Hello. Hello. Am I audible? Okay. तो मुझे ये नहीं चाहिए फेस दिखेगा Hello, should I start? Okay. So very good morning to everybody who have joined us from IIT Bombay campus today. And also, yeah. Hello. Okay. So very good morning to everybody. Greetings of the wonderful day. I am Payal Mukherjee. I'm working as one of the project managers of FOSSEE, IIT Bombay. Good morning to everybody. And I welcome all of you on behalf of my team members of FOSSEE who have joined at IIT Bombay for this program and who all have joined with us virtually. So it's a very special day for the FOSSEE project as we are going to have the industry academia meet on OpenFOAM FOSSEE. It is actually a part of a learning program that was launched in the month of August and will be concluded tomorrow with an online intermediate level workshop on OpenFOAM. So we are hosting this program from IIT Bombay, but we have many people who have joined virtually with us today. I have my colleagues, the senior managers of FOSSEE, Ms. Usha Vishwanathan and Ms. Vinita Parmar. Yeah. I also have my colleagues, Mr. Sumanto Kaur, Deeptanshu, uh, John Pinto, and Evan Fernandez. I welcome the delegates. I welcome the professors of IIT Bombay and Professor Chandan Bose, especially. He has come from the UK, University of Birmingham. I welcome Professor Mahesh, who is the HOD of Chemical Engineering Department of IIT Bombay, Professor Kannan, who is leading the FOSSEE project, and Professor Janani, who is our mentor for the FOSSEE project. Okay. So today we will begin the program with a brief introduction on CFD by Professor Mahesh and Professor Kannan. Then we'll go ahead with the talk of Professor Janani on CFD OpenFOAM efforts of IIT Bombay. Then we will have talk by Professor Chandan. And then we will launch the advisory board of OpenFOAM project of FOSSEE. And then we'll have the panel discussion, and we will conclude with a closed-door discussion on OpenFOAM on CFD efforts of the CFD enthusiasts. So here we go. We are starting the program. I welcome Professor Mahesh Tirumkodulu of the Chemical Engineering Department of IIT Bombay. So please come on stage.
Good morning to all of you. I was going to say very warm welcome. In fact, the weather is slightly cooler than. Yeah, thank you. So welcome to all of you to the IIT Bombay campus. I'm extremely happy to know about the FOSSEE OpenFOAM, the symposium or the workshop that we are having. First of all, I would really like to congratulate my colleague, Professor Kannan Maudgalya. I'm always amazed by the amount of work that goes on under FOSSEE and also the spoken tutorials. And he keeps telling me of the various activities. I've known about the other softwares, but today when he is discussing about his plans for OpenFOAM, I'm not surprised, but again, I'm amazed. The amount of energy, the amount of work that goes on under FOSSEE itself. So thank you very much, Kannan, for this wonderful, wonderful work that you're doing. I'd like to also welcome Dr. Chandan Bose here. He's an expert in OpenFOAM. Probably there's no better person to in fact run this or lead this workshop than Dr. Bose. He did his Master's and PhD at IIT Madras. Now he's a faculty at University of Birmingham. I'm very happy that he has taken his time to come here and be part of the FOSSEE OpenFOAM workshop here. And we hope to see him more often on campus. Hopefully that will come through. I also welcome our colleague, Professor Janani and Professor Samir Jadhav here. Both of them have been very active in the CFD community here. They have been active using OpenFOAM. So while we were discussing about CFD in general and specifically in chemical engineering, I was making a list of all my colleagues who work in CFD, and there's amazed at the number of people who work, my colleagues. So chemical engineering is about 42 core faculty, another 8 adjunct and visiting faculty. So we're close to 50. But out of them, I was seeing who all work in CFD. For example, Amol Subedar, young assistant professor, works in lattice Boltzmann simulations, looks at multi-phase flows. Jason Picardo works in nonlinear fluid dynamics. He also does simulations, looks at polymer flows and turbulence. Partha Goswami works in particle-laden flows, again, particle-laden flows and turbulent flows. He does DEM, DNS, and CFD DEM. Devang Khakkar, he works very well known to all of us, works in granular flows. He uses CFD DEM. Rochish Thavkar, electrohydrodynamics. He has written his own BEM code, boundary element method codes. He also uses, I think, COMSOL sometimes. So his students would also benefit from OpenFOAM. Ratul Das Gupta, interfacial flows and stability. He uses JERIS, again, another open source code, that's CFD, of course. Samir Jadhav works in the area of microfluidics. I know that he's been using COMSOL he's used COMSOL in the past, but maybe now he's started to work in OpenFOAM. Professor Sunthar works in colloidal systems. He does, I recall that he was involved with a company who were using CFD to predict flows in arteries, looking at heart problems and so on and so forth. Professor Sayantan Datta, who has joined us very recently, does multiphysics modeling. You met him this morning. He does CFD. He looks at problems again in biology, looking at cell deformation in flows and so on and so forth. My own work also involves fluid dynamics. I work in the area of atomization, looking at stability of thin liquid sheets, breakup, and also coatings. Again, these are areas which involve CFD. I tend to write my own small codes. I use Julia, again, an open source code. So there is a very large community just in chemical engineering. Of course, in mechanical engineering, there is a very huge community. In aerospace, there is a huge community. So I only see this as a beginning where IIT Bombay, especially through the FOSSEE project, will become a driving force for spreading OpenFOAM, not just in the institute, but across the country. So with that, I congratulate all of you and really look forward to many big things coming out of this collaboration. Thank you.
Good morning. Is it okay? So we also have our team members from Spoken Tutorial. I welcome them as well. So welcome again to everybody. Really delighted that you could come. And I also welcome the online participants. They are from different parts of the country. And we have some expert talks as well remotely. To give a brief background of some of the work we do, we have two projects. One is Spoken Tutorial, through which we train a large number of people across the country. We train something like 8 lakh students a year. Okay. So in that sense, OpenFOAM Spoken Tutorials are used to train students who are interested in CFD to learn OpenFOAM. And we have always been wanting to train them, showcase them, and offer them to the industry or to the research community. Not just IIT students, in fact, mostly students from outside IIT Bombay, outside the IIT system. So that is spoken tutorial, provide basic training. Then FOSSEE comes over and then it takes in specific areas. For example, it could be OpenFOAM for computational fluid dynamics. It could be Scilab, which is an alternative to MATLAB. It could be Python, which is a very popular software. We promote Open Modelica, DWSIM, which are amazing flow sheeting software, DWSIM, used in chemical industry. We have R as an alternative to SPSS. So we have various software that we promote. We promote also hardware, Arduino, for example, OpenPLC. Some of these things are very important for college, for example, also useful in industry. And our objective always has been, can we, like I said about OpenFOAM, showcase the contributors from various colleges, train them to the level of, because you can say that NPTEL, for example, is something that is created by IIT faculty and given to students. Whereas in FOSSEE, what we try to do is, we try to train the students to the level of contributors that they can contribute. Not just here, staff members, but students across the country. So for example, we have something called Scilab Textbook Companion, in which 1,000 students across the country have contributed Scilab code for 1 lakh solved examples from some 630 textbooks, standard textbooks in science and engineering, for example. So that means they are known by people all over the world. This software DWSIM, for example, which is an amazing alternative to Aspen Plus, which we use extensively in IIT Bombay. We have 270 flow sheets developed by students across the country. Okay, in fact, a friend of mine who was a president in L&T said that they actually could use it because oftentimes they go to industry to bid for projects and they have to do some initial computing, and they don't want to invest because they may not even get the offer, the contract. So they said that the DWSIM flow sheets created by students across the country will be useful. Another interesting thing is the DWSIM developer, who is a Brazilian, he embedded a link to FOSSEE on their software, which means million users who use DWSIM see a tab called FOSSEE. They click it, they get all the 270 flow sheets. There, somebody from SVNIT Surat, for example, they had contributed, so it's available. Somebody who has contributed from Ecuador, for example, their flow sheet is available with a URL. That means it's showcasing their talent. And some of our students have used this for higher studies. There was a student in Trichy who applied for, I think, NIT or Sastra, one of those. He applied to Rutgers for TA-ship. And they asked him, how do I know that you know programming? So he sent this link to Scilab Textbook Companion and he got the offer. Okay. There was a student who got an internship in Japan. In fact, one of Janani's students got a job in one of the multinationals. So that way we have a large number of cases. In fact, I forgot to mention eSIM, which is an electronic circuit design software. In fact, Sumanta is a proponent of it, and it was developed at IIT Bombay by piecing together KiCad and NGSpice, okay, with our own various other additional features. We are in the process of developing a GUI for OpenFOAM, and that will make it easier to access. That's one of the complaints that people have, that we have to write a script. It's not, click and play, something like that. There is definitely a benefit in doing it because you understand what is happening. But on the other hand, it makes it easier for some people. So there are a lot of other projects happening. We are developing a front-end Simulink-like environment for XCOS like thing for Scilab. Maybe that can be extended to Octave, Python, Julia, and things like that. These are all, some of them are in research topics. In the OpenFOAM area, CFD area, what will be nice is we have a project called research migration. If we can get every PhD student who works in this area in the country to contribute one research migration, and we have an annual meeting of them coming and presenting what they have done, that will be a fantastic thing. That's where the industry people can also come and meet them and say, and meet their potential recruits, for example. That will be a fantastic thing that we can do. We are here in this particular thing because we are inviting people, stalwarts from industry and academia to be a part of this endeavor. That we have, at least 1,000, maybe 2,000 mechanical engineering colleges in the country. We probably have about, I believe, 350 departments that teach chemical engineering. We have a large, aerospace, of course. Together, it may be about 2,500 colleges wherein students are studying undergraduate education. So can we empower them? Can we motivate at least one of them every year? That will be 2,500 people, right? Offer them to our industry, and some of them will go overseas. That's also welcome. They are our ambassadors. So in this dream, to help aid this dream, we are forming this advisory committee. So I want to thank all of you for joining us in this, and there are some exciting things, exciting talks planned. People are going to talk from industry and also from ISRO and then defense and so on and so forth, and it is going to be very interesting. So I wish I hope that this will be a learning experience for all of us, and I look forward to it. And I wish this activity a great success. Thanks.
Thank you so much, sir. And now I would like to welcome Professor Janani Shri Muralidharan of the Mechanical Engineering Department of IIT Bombay. She has been leading the OpenFOAM team of FOSSEE all these days.
Am I audible? Yeah. So I'll just pick up from where Professor Khan left. The fact that we are coming up with new initiatives, which is one of this industry advisory board. So I would like to explain the journey briefly and the philosophy of why we are here at this point, right? So when I took over 5 years ago, that was just when roughly Atmanirbhar was really taking off. Most of the industry was now being opened up in the sectors of defense, space technologies. And there was a real thrust that Indian talent has to go forward and develop the upcoming technologies. And we are completely self-reliant and not dependent. So that thrust came to FOSSEE as well, which is playing a big role in helping students, the next future generation of engineers, be equipped enough for this call that the nation has for them. Okay, and OpenFOAM very quickly became the front runner. As several people mentioned here, there are several softwares. So why did FOSSEE opt for OpenFOAM? Why did we invest in OpenFOAM, right? So there are certain capabilities of OpenFOAM which kind of serve the purposes for students to quickly get trained, but also for industry to utilize this talent and do cutting throat or cutting edge technology development, which is what is needed from the industry. So CFD traditionally has been written in C, C++ codes or several codes, and the development years for a full-fledged workable code is several years. And writing an in-house code for every application, for every startup or for every company is not possible. So quickly then the reliance on built softwares, commercial softwares grew, but they became very expensive. They have certain restrictions on usage. Example, nuclear embargo. India is not to do nuclear developments. So some of these softwares not made available for us. Okay. So there is severe limitations, both globally driven as well as in-house development time was too long. So OpenFOAM had this perfect bridge that it had inbuilt softwares, inbuilt codes ready to do advanced applications for industry, but it also had the capability of a well-written code where you can go into code and modify things. You can adapt it to your more innovative applications of physics that you want to implement. Okay, so we wanted to adopt OpenFOAM, teach it to students so that they are equipped, but also train industry people, industries, companies to take up OpenFOAM so that they are recruiting and they can meet their goals. Okay. And as part of this, if students have to learn, then faculties across the country need to engage with them. Okay. So IIT Bombay can be a hub, but if we try and train the entire population, we would not be able to do that. We need the help of faculty right across the country to be able to teach OpenFOAM. So with this idea in play that there is actually an ecosystem that we have to build, FOSSEE went forth with certain initiatives that we had in mind, okay, which were named by Professor Kannan. Okay, I will ask, can you open up your FOSSEE.in website? Yeah. So with this background in mind, I will just walk you through some of the initiatives that we had started as far as FOSSEE.in is concerned in OpenFOAM. Okay, and what are the initiatives? How does it contribute? CFD. Yeah. So one such initiative was actually building tutorials for students to learn right at home, right? So that means we started off with the beginners tutorials, then there is an intermediate tutorial, spoken tutorials, and then we have in pipeline and advanced tutorials in mind, right? We also needed workshops. Why workshops? Because we felt that there is a lot of discussion in OpenFOAM. Okay, there needs to be a community in OpenFOAM for debugging, right? So we need to bring together people who know OpenFOAM very well, who are learning OpenFOAM to get that energy up, right? So we had beginners workshops scheduled. We hold a couple of workshops per year. And we also have advanced workshops on specific applications. We also started engaging with industry, okay, like HPCL. We held specific training for them over different modules so that their specific applications can be trained both in a common material available to the entire audience, but also specific material required by the company and their people, okay? We also trained faculty and they had different interests. So we had different people training different things. So this is how we came up with the spoken tutorials material. We also came up with the workshop material. We also initiated something called the case study project, where you can see online we have several case studies. You'll have to double click it. It's gone. Double click it. Yeah. Are you able to open it? Press. Yeah, you'll have to press. Okay. So the case study project promotes students to try any problem they want. Okay, and there is a list of problems, a database here. Universities, colleges, students from which college have done what. It's not restricted to universities. Industry people can do it, faculty can do it, anybody can do it. So you have a list of different solvers, different community. You'll have to. I don't think it will work in an Apple, but yeah. No. It's CMD. This one. Right. So you can see here we have done several gust response of porous wing, analysis of OWC under wave conditions, right? Fluid solid interaction. So we are starting to get advanced studies. When we started out, we had some basic studies, but we have now moved on to advanced studies. So there's a lot of case studies happening here. Now, we also have internships. So people who have taken our basic workshops, then apply to us with some simple task problem that we assign to them, they do it. And then we select the best ones and we have them over for internships. And what we do with internships is not just restrict them to us. They have the ability to work with people across the country, even in UK. Professor Chandan was guiding a couple of interns for problems of their interest. And we were able to, develop new things. Conference papers, journal papers are coming out of the way. And people even are getting awards, right? So this is not just learning. We are moving into a research phase. And I think this is apt point when the industry has to come in as an industry advisor to tell us, what do you need as an industry personnel? What is the cutting edge technology you need? And we are here to develop it for you. In fact, the faculty right across the country, many of them are sitting here, are willing to put in their time to develop. Okay. So one is the case study project. One is the research migration project, which Professor Kannan mentioned. Case study can be simple problems. Research migration is actually taking a research paper which has been published and replicating it in OpenFOAM and putting it up in GitHub, right? So you have a code that's workable and doable right across the community for development. Okay. The third initiative we have is a lab migration project. Okay. So what we understand from students is they need to get, when they're having lab classes, right? Why use commercial software for it? Right? So I want to be able to run my CFD lab course purely, and whatever problem I want, a flow dynamics problem, a heat transfer problem, whatever it is, right? A chemical engineering problem, a biofluids problem, I want to be able to teach them, right? So problems which can be lab trainable, and this can be for companies as well. You can get a set of problems relevant for you as a training module, right? So these are things that we are doing as what is called the lab migration project. Okay, so so all of the information that you have in this cfd.fossee.in, these resources are available to the general public, okay, and free of cost. So you can engage with us as well in all of this. Okay, so now coming back to one point that I want to tell you, right? We need to understand what is CFD, what is OpenFOAM. So I'll just briefly tell you why OpenFOAM. So OpenFOAM, there are several stages in CFD, and what OpenFOAM allows you to do compared to any commercial software. When you open up a commercial software, you have to just click a few buttons. You cannot change things. There is only limited changeable capability. So in your industry, if you want to develop something, it is a bottleneck. So OpenFOAM very quickly allows you to type equations for your physics in a way that is just 2-3 lines, which in a normal C++ code would be several hundred lines, right? So that means very quickly you can start implementing any equation that you want within a few minutes if you know what you want to do. Okay, and that is why OpenFOAM has been chosen by FOSSEE. Okay, so what we will try and do is today listen to what people in industry are doing for OpenFOAM. Okay, and you can come back to these resources and see if there are equivalent problems available. If you feel some problem in your industry is not being catered to in your research lab, you can pose it to us. Okay, and what we are trying to do is, as he said, develop a GUI. Now, some people are not comfortable with the terminal typing commands view, right? So we are developing a GUI mainly for the meshing aspects of it. Meshing is trying to get the domain calculations done in the domain, right? So you're going to divide the domain into smaller boxes, essentially. But you want to be able to do it the way you want it. And there are some limitations if you are trying to type it in a terminal. So we are trying to first create a GUI for the meshing part of it. We've almost done. Now we're moving on to the rest of the OpenFOAM part of it. Okay. So I think a lot of positive responses we have got for the GUI, because that is really a visual aspect. When you're trying to mesh a geometry or a domain, you want to have a really visual feel of it. And that's what we have created. So that's going forward as well. Okay. So now we have understood that we are training students. We have generated the material, the workshop material. It's now time to engage with the industry. And that is where I think Professor Chandan, with his extensive industry contacts, both national and international, and Professor Kannan with several years of experience with interacting with both the government and the industry, have started this Industry Advisory Council. Okay, and I'm very happy because it's the next step we are moving into. We are engaging with cutting edge research, and today is the start day for that. So I welcome Professor Chandan, and it's the best time, I think. It's the right time. The project now goes to Professor Chandan. He will be heading it, and he will be pushing it into areas where we are yet to explore. And we're very excited about this. Okay. So thank you for coming here today. And I'm very happy to see where FOSSEE is heading towards. Thank you.
Thank you so much. Hello. Okay. Thank you so much, Professor Janani. It was a really very good speech, ma'am. Thank you so much. So I welcome Professor Chandan Bose now. He's a faculty member from the University of Birmingham, UK. So over to you, sir.
Hello. Hello, everyone. I hope you can hear me well. So let me introduce myself first. As Ms. Payal has introduced me, I'm Chandan. I'm an assistant professor of aerospace engineering at the University of Birmingham. And it's my great pleasure to be here. And first of all, I thank Professor Kannan, Professor Janani, and the whole FOSSEE team, and also Chemical Engineering Department for inviting me to come here and actually explore different options where we can head this project towards. And so I would start telling my journey or my experience with working with this FOSSEE project. So I did my master's and PhD at the IIT Madras. And then when I was moving towards my postdoc journey, I came across this FOSSEE project. And basically that was the first point of contact I had with Professor Kannan and Professor Janani. And I actually expressed my interest that this is the one-of-a-kind project which is ongoing in India to spread or promote the knowledge of open source software. So as Professor Kannan extensively explained, that it is not only with OpenFOAM on the CFD side, but we have several open source tools, and the main motivation behind this project or the vision of this project is to spread and promote using open source technologies in a country like India, which is very much growing. So So basically, I am very much honored that I got the opportunity to get involved with this project, to contribute in many different ways, to be engaged in different events, workshops that FOSSEE has organized over the years in the area of OpenFOAM or CFD, which is also my area of expertise in my research area. And so I actually was engaged in all of this event and tried to contribute to the best of my capability as an advisor. But it is a great pleasure that Professor Kannan and Professor Janani and also Professor Manasrita, who were actually leading this project, they thought that I could actually be involved more into this and extend some of the directions of the FOSSEE that has been already taken and has been hugely successful in the country. And we can take this effort and promote this knowledge from India to an international level. And that basically, that is where my visions are. And basically, I am trying to increase the impact of this project. And it's very much clear that this project is very much impactful in promoting this open source knowledge towards the education, to reach to the every students in the domain of CFD, to give them the tools or to help them overcome the learning curve, to learn these open source tools, to get to know the computational fluid dynamics from in more depth, instead of just using more or less commercial tools as part of their education. Apart from that, and particularly why we are here, I think I would make it brief because Professor Janani has really extensively told what is our vision and why we are all here. And that was the discussion we started having, that besides the education in different premier institutes like IITs towards any regional universities and colleges to reach out and promote the use of these open source tools like OpenFOAM, we should also at some point need to understand what the industry in this area or the national research labs in India are in which state they are in using these open source tools. And there are a lot of impactful projects that are going on in India from both the industry sector as well as different national projects, which has a component of fluid dynamics or essentially computational fluid dynamics, which can advance those stages very well. And as we know that in this open source framework, we can develop more without reinventing the wheel of writing all governing equation from the scratch. We can take the solvers, which are very much standard, and then improve it or customize it for any particular project. That is where we want to contribute from the umbrella of FOSSEE. And thanks to all of the faculty colleagues from different institutes and from the industry partners who are here and or who have joined online. And today is the day where we first, before taking our actions in making our visions in real life, we want to hear from you that if we can in any way help you to overcome your challenge, or in any way can we support you to grow by using these open source softwares or open source tools. So I think that is the main goal of this today's program, that after some time we will hear from you that at what stage you are trying to use this open source tool OpenFOAM, and how we can help you or we can collaborate with you to actually achieve the visions that FOSSEE as a project we have. So basically, the point that in my mind is that this advisory board, mainly from the experts from the industries in India and also from some national labs, will help us to actually review our works or our basically work packages that we design in the coming future. So in my mind, and which is of course subject, we all can sit down and discuss at how, in which mode we want to do it, but we should have a regular form of meetings to seek feedback, to tell you what we are doing and in which way we are reaching out both the impact of education and both towards the industry and national projects, and then seek feedback from you to refine our ideas, review it, and then accordingly change of our actions. So that will be very much helpful and useful, I think. So the next point that I want to mention it here is that as a country, if we develop the Indian expertise in these open source tools, in a way we can extend it to an international level, and I think that's where my contribution can be more prominent, because I am now a faculty member in University of Birmingham, UK, and kind of engaged with the global OpenFOAM community as the editor of OpenFOAM journal, or also into different activities such as organizing OpenFOAM workshops, talking to my colleagues who are very much expert and developers in different domain of OpenFOAM. So I want the contribution from Indian students and Indian Institute as a whole, as Professor Janani mentioned, to go or to have a leap from the learning stage to research phase, or to a contributing phase to the real life through the real national projects or through international collaboratory projects, as well as through the industry contribution, and showing the impact in terms of numbers, that how these open source tools or the developed tools within OpenFOAM are actually making impact in real life, and how we can ask expert advice from outside India and also collaborate with them to support us to achieve this aim, to solve the challenges that we can face, of course, towards the learning curve. And towards that, we want to reach to a stage where different developments within India, within different regional university or IITs, that goes to and be integrated in the actual release of OpenFOAM repository. So that is the main aim, that we should have the contribution in an international stage and make it open to the globe, so that people use our contributions or our developments and then build on the soldier of giants, right? So towards that, I think this is the main vision. But what are the mechanisms that are possible that we can contribute to? One is basically, as I said, that we are trying to build a platform to actually make all the recent state-of-the-art developments visible to all the OpenFOAM community, that is through the OpenFOAM journal. So basically through the case studies that we are doing within the FOSSEE project, to the internship that we are doing. And I want all of these Indian students to actually make contribution to actual research level, and then they can publish it and release their contribution or the development, for example, through OpenFOAM journal, so that it reaches to the whole community worldwide, and then it can make its impact. So that's actually one of my main vision for today. So today also, and those developments, how can they help the Indian industry sector? That will be a main aim for today's discussion, to know, for me at least, that if we can connect it through some international collaborative projects to international organizations, or also in international industries. And so there are different mechanisms for that, and we should discuss more on as an advisory board meeting when we will have it, and decide our point of actions. So I think with that, I don't want to really make my talk so stretched. So we have a lot of other talks, but I will be very happy to talk to you in person, informally, throughout the day, and happy to answer any questions that you have. And of course, if I have forgotten to tell something, we will keep discussing throughout today's. So I want to thank again all of you who has come here in person, or who has already agreed to help us, support us as being in the advisory board. And also we will hear more from them about the work they are doing. Thank you all. And at last, I really thank IIT Bombay. I thank Professor Kannan, Professor Janani, the Chemical Engineering Department, Professor Mahesh, to invite me here. It's a great pleasure again to come back one of the IITs and contribute in the smaller level that I can. Thank you very much.
Thank you so much, Professor Chandan. So now we'll move ahead to the launch ceremony of the advisory board of FOSSEE OpenFOAM. So I would like to call on stage Professor Mahesh to do the inauguration. And sir, you please also come on stage. So some of the advisory board members are present with us here at IIT Bombay, and some of them have joined virtually. Okay. So please wait for a second, we'll just launch it. And after the ceremony of the launch of the advisory board, we will have the introduction of all the advisory board members, and that would be done by Professor Chandan. Thank you so much, Professor Mahesh. So now we will move ahead to the introductory part of the advisory board members. I'll hand over to Professor Chandan once again.
Hello once again. So PPT. Where the PPT? Where's the detail? Oh. Oh, okay. Sure. Okay. There are some three dots here. All right. So basically, this is the time where we actually kind of show our appreciation and thank those who actually agreed to support us being in the first batch of advisory board committee members. And we are open and more inclusive. So we have reached out to more colleagues from different industries and different national labs. But of course, being in this committee, they need their own approval process from their organizations. So we are only showing the names who has got the approval at this stage, and we hope to keep on more colleagues from different organizations. So so this is first to say you that we are not going to miss anybody. We are open and inclusive. We want to make this team as big as possible because this is a national project funded by Ministry of Education, and we want to get feedback from everybody. So again, with a sincere thanks from the FOSSEE project, let me try to introduce our advisory board members. So the first member who agreed kindly to support us, Dr. Vivek Vitankar, is a founder director of Fluid Dimensions, and Dr. Vitankar is a visiting faculty ICT Mumbai. He's a visiting faculty ICT IOC Bhubaneswar, visiting faculty on NIT Meghalaya. He has done his postdoctoral research from Iowa State University and PhD in chemical engineering from IIT Mumbai University. He has extensive experience in guiding masters and PhD students, and he is well published and very much active in the research area of multi-phase flows, combustion modeling, reactive flow systems, and many other things. So thank you, Dr. Vitankar, and we really hope that our engagement interaction will enrich the visions of the FOSSEE project. Next, I thank Mr. Pushkar Seth, who is here present with us in person, and he's an engineering technical leader at WebTech Corporation. Mr. Seth holds masters in automotive engineering from Coventry University. He has a extensive 16 years of experience in CAD, diesel engine component durability simulations using finite element analysis, multi-body dynamics, computational fluid dynamics, among others. And he has contributed a lot in the field through his innovation by his patents on heat exchanger durability and his publication of the scientific knowledge. He has also authored a book titled Build Engineering Applications Using Python and Flask, and maintains open source Python libraries. So I think that will be a great contribution, his expertise, by integrating it with our ongoing activities of FOSSEE project. Thank you again for joining us in the advisory board.
I would like to call you on stage, sir.
Please come in.
So I would like to request Professor Kannan to present the memento to Mr. Pushkar Seth.
Sure.
Thank you so much, sir.
Sure, we'll talk. So let us go to the next advisory board member who has kindly agreed to support us, Dr. Manavendra M. De. He is a principal scientist in the system engineering division in CSIR NAL, Aeronautical Laboratory, and also he is an assistant professor at the Academy of Scientific and Industrial Research, ACSIR, and Dr. De holds a B in mechanical engineering from South Gujarat University and MTech in the specialization in turbo machines from SBNIT Surat. He also has a PG diploma in intellectual property rights from IGNOU and WIPO, and PhD degree in applied mechanics, computational fluid dynamics from IIT Madras. It's a great pleasure because we had an overlap in our PhD time in that. So thank you, Dr. agreeing to support us being in the board member. He joined CSIR NAL in 2006, and he is continued to being the principal scientist there, and also he has taken up the faculty position in ACSIR. And his research area includes computational fluid dynamics, and he has achieved many accolades, and he is very much active in this area of research. Unfortunately, he is not present in person today. Like our first advisory board member, he has joined us online. So thank you, Dr. De, again for supporting us. So our next advisory board member is Dr. Joseph Prabhu, and he is a CFD engineer at the Indian Register of Shipping, and he is present in person with us. Thank you for coming and agreeing to support us. Dr. Joseph Prabhu is a CFD engineer with having a PhD from IIT Kharagpur, and he specializes in marine structures, computational fluid dynamics. He is currently work in the research division of Indian Register of Shipping, and he has an extensive experience and understanding of marine hydrodynamics, and his research has led to development of different numerical tools and solver in that based solver for maneuvering dynamics. And his work has been recognized through different publications. He's very active in this area of research, and he is actually very much proficient in both commercial and open source CFD tools, which will be a great add-on to our team, because our vision is not only to promote open source softwares, but also to contribute to the challenges that exist. So basically, we also want to talk to our partners, our collaborators, commercial software complement. So thank you, Dr. Joseph, for agreeing to join us in that board, and I think he will be given a memento by
Dr.
Professor Khanna.
Joseph Prabhu has already published a research migration paper with us. He has worked with our team member Rajdeep Padak on the OpenFOAM GUI efforts. So welcome, sir. Yeah.
Okay, so moving forward, our next member of the advisory board committee is basically Dr. Abhishek Dattya. He's the founder of tech startup Simulagence, and I think he has joined us online. So thank you for joining us, Dr. Datta. Dr. Datta has a PhD in chemical engineering from Ghent University, Belgium, and he also worked as a lecturer in KU Leuven, Belgium, for a few years, and now he is an associate professor in the Department of Chemical Engineering, Izmir Institute of Technology, where he is a team leader of Industrial Flow and Process Modeling Group. His research focuses on energy efficiency for the improvement of existing and development of new processes, resource efficiency involving complex hydrodynamic, cost efficiency, valorizing waste resource recovery towards carbon footprint reduction. So, Dr. Datta will be a great asset to our FOSSEE advisory committee member, and we are looking forward to learn more from him in achieving the vision. Dr. Datta again, and we will interact shortly on. I think he is giving an expert talk. Thank you, Dr. Datta, again. Our next advisory board member, who is a co-founder of a tech startup, CFD Baba, and he has been very popular in promoting a unique venture. He has a bachelor's in mechanical engineering, thermal engineering, and he has actually spent a lot of effort to actually promote the learning of CFD through OpenFOAM, and he has invested more than 4,000 hours working with OpenFOAM, which is an impressive number, and I hope that you will continue to contribute to the vision and the action plans that FOSSEE will decide in the coming days. And he wishes to spread as much CFD application knowledge as possible, and one of his interests is through promoting the open source knowledge, which is in complete synergy with the motivation or objective that we have within this FOSSEE team. So we welcome you, Mr. Nikhil, and thank you for joining us. And I will just invite him to come here and take a short memento from FOSSEE team. So next in the list, we have Mr. He's a researcher at TCS Research and Innovation, TCS Innovation Lab, and he has kindly agreed to support us by being in the advisory board CFD-OpenFOAM. He does not directly use OpenFOAM in his work, but we want to know more about him, how they use CFD in the TCS Innovation Lab, and how we can kind of contribute by promoting open source knowledge. And he will be a great asset for us to tell our students how CFD is being used in real life and in industrial sector in the scenario of India. So Mr. Chakravarti has a Bachelor of Engineering in Power Engineering from Jadavpur University, and he has an MTech in Ocean Engineering and Naval Architecture from IIT Kharagpur. Also, he has an MS by Research in Mechanical Engineering from Thermal Group of IIT Madras. He has been awarded as Eschenbo Scholar as Texas A&M University, where he extensively worked on turbulence modeling, and he has also was a VSRP fellow at the Clean Combustion Research Group at KAUS, Saudi Arabia. So he is very active in the area of CFD, and currently I guess he is more focused on multi-phase flows and other in-depth research areas, and we will be greatly gaining knowledge from him in the application of CFD, computational fluid dynamics, in the real industrial sector, and how we can contribute by promoting open source knowledge in the Indian industry. So thank you, Arnab, and thank you for joining us. Unfortunately, he has joined us online, and we are looking forward to interacting with you more. We have with us Mr. Manish Vasme. He is the director at Fluent Engineering Solution and CFD Consultants India. And thank you for joining us. And Mr. Vasme is an experienced computational fluid dynamics professional with expertise in solving complex engineering challenges across industries such as HVAC, water treatment, energy, and more. As the technical director at CFD Consultants India, he has led numerous high-profile CFD projects, delivering innovative solutions to improve system efficiency and safety. He is an alumnus of NITK Surathkal, and he is dedicated to advancing computational modeling techniques, and we are happy to collaborate with him, and he will be a great asset to our advisory board member. I kindly invite him to the stage to get a memento from Professor Kannan.
Please come on stage.
Thank you. So we have our next advisory, Mr. Saurabh. He is a lead HDFE and SCS analyst in John Deere India Private Limited. Thanks for joining us, Saurabh. And he is, I think, has joined us online. Unfortunately, he could not come here in person. So Mr. Mukhopadhyay is an accomplished researcher currently pursuing his PhD at IIT Kharagpur, where he also completed his master's degree. And he has an eight and a half years of experience in agricultural product development, and he has developed a strong expertise in areas such as computational fluid dynamics, DEF, machine learning, and fluid structure interaction. And he is now working on the design of different automotive vehicles, I think, in the John Deere India Private Limited, and using computational fluid dynamics and other techniques actively. And we will learn a lot from him again how computational fluid dynamics is being used in real industrial sector in the India. And we look forward to interact with you, Saurabh, more. Thank you again for joining us. So we have our next advisory board member who has kindly agreed to support us, Mr. Advait Gupta. He is the founder and CEO of Pandub Applications Private Limited. Mr. Gupta has a BTech from NIT Warangal and a master's from Stanford University. And he is very, very much active in promoting the knowledge of open source tools like OpenFOAM, like FOSSEE. So we have a lot of synergy and he promotes it through his organization's Panduv applications, and he has contributed to various industrial consultancy projects. He has also worked with national labs, particularly in the area of additive manufacturing. So basically, it is a great opportunity for us to interact with him as within the advisory board member, and to collaborate more on how to promote the knowledge of OpenFOAM as an open source CFD tool in India together. And that's basically the vision FOSSEE has, to bring all the like-minded synergistic enthusiasts who want to promote open source tools to bring under one umbrella. So thanks Advait, thanks for joining us. I guess that he has joined us online. Yes, so looking forward to interacting with you more online, and probably we have some opportunity to meet in person soon. Thanks Advait. Right. So next, I actually invite one of our faculty colleague, Professor Dheeraj Garg, to come here and take the memento from Kannan. He is a very active faculty colleague with us. So this is something I wanted to mention, that this advice whom we are including or onboarding to support us today are new members. But apart from that, we have multiple professors from different universities and institutions from India. And so first I would request Professor Kannan to give the memento to Professor Dheeraj, and then I will. So with that, let me also kind of mention who are our faculty colleagues from different institutions and organizations who are actively participating in this FOSSEE project. They are mentoring our students. They are actually taking the time to help them to go through internships, to contribute to the case studies. As I have already introduced Professor Dheeraj Garg, he is from Shiv Nadar University. So thanks for coming and joining us. And we have our other faculty colleagues, Professor P.R. Naren from Sastra University. We have Professor Manimaran R from VIT Chennai. We have Professor Hari Krishnan S, Cochin University of Science and Technology. He is one of my close friends. We did PhD together in IIT Madras. We have Professor Raghavendra Gupta from IIT Guwahati. We have Dr. Abhishek Datta from, I already told, he is at Izmir Institute of Technology, Turkey. Professor Tushar Chowrasi from MIT Pune. Sorry if I have pronounced it wrong. Professor Sati Rajesh Reddy from Shiv Nadar University. So these are the faculty members. Without their help, it is very difficult to contribute over the years to train the students, the talented students that come to us to actually know and learn, overcome the learning curve of this open source tool. So thank you very much. Thank you all of you to contribute, and we hope you will keep contributing to this project. Thank you.
Actually, Professor Tushar is on his way. He will also join us in person at IIT Bombay.
All right. So yeah, looking forward to interact with all of you, either in person or online. And with that, I hand the mic over to Payal.
So now we'll go ahead with the expert talk session. We'll have a series of expert talk by the members of the advisory board that we have launched just now. So give us some time to make the setup. Okay, so now we will start with, just a second. Okay, so now we'll move ahead with the keynote talk for today. We have Dr. V. Ashok from VSSC ISRO. So I hope he has joined by now. Dr. V. Ashok, are you there online?
Yes, I'm there, very much there, yes.
Sir, could you please switch on your video as well?
Yeah.
Okay. so much for joining, sir.
So shall I share my screen?
We are delighted to have Dr. Ashok, Associate Director, VSSC. Thanks to contribution of people like him, ISRO has been making, amazing things, And in fact, whenever I give a talk on either FOSSEE or spoken tutorial, I always start by saying that how ISRO's missions are not cheaper than somebody else, whether it is movie Gravity and so on and so forth. All these have been achieved by silent contributors like Dr. Ashok. We are delighted to have Dr. Ashok to address this audience, and there are many students who are joining also, research scholars, and we look forward to benefit by your wisdom, Dr. Ashok. Thank you.
So thank you, and so I would in my half an hour talk, I will briefly cover on the CFD applications in space missions. And I am extremely glad that IIT Bombay is looking on the OpenFOAM open source software platform. In fact, in Vikram Sarabhai Space Center, we do use OpenFOAM. We use DSMC foam, which is the direct simulation Monte Carlo foam for the very rarefied flows. On the other OpenFOAM open source software, you use SU2 for our compressible viscous flows. But then we also have our own codes, which I will cover in my talk. So I'll briefly cover on the various applications so that you will get a flavor of what are the types of problems which we do. And as you know, the space system technology is multidisciplinary. Of course, it has mission design, propulsion, aerodynamics, thermal design, etc. And so the CFD comes mainly in propulsion, aerodynamics, and thermal designs. Of course, and this inputs goes to structures, navigation guidance, etc. I myself have been the aerodynamics background, and almost 35 years I spent in VSSC, and I had worked on the computational CFD code development and also on its applications. So now, if you have to sum up the various challenging problems in the launch vehicle missions, this is one slide that will tell you which are the very interesting problems which are there. Right from the liftoff to the injection of satellite, we have various problems which are there. And if you see at liftoff itself, we have the jet interactions with tower interactions and wind dispersions, and there are a lot of issues there also. And then moving on to the atmospheric phase of flight, if you see, there is where you have the propulsion structure, control aero interactions, and then we have the shock oscillations, unsteady loads, base heating. These are all in the atmospheric region of flight. And then subsequently you have the closed loop guidance, etc., and injection into the orbit. So we will mostly focus on some of the interesting problems during the aerodynamic phase of the flight. And if you see, if you want to sum up the problems which are there, on the left hand side you have the aerodynamic problems, and on the right hand side you have the aerothermal problems. You can see that there's a compartment venting and the shock oscillations which cause the buffet. That means we have to quantify the unsteady forces. Of course, this particular aspect is still a very challenge for CFD because still we rely on experiments. And then there is also the aerodynamic noise which is coming on the strap-on shock interactions. Then there are some jettisoning rockets which will be used for separating the strap-ons, and the lift-off aerodynamics. These are some of the important things which are and multi-jet interaction and aero loads on nozzle. So these are some of the things but we have also special problems like the re-entry aerothermodynamics, flow and combustion studies in air-breathing engines, dynamic stability of re-entry capsule. This is one of the very interesting problems. That is, we have to calculate what is the dynamic stability of this, what is the aerodynamic damping that is coming when there is oscillations of this crew module during the re-entry phase. And we also have the two-phase flow with with combustion. That is also a very interesting problem. And as you know, in CFD, we solve this Navier-Stokes equation, and I don't have to tell this audience about this equation. This is very, very familiar, and this is on a structured grid, on a re-entry capsule. And as you know, these are the very steps involved in you generate a mesh, and then you calculate the cell areas, volumes, calculate the inviscid fluxes after reconstruction, and then you have the viscous fluxes. You march in implicitly or explicitly satisfying the stability criterion, and update till you get convergence. So this is a very standard finite topology. Now let me tell very briefly about some of our solvers which we have. One is the parallel aerodynamic simulator, which is on a Cartesian mesh, so which has a very automated Cartesian mesh, and which has a K-epsilon turbulence modeling, inviscid fluxes using an approximate Riemann solver. We use the primitive variable Riemann solver, and viscous fluxes by central differencing. We have a second order upwind with the min mode limiter, and it is fully explicit. It's not in implicit mode, but it's parallelized with multi-threading on GPU platforms. And this code is now running in various organizations like ADA, ADE, DRDL, etc. And we also use this. This is a very workhorse code for us, because very fast we can generate the mesh and give the results. And these are some of the developments which we did on this. And we have now included the multi-grid technique on this. The multi-grid acceleration is there, multi-core, multi-GPU version, and multi-grid CPU version. And so we have done special techniques in this, which actually enhance the improvement of even the CPU itself. Because as you know, all these CFD codes are memory bound. And so if you want to use the GPU platforms, we need to have a single instruction, multiple data type of architecture. So we need to group these cells before doing the computations. That means we have separate, these are the computations are done group by group. We have partial cell, then boundary air cells, partial cell whose neighbor is split, an air cell whose neighbor is split, partial cells whose neighbor is split. They're all at different categories, and so that you get maximum benefit from the GPU. And by doing this computations, the CPU performance itself has improved by something like 3x, 4x. So that is the advantage you get in the GPU. And we also have an unstructured based parallel land solver, which is aerospace vehicle aerothermodynamics called Pravaha, which we have very recently developed, and we have worked on for the past around 5 years. And this also we have, but this is not on a Cartesian mesh. This is on a unstructured mesh. So, but the mesh generation has to be done by some mesh generation tools. And with this also we have all these various types of solvers like AUSM, AUSM plus, Rho, HLLC, Rezonov schemes. But what is the challenge here is actually, if you see, to build robustness in the CFD codes. That is where the real things comes. And in fact, if you are using these solvers which are open source, you may find it a difficulty in those areas. Because what happens in industrial framework, suppose you want to do a very fast computations, your mesh may not be that much, very accurate. There may be the quality of mesh may not be that good. There may be more skewness. But then your solver should be capable enough to handle those and take those things into account. You may lose accuracy. Instead of getting maybe coming to 95% accuracy, you will get 90%. But in an industrial framework, that's okay, because when we explore various configurations, we want to weed out some configurations, so even 90% accuracy is good enough. What is important is you get very fast results, and you should be able to automate and couple with optimization techniques. So that is the importance of this. That means it's very important to build robustness in the solvers. And we have done that using some special techniques. And so these are some of the applications which we have done here. And this is on a crew escape system with all those jets. And we are also on the reusable launch vehicle technology demonstrator. And we are also having something called the Spices workshop. And, we converted during this, during symposium of applied aerodynamics, which are going to be converted, done in December 12th, where we put a standard problem and ask the CFD groups to solve this, and then we meet together and see how good it is, and the experiment results are not revealed. So like that, we are going to have a hypersonic air intake on December 12th. The geometry is given to all the organizations. There are something like 15 organizations going to participate, and we will see how the results are with comparing with the experiment results. Now let us see some of the applications, and this is on a typical flow field at the GSLV at Mach number 0.9. You can see a normal shock, terminating normal shock. Now these normal shocks will start oscillating and will give rise to acoustics. That is where you have problems in getting from CFD, which you need to get experiments. But you can very well get the forces and moments from this CFD techniques. In fact, it is like a fluid dynamic zoo. You have you start with laminar, it becomes turbulent, then you have attached flow, then you have separated flows, you have shock wave interaction, expansion fan. vortex flows, base flows, large scale vortex structures, flow entrainment, reverse flow, shock interactions, barrel shocks and potential core. All those things are there in this, so it's like a fluid dynamic zoo you can see in this particular flow field. And then that's what I told here. This is a terminating normal shock on the cylinder of the GSLE, this one, but the real challenge is to get back what is the acoustics on this. Now, these are some of the challenging flow problems you can see here. We have certain things which are already carried out. This is RLV reusable launch vehicle technology demonstrators, scramjet, GSLE Mark III, two escape system at the pad abort test, and we had very recently done the landing experiment, the Chandrayaan-3, the test vehicle which we have done recently, the Gaganyaan, and then we have the future, the RLV orbiter and the scramjet. The airframe integrated scramjet with an air-breathing engine, which the thrust minus drag positive is a very, very challenging thing. It is something like an S51. And high angle of attack aerodynamics for RLE landing experiments, multi-jet interactions in Chandrayaan-3, and also the dust that is coming because of the reverse flows, the test vehicle with the crew escape system, and we have also challenges in one mission of the launch vehicle, Mark III, wherein we have the two-phase flow with the sloshing involved, and winged re-entry of RLV orbiter. Parachute inflation aerodynamics is one of the very, very critical things. What happens during the first few seconds when the parachute is getting inflated? Are you able to do an FSI, full structure interaction, and get the loads and see whether everything is fine or not? Then inflatable aerodynamic decelerators, these are things. And on the bottom side, you can see our capability in terms of facilities. We have now going to have capability of wind tunnel capability from 0.2 Mach number all the way to Mach 12. And we also have going to have set up a 2 petaflop supercomputer very soon. And this is some of the very typical things you can see here. This was the earlier configuration of the launch vehicle Mark III, which had a straight nose cone and also the strap-on also straight. And then on the left side, we improved upon it and then made it to a standard nose cone. What I want to stress is there is on the strap-on to nose cone attachment, there will be a vortex that will be shed, and this will give rise to larger acoustic levels. So you can see this is the case with the straight nose cone, and the other one is the standard nose cone. And this was actually giving us larger acoustic levels. And this is on the cut plane. You can see there a typical the shock vortex interactions, which is enhancing the acoustics downstream. And this was what we got. We measured it actually, and we got benefit by doing this. We had almost 9 dB extra we got in the aft adapter just behind the strap-on nose cone. So this is the benefit you get by doing this such studies. Is an unstudy, of course, is the Euro study. And the way in which we do the aerodata methodology is, of course, we have this is the flight configuration. We have the wind tunnel test. And of course, the wind tunnel will not be same as the flight configuration. So there may be some differences. So that differences called the geometry correction is what the CFD does the corrections. And then suppose there is a jet. So you cannot do experiments with jets. So we either do it with a cold flow experiment in jet and a hot flow from CFD, and these things are getting accounted. That means you have a basic data from wind tunnel, you add the corrections of geometry and jet from CFD and give the flight data. So this is the way in which you generate the aerodynamic data for the entire vehicle, which is used for the control studies. So this is the typical load distribution which we give. That is what is the load, it's a meter per radian, and this is what is going into the structural design. In fact, if you see, all the structural designs are initially done using CFD and then only verified by means of experiments. That means the CFD has to play a very important role right from the design phase to actually finalize what should be the structures. So this is another important aspect of the CFD. Then another thing is on the base heating of the launch vehicle. As you know, that when the launch vehicle climbs the atmosphere becomes, the pressure drops, and so the jet pressure ratio, that is the exit jet pressure to the atmosphere pressure, increases, and the jet plumes. And when you have this pluming, what happens is that supersonic flow, like you can see from Mach 2.5, there's a jet-jet interaction. And, that jet interaction causes a shock. And then what happens is there is a reverse flow that is coming here. So the oncoming flow is not able to penetrate those shock interaction. So there's a reversing, which gives rise to heating in the base. And this has to be quantified, and we should define the thermal systems for this. So this is what we first quantify, what is the heat flux that is coming because of this, and then do special experiments to design those TPS. So this is the one typical applications. Then another interesting thing which I would like to tell, in one of the flights of GSLV, we had the first flight where, when all the strap-ons don't generate the sufficient thrust correctly, around something like don't generate more than 98% or so, they will cut off. So one such thing happened, and one of the strap-ons, although the cutting off has happened in all the 4 strap-ons, but only the fire happened in one of the 4 strap-ons. Then the question was, why only happened in one? Because you have a fuel-rich propellant that is coming out and mixes with the external oxidizer, oxygen-rich, and then there is a burning that is happening. So we did the simulations, and with the wind prevailing at that time, and we can see that there is a vortex found in at that particular strap-on, and because of the buoyancy, it comes up, and that's how you see only in one the plane in one of the strap-ons. And this is another thing, just on the launch pad, which you are seeing the jet flows. But what happened at around 2 seconds later, at 5 meters, you can see a reverse flow of jet that is coming between the umbilical tower and the launch vehicle. And this particular simulations was done. We wanted to see why this is really happening, and so we had the CFD simulations done at this particular conditions. And yes, indeed, we found out that there is a reverse flow of the L40, that is the liquid strap-on is reversing, and we want to know why this is happening. So what really happened, this is on the launch pedestal. So when there is the jet that is impinging, it flows in all directions. Now we can see here that there is a condition where you have the launch tower here. So this is not allowing it to go in this side. So if you take a cut section in this, what we are seeing is there is a fountain that is formed. So because of this fountain jet, we are seeing that there is a reverse flow that is happening. So how do you prevent the fountain jet? You just put those diverters there, and then we indeed did that. And then we can see here that we are not seeing any reverse flow. This was what was done, and it was done way back in the year 2003 itself. But I just wanted to see, because this is one very important applications, where CFD is able to give solutions to this. And this is what you can see on the plant side, because the diverter, you are seeing that the jet is getting diverted. Now there is also another problem is on the L40 gimbal. See, when these nozzles are the gimbal, and that's how the control is getting activated. Now we need to find out what is the load, aerodynamic load on the nozzle, because the control system needs that input. But then when you do the internal experiments, you do without the jets. And we found out that if you do without the jets, you get very large load, and that has a problem with the control system. So when we did with jets, we could find out that the loads were indeed very less. And that's what you can see here in this graph, where experiments were done without jet, and we do the CFD, and we also do CFD without jet, and say, okay, when we have a confidence that is built up without the jet, and then you design for this with jet, and then we also got a comparison from the flight, and we really got a good comparison of the moments that is coming because of this. So this is another application which I wanted to highlight. And these are the several types of steady pressure measurement that is done on a launch vehicle. And we see, at various parts, I'm just showing them typical match that is there. And these are all fairly, tractable problems at different places, where on this portion, on the red portion, we can see here. And this is on the, at transonic Mach number, we have a sudden dip in the coefficient of pressure. Anyway, these are all well captured by CFD. There is no issue. And this is on the boat tail, where you have a separated flow. And there only we have some problems, because when when the flow is separated, you have the issues of getting the pressure very exactly, unlike the attached flows. Because it already depends on the turbulence model which you employ. This is another important thing, is on the stability of the jets. Now you can see here, this is without jets. But as you know, when the launch vehicle goes up, there is a jets are there, and that really affects the stability. Now we can see how we compute the stability for this. You do a CFD with jet off and with jet on, and what you can see here is up till the base, there is no difference. But at the base region, you can see the jet-jet interaction alters the flow field. And because of this, what really happens, it becomes really unstable, more unstable. And this is what you can see, the palettes, which shows the effects of the jet-jet interactions at the supersonic Mach numbers. And that's what we see it. And we really notice that there's a decrease of CN alpha by 14%. And XCP was moving towards the nose, that is making it more unstable. You can see the center of pressure location without jet and center of pressure location with jet. Well, this is another application which you wanted to show, was on we put a flat shroud on the base of launch vehicle Mach 3, because what we found was that the jet, we thought that flat shroud, we are seeing that there's a flow that is getting separated and reattached on the nozzle. And this particular problem wanted to be, alleviated. So we put a flat shroud so that, it just doesn't reattach on the nozzle. And that's what you can see here without the flat shroud. And with the flat shroud, you can see very clearly how much the pressure reduces on this, and thus reducing the loads on the gimballable nozzles. And this is all the experimental validation for that. This is another thing which I wanted to highlight. Of course, there is also unsteady problems. That is when you start, when you start the engine, there is the nozzle will be having a closure. That closure breaks, and there is a jet that is coming out, and there is what is called the jet overpressure has to be quantified, and all these subsystems of the base has to withstand that. So this is one such unsteady simulation which we carried out to quantify what is that, and these thermal boots are designed to handle that. Well, this is on the Chandrayaan-3, which I wanted to tell, and so this is the this one, which all of this I did not have to delve in detail because it's quite popular, and these are the several types of firing which you do, and then on the Chandrayaan also, and this is the approaching this. And but what I wanted to tell was on the fluid dynamic aspects. Now you can see the jets are fired, and when you do this, there's a jet-jet interaction that is coming, and which causes a reverse flow. And we need to quantify the heat flux that is there, and all the thermal protection system has to be designed for that. And we have done computations for that. And the earlier things, when you have two jets that is firing, you have the reverse flow of the dust that is coming will get lifted up. And so this time in Chandrayaan-3, we had only single nozzle. We did not have the two nozzle just to alleviate this particular dust problems. Well, this is on the winged re-entry vehicle, and here you can see that we have the various phases: the hypersonic phase, the terminal area energy management phase, and approach and landing phase. And this is a typical case where if you do a hypersonic chemically reacting flow, we can see the perfect gas and the real gas. The real gas is showing the very less shock standoff distance. That is mainly because when you have a very high temperature at the stagnation point, when the oxygen starts dissociating at 2000 Kelvin, nitrogen started dissociating at 4000 Kelvin. And when the dissociated gas, they will become cooler. When you have cool gas, you can push more mass in the same stream tube, then that's how the shock gets closer. So these are all the phenomena that is there. And we had also done various simulations to quantify these heating levels. Of course, the wall also plays an important role. We have something called the catalytic wall and non-catalytic wall, which means that the dissociated species called the O, the nascent oxygen, and N, they can recombine at the wall and dump the heat of diffusion and the heat of that is the joining, that is the dissociation heating will get dumped up on the wall, and so that has to be prevented. And so we have special materials like RCG, which will prevent this recombination of the species, recombination of O to O2 and recombination of N to N2. And these are some of the things. And there's also something called the gap flow, because these elements has to be moved and there will be a gap. And when you have this gap in hypersonic flow, what is the gap heating? This has to be quantified correctly, and we have to design the seals for this. And these are all some of the RCS that is fired, and in the hypersonic flow, how the RCS affects the aerodynamics of this also has to be quantified. And these were all done using CFD. And this is on the very landing experiment which we did, and that is the approach and landing phase, and that portion has been done now. And autonomous landing has been enabled. And for this also, we need to generate the aerodynamic coefficients for the control design. And here also this was done, and this is with the helicopter downwash. We had done first initially in the MI 17, and now we have done later on with Chinook. And this is the downwash of that, and seeing that the downwash doesn't affect the helicopter. And all these CFD computations were done to quantify this. And this is at various angles of attack when it is coming down. And what should be the limiting angle of attack and what is the stall angle of attack, all those things we had computed. Of course, we also done several internal experiments in IIT Kanpur and NAL. And so we had seen that this is how the wing vortex and the vortex breakdown happening at what angle of attack. So these things were quantified using CFD. Now coming to one of the very interesting problem is the moving unsteady problems. See, we do a heat shield separation. Now, normally what we do is now when we should be able to minimize the cost which we are doing by doing this testing. Now, this heat shield separation occurs at almost at rarefied conditions near vacuum. Now, as you know that none of the launch vehicles we do without testing. So the philosophy is test as you fly and fly as you test. So if you want to test as you fly, then you have to have a huge vacuum chamber to accommodate this heat shield, and then we have to separate on that, which costs a lot of money. And so what we have done is, why not do in the ground and quantify what is the effect of the atmospheric this one, and then see what will happen for the flight. So that's what was done for this particular condition. So we did this heat shield separation on the ground. And on the ground, what happens is, so this is a moving body problem, which we have done using a Cartesian mesh. So this is a Because this I did not go into details of this, so we have to have a special type of Riemann problem to do this, and some cell merging and moving boundary techniques are there. But what I want to tell in summary is, this is the heat shield that is getting separated, and so initially you have a very large acceleration. So we have the velocity that is given as an input, and with this velocity as a moving boundary as an input, when we compute, what you can see here is how at 8 milliseconds, 14 milliseconds, we can see a pressure drop, and this pressure drop and what is measured is exactly matching. And because of this pressure drop, there will be a collision, and you will find that there is a collision, but this will not happen in vacuum. So that's what we found out, and so we are now doing away with all this thing, because but Ariane does with the rarefied conditions, which cost a huge money. So this was debated in way back in those years, and then we avoided this by quantifying from CFD. This is another typical things on the inflatable aerodynamic simulator. This is coming down. We want to recover some objects by this aerodynamic simulator. The flow is from right to left, and you can see very high angles of attack, high Mach numbers, complex flow, shock interactions, high aero heating, and all those things which we are done. And we are seeing the matches with the commercial code Fluent and our own code Pravaha. And so normally what we do is we have commercial codes also, mainly because there are many conditions where you cannot do experiments. In such cases, you should have minimum code to code, at least 2-3 codes should have almost the same result. So that is the way which we go ahead with our design process. And this is the sensitivity of turbulence model on the heat flux. And this is another interesting thing on the how much more time I have? Another 5 minutes, or can I get a feedback? Hello?
Hello, sir, am I audible?
Yes, you are audible.
Sir, another 5 minutes will be fine.
Fine, okay. So this is on the scramjet vehicle, which we wanted to demonstrate. And so this particular thing, and this experiment was planned for 5 seconds. So we have a design emission with this pillbox. In fact, this is a low-cost mission using sounding rockets. So this is what was done. And okay, this is got mixed up. So for this, we need to do the chemically reacting flows. And so this is one of the Leher cylinder case where you have a stoichiometric mixture of hydrogen and oxygen at Mach number 3.55. What is interesting to note is, although there is a temperature rise that is happening because of the shock wave, but the combustion happens only downstream, which means that there's a finite time for the combustion to occur. So this is a typical case of validation of a non-equilibrium chemically reacting flow. A Leher cylinder of 15 mm dia is a typical case for non-reacting flows. And we can see this is the shock front and the combustion front later. So that is the thing. And so that is the validation which was done. And this is the trajectory in which we had gone, and we had done some experiment. And you can see here there is a non-reacting flow and the reacting flow. What is important is to demonstrate supersonic combustion. And what do you mean by supersonic combustion? When the combustion occurs, there should not be any upstream influence. And that's what we are precisely seeing from this plot. That is upstream of the strut, whether it is non-reacting or reacting, it is exactly the same. And we had done measurements across between the two struts. And to verify this is what the next plot shows. You can see the blue one is actually the blue graph is the data which we got from the flight. That is the flight measurement non-reacting is the green one, and the flight measurement reacting is the black one. You can see here up to the strut end, there is no difference between the non-reacting and reacting. And this clearly demonstrated that we had achieved supersonic combustion. And then we also had further points at different conditions, and we could even get the flame out of this. So this was a very highly successful experiment of the scramjet demonstration. As you know, the scramjet is always called lighting a lamp in a hurricane. So that is how it is. So you stabilize the flows behind the strut and then do the combustion. But there are some problems even in this in air intakes. You can see here that suppose we are now working on a airframe integrated scramjet engine, where we have 3 ramps, and the cowl shock that is impinging on the ramp causes the separation bubble. And this separation bubble is very dangerous, because what happens is the separation bubble grows, there will be an unstart of this engine, of this intake. So we have to very correctly able to predict the size of the separation bubble. And we did have surprises, because there will be a lot of differences if you employ a real realizable K-epsilon model and SSTK omega model. Precisely getting the size of the separation bubble is very, very difficult unless you tune the coefficients of those turbulence models. So these are some of the things. Of course, we are doing away with that by retracting the cowl tip or making the shock strength lesser. These are some of the things which you are doing later. This is on the end-to-end mission of the TVD1, and where we had various phases, and we had we wanted to demonstrate an abort of the crew module. This was done very recently in last October, and this is on typical flow field on this. And we also do internal experiments, oil flow measurization, and the CFD, and how the with the HEM jet, that is the high altitude escape motor jets firing, and how it's getting separated from the crew module. All those simulations are being done. And this is on the Gaganyaan mission profile, and this is where we have the orbit of 170-40.8. This is a very challenging mission where it's going to happen very soon, and for this all the preparations are on. But here what is important is the re-entry phase, where you have the very high heating coming, and we should have a proper thermal protection system, and also the deployment of parachute and the associated oscillations and things like that, and the dynamic stability of this. And here we have done the simulations for the Mach number 21 and alpha minus 16, because that is the trim alpha for this. And we have done the blackboard studies with saying electron number density variation, and this is a typical numerical simulant, and we got very good match with the test data, almost 4% match with test data. And this is my final slide, and this is the space vision for 2047. We are going to have a Bharatiya Antariksha Station by 2035. The first module will be by 2028. The lunar sample return by 2030, and of course we are also planning a soft landing on Mars. Indian moon landing by 2040, and we are also having a Venus mission. So many of these things are approved by the central government, and we are working on this. We have a lot of exciting missions. There is a lunar sample return also is there, and a lot of work for the CFD and the associated technologies. So I find that there is a lot of exciting opportunities for working in this space vision for 2047. In fact, there are a lot of people involved. It is not only just the ISRO. There is a lot of academic institute, the private industries. They're all hand in glove in achieving this. So thank you very much for your patient hearing. And if you have any questions, I can take.
Thank you, Dr. Ashok. So we do have a question from Professor Bose.
Yeah.
Ashok, and I think the first thing I would like to really express our gratitude and thank for accepting to speak and give us a lot of information how CFD is being used in the national projects. So I have one question, like you mentioned that you are also inclined using this open source tools such as OpenFOAM for your problem, and you have developed your in-house codes, which is fascinating to see, and you also use commercial software. So can you briefly share your thoughts on this? So, and
I tell you, that's why I told the open source software,
open source tools in these projects.
See, for example, actually the DSMC foam, that is a very I will tell you very effectively applied in DSSC. That is mainly because none of the commercial codes have the DSMC capability. Mainly that doesn't drive business for them. That's why, and the DSMC is never a design driver. If you take a launch vehicle, the design driver is basically transonic Mach number. So where it is a compressible viscous force. That is why if you see almost 80 to 90% of our computations is on compressible viscous force. That is why all our things are basically density based solvers. In fact, if you see Fluent, their strength is on the low speed flows. Our low speed flow applications are very less. So that is one thing. But then what we found is there are some areas where we really need to do it. For example, suppose I want to know how much time a satellite will be there in the atmosphere, in a rarefied atmosphere. I need to get the drag of that. So if I want to find out the lifetime, the drag is a very important aspect. There I need to have this capability. So we had used that, and very successfully I can say that the DSMC foam was used. The only issue is then what we wanted was, we wanted to couple, for example, if you take the Chandrayaan 3, there we had seen that you have continuum flow for some time, then you have transition, and then only you have free molecular flows. We wanted to bridge the continuum flow to the DSMC. So that is what we, if you have open source, you can do all those things as one. It will be possible to do that. So that is our take on the DSMC foam. But on the supersonic flow, we had used SU2. I don't know, because this is more, you are more onto this. SU2 also is another good code at the Stanford University. But then what we found is, for some of the complex problems, like if you start doing at very high jet pressure ratios with jets, the solutions normally blow out because you have negative energy coming into the solutions. And if you don't properly tackle by doing appropriate CFL number and also the grids, you will have problems. You may have to drive the solution. So that is where the robustness of the solver becomes important. And most of the time in industrial setup, we require solutions in 1 or 2 days, because the solution, the vehicle will be on the launch pad and they will ask questions just 2 days before, and we have to give answers. Robustness is very important. So we cannot. So that is one thing which we found, that the commercial solvers, the open source solvers need to improve on the robustness. So this is my intake. I don't know whether I have answered your question or not.
Thank you, Dr. Ashok. We are looking forward to interact with you more from the FOSSEE team.
Yeah,
Okay.
I have a few questions.
Yeah.
This is Kannan Madhulya speaking. We are really happy that you could address this gathering. Sorry, there was some delay in getting in touch with you because we had to go through some proper channels and things.
Yeah, yeah. I superannuated last month. Yeah.
It's also the reason why we could not invite you to join the advisory board. We would very much like you to be a part of our advisory group and guiding us how we should spread this activity. In particular, how such an activity can be helpful to ISRO, for example. That will be a fantastic thing. That can happen in many different ways. For example, suggesting some problems that students or faculty members across the country, or even the startups. We have design consultants with us. Some of them may be interested in addressing some of these problems, number one. Some of them may be interested in developing new algorithms, robust algorithms, for example. And the third one could be integrating some of the things that you have developed, helping integrate so that, because as Dr. Chandan Bose is part of the governance, OpenFOAM global governance group, so he knows all the people. So in case ISRO develops something and you want to integrate in a particular way so that it is reusable for you as a part of your version of OpenFOAM, things like that. We can think of many different ways where we can contribute to the amazing work that ISRO is doing and VSC is doing. So for all these purposes, it will be great to have you on our advisory.
Yeah, thank you very much. I will say there are some niche problems. See, for example, the spray that is coming out. See, for example, when you have a kerosene injection, we do a barbitaging, that is effervescence. Now, how these sprays are coming and what type of, there are something different types of flows there. These are all very difficult to track, even commercial solvers don't have. But with the OpenFOAM, I think it should be possible. So we can work on niche problems like that. Unsteady combustion is one niche area. How to couple the slosh and the two-phase flow with combustion, that is another important area. Acoustics is definitely a very, very interesting area. Very much the commercial solvers don't have capability. Like LES and this, if you are able to do that and get acoustic like jet noise and all with the reflections and things like that, it'll be great. So these are, I am finding that there are a lot of scope if you work on niche areas.
Okay, thank you, Dr. Ashok. We will get in touch with you later. Thank you.
Yeah, thank you. Thank you.
Hello, everybody. So now, thanking Dr. Ashok.
Yeah.
So now we'll be breaking for a tea, short. Before we break for the tea, I would like to call Professor Tushar on stage. So we have a memento for you, sir, and we would like to visit.
Okay.
Yeah, Professor Tushar has a question to you, sir. Professor Dr. Ashok.
Yeah.
First of all, very good afternoon to you. and one and all present over here. So, am I audible, sir? Now?
Yeah, you're audible. Yes, you're audible.
So my question was, like you said, you are doing some rarefied gas dynamic studies with the simulation, and 1 and 2 days you need results. So if rarefaction is very high, like Knudsen number goes beyond 1, or for example, consider 0.1 also. So where
Yeah.
this Knudsen number is 0.1 or in that range, that time it is computational power is very limited to give the results in 1 and 2 days.
Right, right. Yeah, that's true. So this I told what I told was the only 1 or 2 days is not on the DSMC type of flows. As I told you, the DSMC type of flows is not a design driver. It is basically, I told you that because at that conditions the heat flux is low, the aerodynamic forces are low, so it is never a design factor for any of our structures. But then it becomes important if you want to know the lifetime of a satellite, because the lifetime of a satellite will depend on the drag that is appearing on it. So you should be able to correctly predict the drag. For that only, I told that was is important. And then some of the conditions like what I told was on the jet interaction at a very rarefied conditions. There it is important. But then what we always do is, as an engineering thing, if you err on the conservative side, so we assume it to be continuum and then push it. Like suppose the external pressure is say vacuum, we'll consider zero point 0.1 Pascal and do the computations and get away with that. So that is the way it is done. So as you said, yes, but it will be interesting to do a lower Knudsen number. It will be very challenging because your mesh size will go like anything billions of cells, because as you know it should be less than the mean free path. So so that is the that is the issue there. So we normally don't do at 0.1 Knudsen number. We do much higher than that only.
So yeah, so we can help you in that sense. So that was my
Yeah.
Thank you.
Thank you.
So much, Dr. Ashok. So now we will break for tea. And before that, I'll just request Professor Tushar to be on stage. So Professor Tushar is a faculty partner of the OpenFOAM project, FOSSEE.
Yeah.
And he has been guiding students since the last 2 years.
So thank you.
So we will have a 15 minutes tea break. So I would request all of you to please come outside.
Thank you, Dr. Ashok.
Hello. So welcome back, everybody, after the tea break. And now we'll move on with the expert talk, the series of expert talk by the advisory board members of FOSSEE, OpenFOAM team FOSSEE, IIT Bombay. And the first talk will be by Dr. Manabendra De. Dr. De, are you there? Dr. Manabendra De is from...
Am I audible?
Yes, sir, you're audible.
Is there any background noise?
No, it's perfect, sir. If you could also switch on your video.
I'm extremely sorry. I have some issues with the video, so not be able to be visible today. So maybe invisibly I'll have to talk today.
Okay, sir. Please go ahead. No problem. So, do you have any slides?
Yeah, I'm just trying to see. Do you see a blank slide now?
Yes, we can see a blank slide.
Okay, I think I'll just So, may I start with your permission? Okay, so very welcome to all of you. It was really a nice, opportunity for me to, again get in touch with the academic circle of FOSSEE, IIT Bombay, and my very near friend, Dr. Bose. So we were discussing this a couple of weeks back, and then it was a dilemma for me because the audience is from a spectrum of disciplines. So deciding the title was very tough. So then we're just giving a thought process to that, and suddenly it struck me that we have recently concluded the 29th UN Climate Change Conference of the parties, which we commonly known as COP29. And we were talking about emphasizing on the climate finance, building adaptive capabilities, and integrating the nature-based solutions and the clean energy transition with special emphasis on the climate vulnerable region. So keeping in mind all those things and a discussion with my colleagues at NAL, it was apt for this particular day to probably choose a title wherein we can showcase some of our activities wherein we have skillfully tried to use OpenFOAM, keeping in mind the sustainable development goals of the UN, which have been declared a few years back. So in line with that, the flow of discussion will be like this. Just for the formality, I will give you a brief overview about CSIR and NAL. And then we will have a bird's eye view of how OpenFOAM was utilized or was attempted to be used in NAL for Sustainable Development Goal number 7, number 11, and also multiple Sustainable Development Goals, which are touched upon by the Aerial Vehicle Development Program. And finally, I will conclude my discussion with the thoughts that I have. They are only my views, and just a disclaimer that it is not overall view of NAL. So I take the responsibility of those statements that I will be making towards the end of the presentation. So CSIR is a chain of research organizations. We have about 37 labs across India. The nearest ones to IIT Bombay are NCL, National Chemical Laboratory, and URDIP, who are dealing with the patent and patent analytics. They are located in Pune. Bangalore, we have 2 labs, 4PI and National Aerospace Lab, where I work. And precisely, if you get into the interests of NAL, we have various focuses and various research disciplines. So it's basically like a bouquet at NAL of different technologies and competences and the verticals, research verticals that we work on. One of them being computational fluid dynamics. And our core focus is on civil aircraft and micro air vehicle developments. Of course, we also support the space programs of the government of India, as well as the defense programs of DRDO labs. At the same time, the technologies that we develop from all these programs, whether it be civil aircraft programs or the strategic sector focused programs, the findings or the knowledge base that gets generated, we also see to it that we translate it in some way for the societal needs. So that's where areas like wind energy and meteorological modelings have also been researched at our institute. So moving to that, in that direction, the first application where we explored using OpenFOAM was for the sustainable development goal number 7, which talks about affordable and clean energy. And since its inception in 1959, CSIR NAL has been working on developing technologies for wind turbines and different enabling technologies for harvesting wind energy and also wind solar hybrid systems. So when I joined NLA in 2006, I started working on that. And we were looking at different architectures of wind turbines, which would either be installed in an open field or in the wind farms or in urban areas. So when we talk about designing or conceptualizing wind turbines for urban areas, the first thing what we need to understand is how is the flow pattern over a typical urban landscape, and then understanding of that helps us to choose the configuration. So towards that direction, we did a work. And another thing which I would like to mention over here is all these things that I'm going to highlight today have been done in collaboration with academia. Like the students at undergraduate level or postgraduate level, when they came to NL for their internship or their final year project works, along with them we explored this unified world of OpenFOAM and tried to see for these kind of applications how do we utilize the merits and all the capabilities of OpenFOAM. So as I was telling, we first tried to understand the wind patterns in the vicinity of the building. So you can see the a very idealistic CAD model of a landscape and its computational domain and the grid details which are generated by snappy hex mesh capability of OpenFOAM. And then we simulated the flow past this building to understand what sort of flow patterns would get generated and what sort of boundary layers get generated over the the vicinity around the building and over the top of the terrace. So, and then try to understand that what is the variation of the free stream velocity vertically above, for example, the terrace of the building, where it is the ideal place for putting a wind turbine. Now, if you look at these results, there can be two thoughts. One is that we try to have a pole which protrudes out of the boundary layer over the terrace of the building, and then we put a conventional wind turbine. But in that case, there will be a lot of structural implication on the terrace flooring as well as the building structure altogether. So this study posted another problem, or we would say another query to us, that whether we can have an innovative shape which can work within this boundary layer where there's a lot of recirculation happening, a lot of turbulence is there in this layer, but at the same time we avoid some huge support structure like a tall pole over the terrace of the building. So that query drove us to looking into the nature, which brings us to the next case study, where we tried to see whether we can take inspiration from nature and then borrow some magnificent shapes which the nature has evolved over not just decades but centuries or even maybe ages. As we know, the Darwin's theory of evolution says about survival of the fittest. It is not just that the animals or the birds or insects have revolutionized their characteristics to survive, but also a passive looking thing like a seed pod of a tree also has evolved throughout this this period, and they have only those shapes that have survived are the ones which we see today. So in that context, we thought of looking to the seed pods of two different species, Begonia variegata and Mimosa, and see that which shape will give us an aerodynamic standstill aerodynamic torque, which will be greater than the cogging torque of a typical generator of a small wind turbine. Now, just for the background, if we look at the small wind turbines, they use permanent magnet generators, which are notoriously known for the high starting or cogging torque, which prevents them to start in a quick or low wind speeds. So the question here was, can we borrow a shape from the nature which will help to start in a very low wind speed, as low as maybe 1 or 2 meters per second, which is beyond the capability of the conventional rotors, the horizontal axis wind turbines, or the ones which are using the lift type mechanism for generating the torque. So in that context, what we did was we collected these specimens, the specimens of the seed pod, and then we generated the digital twins of that, a series of digital twin by varying two geometric parameters. Over here, what you see is the diameter to the height ratio of these seed pods. And then we did, the conventional approach of, meshing the surfaces and then creating the grid for the flow simulation. And it was all done in OpenFOAM. Of course, at that period of time, we were using the body fitted grid. So, we had to approximate the shapes. But when I was, doing my PhD work at IIT Madras, I was exploring the possibility of using the immersed boundary method, which is one of the methods used to handle very complicated geometries, and also the ones where you have the dynamic meshing kind of a thing, or maybe the moving boundaries, I would be more specific. And luckily, while I was trying to explore that, the OpenFOAM extent had initiated the work, and I believe today it will be at a very advanced level. So probably one question that I would like to put to the FOSSEE OpenFOAM forum is to explore the possibilities of seeing the implementation of the immersed boundary method and exploiting it for analyzing a rotating blade, the one which we are trying to see over here. So at that point of time, of course, we were handcuffed with only the basic static mesh. So we tried to understand how is the static force or the static torque varying for different geometric parameters. So that is where you can see over here that we studied the natural shapes for both the seed pods, and then based on the findings of the starting torque, we then moved on with one of them, the mimosa based rotor, and then again varied the pitch to height, or the number of turns. We varied the number of turns of the rotor, and then again repeated the same understanding to see how the starting torque of the rotor will be generated vis-a-vis a cogging torque of the typical 1 kilowatt permanent magnet generator. So at present, what we are doing is, based on these studies, we are trying to print a 3D model with the help of 4 PhD students who under their societal module under the ACSIR framework, and see whether whatever understandings we had got from OpenFOAM, whether they are really going to have the same effect, or we are going to have any surprises. But at the same time, as I already mentioned, probably we can use the immersed boundary method sort of formulations in OpenFOAM to see when the seed pod rotates, what sort of forces are generated, and what sort of characteristics would these rotors exhibit. So this is one example of OpenFOAM. The second one, which I am going to highlight, is from the working group of Dr. T.N. Venkatesh and team, who are from computational and theoretical fluid dynamics division. So as we know, urbanization is happening everywhere across the globe, and India is also not, it has not remained untouched from there. So when we talk about urbanization, one of the critical thing that needs to be understood is the urban heat island. Because of the concrete jungle that grows during the urbanization cycle, the problem of the urban heat islanding also grows very much. So this group at NAL, they tried to understand how these landscapes, or the anthropogenic landscapes, how they will affect the wind pattern, and what sort of heat islandings and the effects will get generated in the vicinity of the cluster of building. So they went in a very systematic way, wherein they first simulated the flow past a very idealized domain of 2 high-rise buildings, and tried to understand the flow patterns that are occurring, and then they varied the distances between the buildings and tried to see what was the changes that were happening in various features of the building, with the velocity contours or the streamlines of the flow in the vicinity of the building. Having gained confidence on this using the OpenFOAM, the group moved forward towards doing simulation on a real world kind of a scenario. What you see over here is they have attempted to do it the same study for the Petronas Tower, which is in Kuala Lumpur, Malaysia. It is about 88-storied building, around 452 meters, approximately 1483 feet building. So the same studies which was done for an idealized conditions were now done for across a building which is, in real world it is existing. So again, similar studies were done over here, but apart from the wind patterns, this time they also focused on the thermal effects of the wind, thermal effects of the urban urban building clustering, and tried to gain more insight into how the wind patterns were getting changed because of the thermal effects. They did by studying the eddy diffusivity of heat coefficient KH values and seeing, the basic understanding over here is like, if you have a higher KH value, there is a lot of thermal exchange happening. So this can help us to detect which zones within the cluster of buildings are having a lot of thermal gradients, and then what can be done to address the discomfort that are caused due to that. So having gained experience on a hypothetical but a real world case, this team went forward of taking case of the World Trade Center, which is there in Bangalore, an urban location in Bangalore, and they also tried to understand what is happening in terms of the urban heat islanding using OpenFOAM. So again, you see over here the computational domain and the grid across the landscape that was chosen, and few glimpses of the numerical simulation where you can see the stream tubes and the contour plots of the velocity magnitudes over here. The entire simulation as well as the gridding was done using the capabilities of OpenFOAM. That is the best part of it. This work was done in conjunction with the student from Madras Institute of Technology, Anna University, and Dr. T.N. Venkatesh's team. And probably we will see if the student who worked on this problem can be also included in the FOSSEE's forum in the near future. So again, here you see over here the plots of KH, and it helps the simulation through OpenFOAM actually is able to help the team to understand the heat transfer in the vicinity of a very complicated flow domain, wherein you have a lot of landscapes with different sizes. And another innovative part of this simulation was the WRF model, the weather research and forecasting model output was used as the input for the CFD simulation over here. So there was a coupling done between the mesoscale modeling and the microscale modeling in this particular study. So that was another thing which tells us the versatility of OpenFOAM to absorb an input from a computational model which could be of a different scale altogether. Now, this brings us to the third application of where NAL has skillfully tried to utilize OpenFOAM, and that is also from the CTFD teams, the Computational Theoretical Fluid Dynamics team, Dr. B.N. Rajni. And this work was done in conjunction, the works that we will show over here related to the aerospace domain was done with the SDM Institute in Dharwad. Just a glimpse of that. Some of these informations are classified, so I won't be able to show them, but just they permitted me to highlight these things, like wherein OpenFOAM was used for the NAL's project. It was used for the internal flow for the fundamental basic research programs that are given by CSIR. Two of them were highlighted. One is the study of flow pattern inside an S diffuser duct with different bend angle. Now, basically, this is a problem for the aircraft intake duct, especially for the fighter aircrafts, like, say, for example, AMCA or even F-22 and all, where the engine has a duct which which channelizes the inflow to the engine inlet. So we need to understand the flow pattern, what are happening in the geometry of the diffuser, its shape, its inlet architecture. How does that affect the quality of flow which is going to go inside the engine? So in that case, for this particular purpose, our team had used OpenFOAM as one of these flow solvers and tried to understand the effect of bend angle. The second application where OpenFOAM was again used by this team was to understand the aerodynamics across the ram air duct of the environmental control system of the Saras aircraft. Saras is our flagship program, NL's flagship program, a 19-seater civil aircraft. So the team had tried to use OpenFOAM and understand the implication of the geometry of the air duct on the performance of the environmental control system of the Saras aircraft. Now, these were the examples of internal flow simulation using OpenFOAM. NIL also has a collaboration with our sister lab, National Geophysical Research Institute, NGRI Hyderabad, wherein they do the heliborne geophysical mapping of various magnetic parameters, those things. So they have done work at Ladakh as well as Northeast. Now, before we do that, what happens is this: the study is done like there will be a UAV, and underslung will be hanging from the UAV, and it will be doing this survey. So when we do that, it is very important that when the airflow passes from these the underslung, what is its effect on the stability of the aircraft? So here also OpenFOAM was used to understand that when the airflow passes across this hanging underslung, what is the the sort of force patterns that get generated over the flying UAV, and how whether there is any chances of getting an destabilization because of that. Also, we have skillfully used airfoil, understanding the characteristics of the airfoil for our Saras as well as the regional transport aircraft programs using OpenFOAM. And in line with that, the academic projects that were taken were using OpenFOAM for simulating a very elementary flow physics like simulation past circular cylinder or simulation of the airfoils used in MAV applications. So these are some of the glimpses where OpenFOAM along with another flow solver SU2, which is from Stanford University, were used. And apart from that, the in-house code 3D Perl, there is a hybrid RANS LES code. They were also used to understand the variation in the aerodynamic coefficient across different airfoils for the different angle of attacks for different turbulence models. And you can see over here, we have very good, similar trends between the in-house codes as well as OpenFOAM, and their comparison vis-a-vis the experimental observations that are available. Of course, here, moving from 2D simulation, OpenFOAM was also used for studying the flow past rectangular thin wings, which are very typical for the UAMs or UAVs, and the overall appreciation of how the in-house code, OpenFOAM, and the measurements, how they do vis-a-vis each other. These are some of the glimpses. And moving further with a practical example of simulating a flow past the fuselage. So this was another study that was done using OpenFOAM as well as the in-house flow solver. And unlike the previous two groups, that is my group as well as Dr. TNV's group, here the grid generation was through either ISM CFD or using point-wise grid gen, which are commercial grid generators. So again, here the versatility of OpenFOAM was established, like, it is able to not just absorb the input from a third-party tool, but is also able to absorb the grid which is generated from third party. Like, if we don't use the snappy hex mesh capability of OpenFOAM, we can make the grid in a third party grid mesh generator and then use it in OpenFOAM. So this over here is just a glimpse of how the pressure contours were predicted by OpenFOAM and 3D Perl. And you can see that a very good match between both the solvers. One is an in-house solver and one is the open source solver. So with this, I would just like to share my concluding thoughts. We have a dire need to use OpenFOAM framework for both academic and industrial research, and the platform for exchanging notes and discuss the issues that are being faced by the OpenFOAM community is imperative. Of course, a pool of HR which has an expertise in handling OpenFOAM will be really a boon to the Indian and Indian industry as well as the research fraternity. And as we see the the NABLA sign, which is a part and parcel or the integrated part of OpenFOAM itself, gives an indication that the need of an hour is to realize a research triangle wherein the academia, industry, and research organization come together, and we try to see how the magnificence of OpenFOAM can be extended to the various challenges which the academia as well as the industry is facing. So with this, I conclude my brief discussion, and I thank the organizers, FOSSEE, IIT Bombay, University of Birmingham, Professor Kannan, Professor Bose, Ms. Payal, Professor Janani, for giving me an opportunity and giving NAL an opportunity to be a small drop in this ocean. And we look forward to a long-term association with this August forum, and try to contribute with a minuscule level things that we have done at NAL. Thank you very much. Have a nice day. You can reach me on the given credentials. These are my official as well as personal email ID as well as WhatsApp. Thank you very much.
Yeah. Thanks a lot, Dr. Dey. I know you need to leave because you have a meeting right now. So please join us whenever you are free, and kindly join us during the panel discussion in the second half today.
Sure, ma'am. Sure. Thank you.
Thank you, sir. I would like to call Mr. Pushkar Sheth on stage. So the next expert talk is by Mr. Pushkar Sheth of WebTech Technology.
अंदर रखो. Okay. Am I audible? Right. So yeah, thanks for having me here. And I'll talk about what we do in CFD in our applications here. But before that, I'll quickly run through the company. So yeah, this is my introduction. Chandan has already introduced me to everyone, so thanks for that. Um, so Webtech is a conglomerate started by Westinghouse, and then they bought out the Fevely branch, which is the transit engineering. So mostly majority of the metro trains are from Fevely, some are from Alstom, and then they also bought the GE transportation business, the rail business of GE. So the air brake technologies, but that umbrella applies to everyone. And yeah, I am legacy GE. I joined GE back in 2011, and I've been working on diesel engine durability of all the GE components since then. So yeah, our freight headquarters, the GE rail headquarters, are in Pittsburgh, Pennsylvania, in the US, and along with and maybe I can tell in detail or to relate with the audience, if you the Denzel Washington movie Unstoppable, so all the locos you see there, the few of them, I think BNSF was the customer there. So also in North America. So, so along with the locomotive business, we have many other products like software products which help the locomotive a huge deal in 2017 to supply 1,000 railway. These are diesel electric locomotives. And so this is the engine family that we work on. I am a part of the base engines team. So the FDL is the legacy engine. They have been around for the past 50 to almost 60 years in field. Of course, they were a part of a different company back then, and then the design came to us. Then in 2003 to 2007, we started development on our GO Tier 2 and Tier 3 capable engines. So Tier 2 are emission norms for these diesel engines. So now currently we are at Tier 4, but not all the fleets have moved to a Tier 4 compliant engine, but we still offer the capability of Tier 4 capable engines. We have applications in locomotives. As I said, the smaller variants of these engines are also used in marine industry, like big ships to tugboats as well. So we have an inline 6 variant and inline 8 variant, or a V8 variant of the FDL engine, which are used in tugboats on the Panama Canal. And of course, power generation. So an engine can stay in place and then generate power using it. So yeah, this photograph is of our Indian Railway locomotive. You can see it in many media photographs also around the media and social media. And other products are LNG. So dual fuel is something that we are taking up seriously again. So using methanol or ethanol in conjunction in mixture with diesel spray. And then hybrid locomotive, so use a battery and a small engine. That is a proof of concept that we have delivered. An engine digital twin, now you can look at it in various ways. There are that can have a digital twin, but an entire locomotive engine uh, entirely built as a digital twin, we have not achieved that yet, and it will still take a lot of years to do that. Battery electric locomotive also, we have delivered a proof of concept. If there is a customer, we will definitely can supply there. Now, what are the basic parts of the engine? So, you see there, the power generation piece, the V12 or a V16 engine. Coupled to that is an alternator. So we have our GMG series alternator that is also either it can be bought out or we can also make alternators. And then the alternator supplies powers to IGBTs and then to traction motors. So that is how the locomotive runs. Okay. So what are the opportunities where we can use CFD or simulation as a whole to make this product a success? Okay, so let me go to the heart of the slides very quickly. So now how do we divide this? We can divide this by the product, or we can divide this by the timeline in which the simulation needs to show results. So the first category I would put at is problems in field. Now, if we see some problems in field and we think that it is caused by a flow thermal problem in a component, we need those results very quickly. As Dr. Ashok previously said, we need the results in 2 days, or in industry lingo, we need the results yesterday. So yeah, that is where the first category of results, right? And doing a CFD in that scenario is very difficult. So you generating a mesh itself takes a couple of days. So solving it is, questionable. Beyond that, you might also need to do further analysis, like CFD will just give you the temperatures. You might need to take those temperatures to a structural model and then solve the structural for the durability, solve a low cycle fatigue code, and then say that, yeah, this is the problem because of which the component is failing in just after installation. The loco is just rolled out of the manufacturing line and the component's breaking. Now, the second category can be program based, where you have decided that you are going to use a simulation tool to help design your component. Okay. Now, this component can be designed in-house, or it can be a bought out component. It's very easy to start simulation on an in-house component because the CAD details are captured very easily. You can start the program in a very planned manner. If it's a bought out component, it gets a bit of a struggle getting the correct CAD for your variant of the part that is getting supplied to you. So yeah, that the program based analysis can involve CFD, can involve a further FEA if required, and that based on the budget and timeline can be 3 months to 6 months timeline. And further to this is 5 years down the line, what are we going to do? So that is a part of advanced engineering team that I work on, and that for that we do combustion. Like an example will be a combustion simulation. So where we do the combustion on the cylinder and then predict the emissions, although we are not there yet. And as far as tools at Webtech go, we are still with commercial tools. We don't use a lot of OpenFOAM. It is almost close to zero. So I'm trying to pioneer OpenFOAM into Webtech for simpler applications at first to prove the capabilities, and then go to complicated applications. So let's go component wise. So a locomotive will have a major component of cabs, that are the sheets surrounding your components, and the diesel engine and attached components. Okay, so let's discuss on the cab side. The cabs will contain engine cab, radiator cab, and an operator cab. Now, major application of CFD that I learned from my colleagues is if you look at part of the locomotive is where the full structure is there. Now, thanks for keeping this board because it's useful. So you have the full platform, which is a couple of meters long. Okay, it will take you about 15 seconds to walk the length. Now you need to ventilate this because there are couple of motors attached below it. Okay, so how do you optimize this design? Now one case can be your entire platform is manufactured and you are going to place the fan and place the sheets on them to decide how the airflow is going to go. So there is a fan here. Okay, and then are all the motors getting equal amount of air or not is what you need to design. So this is one application on the platform side where CFD can be useful. Okay, you can simulate the entire platform in CFD and then decide that all the motors or all the components are getting the airflow efficiently or not. Second application example I can show on the platform side is the operator cab. So the operator cab is where the operator sits and operates the locomotive. Now in India we do not have any standards for operator cabs, but in US the standards are a bit high. The operator cab needs to have a toilet and it needs to be ventilated, it needs to be air conditioned. Okay, so our locos, the ones which we are supplying to Indian Railways also are ventilated and they do have air condition. So the ducting of the operator cab is also important and it takes about 5 days to get the ducting right. But if the problem is taken to CFD, you can simulate the problem on CFD and get the operator cab ducting right. Okay, within it will take more time, but definitely on field you are sure that this type of ducting is going to give out a airflow. Same thing, this process if done on field for the platform takes about 12 to 20 days to get it right. Okay, to get the flows on all the components right, but if done on CFD, this process can on the field can come down a lot. I mean, you can get it right in design stage itself. Okay, now this example, if you have the now locos can consist. Okay, you can have 2 locos or 3 locos depending on how much load you are pulling in your freight. So if the diesel, but the second loco is of some other fuel or is a battery operated locomotive, you cannot let diesel engine affect the locomotive. So this simulation we are just getting the effluent from the diesel locomotive and seeing how much it is reaching the inlet or the inlets of the battery loco are right here. So how much is reaching here? So yeah, on the cab side, this is the application. Now on the diesel engine side, there are huge amount of applications. You have a cylinder head which sits on the crankcase. You need to do the durability. So do the coolant flow thermal, where you assume the temperatures on the fire deck, and these temperatures then go to the structural model. You predict how much it is expanding according to the complicated context, how much friction is happening, and then take it to a low cycle fatigue code, calculate if any cracks are happening or not. Sorry about that. Then of course, other applications go to turbocharger, getting the turbocharger map, performance map, and then exhaust for, of course, again, low cycle fatigue applications. So yeah, another point I need to make is CFD alone may not be enough. and sometimes the client also thinks CFD हो गया अभी और क्या बाकी है, तो ऐसे सर अभी स्ट्रक्चरल करना पड़ेगा, LCF करना पड़ेगा. So the CFD engineer should work with the structural guys in providing the loads correctly, otherwise the work gets incomplete. You need to provide the loads properly so that they can apply it in the models and then accurately predict the expansion or the pressures as they are distributed. Yeah, that is all from my side. Any questions? Yes, sir.
Despite now plan to run 460 kilometer per hour, they are almost flat front instead of like we see in others.
Yeah.
Is there any reason for specific to India, or like it works well that also?
You need to bring in innovation there. This point was very much brought up by one of the colleagues who worked on aerodynamics earlier. Brought in why aren't Vaptec locomotives aerodynamic? Okay, there is a thought process behind it. There is no other issue. So now if you go to a Vaptec website, you will see a nicely aerodynamic loco which we are actually working after. Thanks. Nice question. Thanks.
Thank you, sir.
Yeah, thanks.
Yeah. So because we are running short of time, I'm just moving a little bit fast. So thanks a lot for your talk, sir. Very informative talk.
Thanks.
Yeah. So I would like to call Mr. Manish Bhasme, CFD consultants. Yeah. Over to you, sir.
Hello, am I audible to all? I think am I. Okay. So without a lot of time, I will try to make this conversation very easy, and I will try to highlight a question that triggers me when I was in BTech and MTech. So first question was when I was in BTech, that how the CFD industry make the money, right? We seen a lot of slide, a lot of research work. So let's go to the slides like how this industry actually works. So okay. So before that, I just would like to express myself. I'm Manish. I was BTech in chemical, and then I did masters in chemical plant design. And during masters, I seen my lot of friends who are doing titration, and that's the reason I don't want to spend a lot of time in titration or chemical engineering. I took a very easy subject. So I just want to be sit in the AC lab, where having a HVAC, a good airflow, and just want to sit in front of computer. So while doing this CFD, I gone through a lot of equations. So I did a CFD which can pass my paper. Okay. So that's what my background for the CFD. Okay. So let's go to the first part of CFD. It's CFD and its industrial application. So how this CFD industry makes the money. The first is compliance project. So there are a lot of rules and regulations for every industry. Let's say if you are into pharma industry, where this, pharmaceutical medicine or you vaccines, while they are filling, they have certain norms. If you don't follow these norms, the government or any advisory board doesn't give them an agreement. So before install any those system, they want to prove that whatever HVAC system they are supplying, it's good, it's going to be work. So it is a compliances. So in that reason, the CFD comes into picture. You need to satisfy those norms. So CFD has a lot of business in this industry where compliance comes. So I will show some examples. Car park. I don't know whether in India it is very compulsory. But if you are going to the Dubai desert zone, Saudi Arabia, they having the atmospheric temperature around 45 degrees Celsius. And if you drive this car into such a desert and you are parking into your car park, it's possibility that it will catch a fire. Okay. Then government comes into the picture and asks them, why shouldn't you provide us a HVAC system that show that if you burn the car, and let us show the HVAC system you have proposed. Let's say I'm burning one car here, and I'm showing the government that, okay, we have this HVAC system, if you see the pink color, okay, and this is 4 kilowatt of car being burned, okay. So then we are performing simulation and taking out all these burned carbon monoxide out. So how it get passed? The government provided norms that within this second, the CO concentration at particular level should be this, okay. The values vary country to country. The Dubai has different norm, Australia has a different norm, Singapore has a different norm. It's vary to the geographical location. So in such a case, it's very important. And to be honest, if you go to perform this simulation in actual practice, it will going to be cost one car cost, which is in million, right? So CFD save a lot of cost. Give them a compliance CFD report so that their project can get approved and get finalized. Then another into the storage things. Let's say the Amazon, Flipkart, if you are working with them, you are having the storage, right? So also they have, if we are storing our product there, so they are asking what is the ACH there, because ACH is the air change per hourly. If you want to be store a good product, you need to be ventilation, the natural ventilation. Since you are not putting any force ventilation with the duct or anything, the fans, it's all depend on how the surrounding is, right? So we perform CFD simulation on the basis of geographical location and what is the data available, the average velocity throughout the year. And they have a lot of openings. Let's say this warehouse having the shutters, the windows and door all. And then we throw the air and then we calculate the ACH. Okay. So that's how the compliance work. Another one is the data center, very common. So before installing any data center, let's say I perform this for the Airtel. What they are doing, they are proposing some, the data center, their manufacturer, and they want to make sure that what is the HVAC system they have applied. It's taking the good amount of cold air and cooling their server. If there are, heat spot or all, they can, very important to show the evidence that this is how their HVAC system is. Okay. So this is one compliance thing. Second is the, cross verification. So this is one of my customer, and this equipment is cost around maybe 2 crore or 3 crore. So before manufacture this one, he want to perform simulation and cross check if this equipment being manufactured, how it will perform, whether it will deliver the same amount of temperature that he designed for or not. So before manufacturing, we can perform the simulation and letting them know, Baba, this can be a temperature and it is not being achieved, so he can take the action by that time. So this is how he with a lot of cost before he manufacturing. Same thing is here for the plate heat exchanger, the same thing. For the double pipe heat exchanger as well. The steam tank. So there we have where we have the petroleum industry, and once they took out the lot of crude oil from the earth, let's say, they process into steam tank where the oil and the petroleum product get separated, and it's depend upon how this petroleum product and water interact, whether it is providing sufficient residence time for the petroleum product to move upward or it is getting out. So you can see we have performed a lot of simulation. So our existing customer having the petroleum product of the particle size, let's say 120 micron, the initial efficiency was 55 micron, and with our consultation, with a small modification, we have achieved up to, I think, how much? 85. So it's, and you can multiply this efficiency to the number of working hour, maybe it can be run for 2 years continuously. So you can calculate how much cost we are going to save for our customers. And that's why they are willing to pay anything if you are doing small changes for the petroleum industry. Another thing is electronic cooling system. This is not a common system. Let's say it is not for Dell Rack server R30 or common product. It is for the military product, because military configuration is way higher than what we normally use. They maybe use 5 GPUs, 6 GPU, and the 1 GPU almost cost 6 lakhs. And it is not about the cost, but also while doing the military operation, they doesn't want to lose any data. So they want to make sure how their system is cooling efficiently or not. So what we can do in the simulation, you can see this fan placement is not good. It's being circulating, it's taking the air, throwing here and getting circulating back. So it is not getting cooling efficiently. So that's the reason the temperature of certain GPUs getting higher and low. So you can place the one plate here, so that can be blocks recirculation, but still it is electronic thing. If you make a small changes, the entire electronic engineer will be, fight with you, because again they go back to the motherboard, the placement, all those things. So it is way complex in terms of electronics, but in terms of big HVAC industry, you can take a duct out or fit anywhere. That's not a problem. So same for NVIDIA, we have performed, but it is not for standard NVIDIA. My customer use 4 NVIDIA graphics card here, and he were interested what is the temperature, and you can see the temperature is 100 degrees Celsius, and that decreases the efficiency around from 90% to the 80 and 75%. So that's not a good thing. This is another project. Okay. You can see this chiller yard. So what exactly chiller yard is, I will let you explain. So we are having this AC system installed in our office. How it is being cooled? Because it is taking the heat and discard into the environment, right? So it is taking the heat and spending to the environment, right? Exchanging. So this is chiller yard. We have somewhere it is placed outside the window. Maybe that's why you are seeing a lot of AC system hanging on outside your building. What happens if I'm cooling air using from the atmosphere? It is being circulating back to the same thing. So in that way, your delta T got decreased. Once your delta T got decreased, your heat exchanging rate is going to be decreased. But at the same time, you are spending a lot of electricity for this compressor, right? No matter what you are spending, but it is not working efficiently. So you can calculate it is not about the one chiller yard, but entire Middle East is depend on HVAC system. A small modification, if you make a change, that will impact highly on their cost. So that's what important CFD bring into those areas. Okay. Then third application is problem solving. So this is one from the military project. Let's say the military people are working there, sitting, and they're having the rack server system. So you can see how air is flowing in, coming out. So people are not feeling comfortable, and the cold air is not getting distributed into the rack server system. So in a case it can fail, or people not feeling comfortable. So such an issue can be solved. And I think the previously in the locomotive, what he is told, the same thing we can do here. This is into the process industry, problem solving. So this is one of the project from, let's say, my MSME's customer, and you can see how his reactor looks before CFD and after CFD. So we can predict how the particle flow, because this spray dryer thing, you cannot see what's exactly happening into the, inside the metal walls. And CFD letting you know how's their moisture content, how the air is going to be flow. All those thing information we can change. The cyclone, all those things. This is what problem exactly occur in such a system. While delivering manufacture such a cyclone, they commit a lot of efficiencies. Like we will give 100%, 95%, all those things. But once they are installed, they are getting minimal, separation efficiency. This is fine if you are having the cement industry or your product is somewhere raw. But if it is pharmaceutical industry, a gram of, product cost a lot. So in that regard, they want to increase their separation efficiency. You can see how my customer having the initial separation efficiency and how we achieve their, higher separation efficiency with our CFD simulation consultation. Similarly, this is one of radiator from my client. They manufacture and they made 20 pieces, and none of them is working because of the pressure drop. They may be provided narrow diameter, which is not good. Their engine is not capable of forcing such a pressure, and in that thing, so CFD helps. We help them out to change their dimensions, all those things, by making a minimal modification here. And in that way, we save a lot of cost for them. So here's the application for, the problem solving approach can be done using CFD. Same for paddle dryer. This is very interesting case. Let me tell you this very interesting case. I was visiting one of customers, and accidentally I found this piece of equipment, and he's selling this equipment from 1995. And I observed this equipment around 2018. Say he's selling this equipment from past 20 years. And I told them there's a major bypass in your system. So what is the process time you are taking? It is batch equipment. So he's taking 6 hours to get that product out with a proper heat exchange. I told, what if I can make the modification and let you know the same system and your process time can be break down to 3 hours or 2 hours. And this is where he, expresses gratitude toward the CFD, because what exactly MSME people do, they take the product, take it to the home, do the operation, take out all part, yeah, and do the copy paste. So what mistake have done in the previously can be get repeated. So in that regard, CFD helps, and you can see what is the residence time, like, time taking for me to get steam into the 3 paddle, it was 50 seconds. And with simulation, I took it to the 3 seconds. So now the batch time for the 6 hour can be broken down into the 1 and 5 hour. So you can imagine how much amount of benefit he got. Means the same factory, he's paying for the working hour for the 1 day, and he's getting, let's say, 1 ton of the product for 1 day. Now he's getting 3 or 6 ton. So you can calculate how much profit he's getting. The fourth part of industrial application, it is innovative type of research product. So we having a lot of customer from the pharma background, because their viscosity change, density change, all those change, their residence time change. So they cannot perform this, RTD analysis because it's very expensive. You need a lot of separate, and there are a lot of parameters they want to study, and it is not feasible with, experiment. It's feasible, but then you need to, you have to be very patient and spend a lot of time. So with CFD simulation, we can give you RTD data. So we can apply 1 parameter model, 2 parameter model to calculate what is dead zone in your CFD tank, what is the bypass in your tank, right? So all these things you can calculate using CFD. Another in research area, because we are highlighting the research area, I have a lot of customer. They just take the equipment and come to my table. I want this to be done. This is my competitors. Do the CFD and do a better than this. So there's a lot of research. They come and give me for blower, we can generate pump curve or pressure, that all those things for this pump as well. You can see centrifugal pump. It is way outward pump, and it has a lot of drawback. This is problem from the Netherlands, because Netherlands is the country, it's below the sea level. So what happened? Because of this country is below the sea level, it's occupied with a lot of sea, and government is very concerned if something they want to touch to the water. If they want to change something to the water, the governments come into the picture and they say, first perform CFD simulation and let us know what will happen. Otherwise, it was a flood in I don't know which year, the entire country, half of the country people get flooded. So more into the specific to the Netherlands, they are very concerned about this. They want to perform CFD simulation for whichever area water they have, pump sum, water treatment, nowhere it is. So they perform a lot of things. So windmills nowadays, this quite common project. Again, this research project, my client having this huge reactor, and I wasn't confident about his, thermal calculation, because you can see this is a thin, what is this? Fins, and it is 0.3 mm, and you cannot measure the CFD. So what I have proposed is to make a simple small reactor, let perform CFD calculation experiment, and try to in between way so we can model in very simplest way. So we have done this. Multi-phase product again is petroleum industry. So petroleum industry, a lot of time not having only the liquid, but sometimes gas is also coming out. So when gas and liquid comes into the picture, there is a bubble flow and it oscillates a lot. So one of my client having installed this one, and their worker is not want to work on the floor because floor is vibrating a lot because of the flow, and they don't know which area is problematic because entire floor is vibrating. The source of vibration itself are creating vibration, and then it is getting transport. So they don't know where actual location is. So through calculation, we predicted the actual location, and they taken care and they solve the issue. Okay, now the first part is complete, that what is CFD and how it is being implemented and how people make the money out of it and how we can generate jobs for the people. So to say, that's what I think we are focusing, right?
Actually, sir,
Okay.
actually, there is a time for the lunch if we give.
Okay. So I will try to wind up. Within 2 minutes?
2 minutes,
No, 2
yeah.
minutes, within 2 minutes. So what I would like to highlight is in the Maharashtra, if you look at the only Maharashtra, because I work in the ground level, so I know, let's say it's all like 1200 MSME, it is not a small number. And such an industry having, they having their own design, okay? But it is not well engineered, that I can say from my understanding and what kind of customer I have. So this industry, this 1200 industry has a lot of huge potential for the CFD engineer to come up with their knowledge to bring down or resize their equipment so that they can save a lot of cost, and also the community can get benefit in terms of jobs. So that's what I am focusing. My contribution for this process is to communicate with this MSME with CFD worlds, right? Okay. So what exactly drawback this industry has? It has, the first point I will go after. The first thing is they don't have the enough finance, right? So they don't have enough money to get a CFD engineer as well. Then after the highly paid CFD licenses. So here we can have the breakout. We can use open source software, so break down their cost. In that way, we can introduce process there. Okay. The third thing is lack of awareness. Mostly people don't know what is CFD. They are doing into the work into the industry engineer. Even the engineer don't know working there what is CFD. So here we need to spend a lot of time to making some arrangement or something that let them aware, like this is CFD can do. Yes. Third drawback in this industry, MSME is like that because his father running his industry, let's say for the pump, his father having a good knowledge about the pump, he's going to be great for the good business for the 10 years. And after the 10 years, we are seeing this industry going fall because his son take cares the industry. He's from the commerce background. He don't know what is a pump, right? So such a people cannot encourage the technical thing. So I think we cannot work here. That's a lot of headache. But I think this area we can work. Yes, so that's what my point of view, and I would like to contribute in that way. If we can reach out to the maximum MSMEs, where we can break down the cost with the help of FOSSEE. So in that way, I think we can help the CFD community which who are looking forward for the jobs in the domain. Thank you.
Thank you so much, Mr. Manish. So now we are breaking for lunch, and before that, Professor Kannan, can we stand up for a photo session or outside? So for the people who are there online, we will just break for lunch now, and we'll come back. Yeah. So if you can just all of you who have joined online, can please switch on your video so that we can all take a group photo before we break for lunch. And after lunch, we will resume at 2:15 p.m. So we are going to have a quick lunch break. I can see Dr. Datta. Hello, Dr. Datta. Welcome.
Yeah, hello. I've been following the lecture, so yeah, it's a bit morning here, but nice lectures. Hello, hello, Professor Bose.
Hello, Mr. Advait. Welcome.
Hello.
Hello.
Hi, Miss Payal. How are you? Hi, Dr.
Hi,
Bose,
hi.
Dr.
I see Dr.
Datta.
Gupta is also here. Yes, hello, hello, Professor Abdullah.
Yeah. How's
We
everyone?
will
A lot of nice
switch
lectures
on your
today.
videos, everybody who is convenient. Then we can have a good, group photo.
Am I visible? I'm not able to figure out if I'm visible or not. Multi-speaker.
Yeah, I think you are visible. Just maybe a
Okay.
little bit, go a little bit higher up.
Okay.
Yes,
Okay.
this is
Okay.
better. Yeah.
Dr. Bose, you're not audible if you're trying to say something.
Can you hear me now?
Yes.
Yeah,
Perfect.
so we were just telling that, I mean, if you are comfortable switching on your camera, we can just take a screenshot of all the online participants just to like have a feel that we are all together in this event. And yeah, and we will restart our session after lunch with Advait's talk from 2:15 p.m. So we have to really hurry up for the lunch and get back. And really sincere apologies for the delay in the event going on. And thank you very much for being with us. Thank you.
Hi, everybody. This is Professor Kannan speaking. Really happy that you stayed with us till now. Look forward to your being with us till the end of the day. Can you all turn your camera on so that we can take a photograph, as Professor Chandan Bose already mentioned. Let's come on. Want to see a smile. Okay, I suggest you, just take a screenshot. Thank you, everybody. Sorry, we cannot offer lunch to you, but we will meet after lunch, okay? At
Have a
2:15.
good lunch. As they say in Turkish here, afiyet olsun. Bon appetit.
Thank you. Bon appetit. We'll meet at 2:15. Thank you.
Okay.
मालूम पड़ेगा वो कंटिन्यू में। हेलो 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 हेलो, बड़ा इसमें क्यों डाला फर्स्ट में? फर्स्ट में डालने बोला उसने। हाँ
फर्स्ट का ही है ना?
नहीं इधर था, ये वाला इधर लगाया था, चलेगा चलो। हेलो हेलो चेक, हेलो 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 चेक।
हेलो।
इधर से कोई तो बोलेगा हेलो चेक माइक टेस्ट, हेलो चेक, हेलो हेलो क्या, हेलो चेक, हेलो हेलो, बड़ा इसको, हेलो 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 चेक, हेलो 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 माइक टेस्ट 1 2 3, हेलो आ रहा है क्या? ये तेरा है, हेलो 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 चेक माइक टेस्ट, ठीक है, हेलो।
Hello.
Hello.
Welcome back, everybody, after lunch break. So we will continue the expert talk, the series of expert talk, and the next talk will be by Mr. Advait Gupta of Pandav Applications. So welcome, Mr. Advait.
Hi, Miss Payal. Thanks for the introduction. Let me share my screen. Is that possible for me to share my screen? Because I think the screen sharing is disabled. Hello, am I audible? Hello. Oh, great. And my screen, is it visible?
Yes, I think your screen is visible, but you have not shared anything yet, I guess.
Okay.
It will come, I guess. Yeah, now it's okay.
Okay, great. Thanks a lot. I am Advait Gupta, founder and CEO of Pandav Applications Private Limited. First of all, thanks a lot to Dr. Chandan Bose. We have been interacting on and off, and through him, I got to know about this academia industry collaboration that FOSSEE is now thinking about. And also thanks to Professor Janani ma'am. I think we were in contact a couple of years ago, exchange a few ideas about how OpenFOAM proliferation can be done in the country. So rather than talking about CFD and different all the cool work that a lot of people before me have shown, I will focus a little bit on the reality of OpenFOAM in India right now. Before that, very quick introduction again. I am Advait Gupta. We are based out of Bareilly, Uttar Pradesh. That is my hometown as well. And my expertise lies in theoretical fluid mechanics, high performance computing, scientific software development, and things like that. This is the data that we have over the course of almost last 1.5 year. Total CFD applications or OpenFOAM applications that we received on our careers page is 967. During the HR call, we ask a very simple question: do you know OpenFOAM or not? And after that, some 369 people moved forward to the CFD test round, where 27 of the people could actually clear the CFD test, very basic CFD test. And then out of that, 9 applicants actually took the OpenFOAM assignment. It's a open book 24-hour OpenFOAM assignment. Again, very basic questions. Actually, it's one single question that we give. And 2 people is what we actually ended up hiring. So 967 applicants in the name of CFD application engineer, down to 2 people that were actually hired. So I'm just trying to share our pain as someone who is out and out working on OpenFOAM application and source code development and user interface development and many other open source software tools. So it has become a nightmare for us to hire people who have expertise in open source tools. We came up with 2 solutions for that. The very first one is the International Simulation Olympiad. Since my childhood, I was always fascinated with a lot of Olympiads, maths Olympiad, physics Olympiad, and I'm sure all of us have been part of that in one way or the other. I always wondered why we don't have a simulation Olympiad at a global level. So we have been doing it for the last 2 years. Also, giving out prize money from our own without any external sponsorships from the company's pocket. But we have been only promoting OpenFOAM. So the entire set of problems that is given in this International Simulation Olympiad, which spans over a period of a month, you're supposed to solve it using OpenFOAM only. So in the first year, we had winners from Cranfield University and IIT Bhubaneswar. And this year, the winners were from NIT Durgapur and NIT Hamirpur. While this is our effort for promoting OpenFOAM, creating excitement about OpenFOAM, but still out of hundreds of applications, hundreds of applicants, and it is free to register for this event, by the way. There are actually a very few number of submissions or solutions to the very basic problems, or let's say intermediate OpenFOAM problems that we provide. So I hope this will change in the future. And in fact, in our last Olympiad winners announcement, Dr. Chandan Bose was our chief keynote speaker for that, and he shared a lot of good ideas about where and how these things can be further improved. The second initiative, which unfortunately we are not able to continue as much as we want, owing to a lot of, I mean, at the end of the day, we are a business entity. Is Pandav Applications Advanced Academic Program. This actually got quite popular within the country, where we used to teach OpenFOAM from a very industrial problems point of view. I know FOSSEE has been doing a great job, getting students ready, getting started. A lot of students with OpenFOAM, but because we have access to real industry problems, real complex geometries, and real deliverables, we used to trim them down a little bit.
बाकी देखो फिर भी ब्रेक इवन पे ही समझ लो आप, ठीक है। वैसे तो ये है रियलाइज्ड 1000 के का दिखा दो। ये है अगस्त का। अगस्त में मैं 95,000 के प्रॉफिट में था, 95,000 के प्रॉफिट में। प्रॉफिट मेरा 1 लाख का था, प्रॉफिट चार्जेस कट के 95,000 के प्रॉफिट 1 ही लॉस था, ठीक है।
I think someone has turned on the mic.
तो मेरा क्यों नहीं वीडियो में ये मेरा पोजीशन है, ठीक है। लाइव आपको दिखा
Yeah, now it's okay, I think.
Hello? The voice is not coming. Actually, you're muted.
Oh. Am I audible now?
Yes.
Oh, great, great. Right. So what I was saying, these are all the different universities and different industries, research labs where we have taught students or professionals OpenFOAM in the past, either in a more direct capacity where we directly collaborate with the university, or in an indirect capacity where the students from that particular university have approached us as a group and we have taught them OpenFOAM. So we were running specialized courses on thermal management, aerodynamics, HVAC, and multi-phase flows. Unfortunately, we are not able to do this as much as we wanted because of other engagements, but I hope to see more of that. In terms of the type of physics that we are capturing using OpenFOAM, and we want to see more of this happening in the country, is I can show a lot of stuff, but I'll just give you two videos, and I'm sure this will make you appreciate the type of multi-phase laser dynamics, coupled particle dynamics, coupled CFD solver development work that we have been doing. So this is a laser powder bed fusion simulation, a 4-phase system, all phases out of which 3 phases are changing into each other. There's Fresnel reflections happening. The powder bed is lying on the bottom, melting, solidification. You name it, pretty much all the equations are in there. And then there's another one on additive manufacturing side. Again, this is quite high fidelity metal deposition using wire DED or wire direct energy deposition process. We have successfully been able to penetrate a few industries with a lot of pain, of course, because many companies, I think one of the companies that was named earlier, HPCL, while they went through a very nice OpenFOAM training courtesy to IIT Bombay, they never actually went on to adopt OpenFOAM, and we have been trying that they actually start using OpenFOAM for their industry projects, but they are very happy sticking to ANSYS, and the legacy of decades and decades of legacies is stopping them from even exploring OpenFOAM in a more serious manner, rather in addition to just learning OpenFOAM. But there are other companies that have been adopting OpenFOAM. We have been giving them very top grade, projects, solver developments, and they are liking the work. And I hope that same will continue to other companies as well. A few notes that I've written down on a piece of paper, not included in the presentation, is before moving back to India in 2020, I was in the US for 7 years, and I was the global head of academic programs there. And one thing that was very, very embarrassing or shameful as an Indian, what happened behind the closed doors of the commercial CFD software companies. They used to basically think about how to get developing economies addicted to their software. That's exactly the words that were used. And I think to some extent they have been very successful in doing that. And I really hope that would change for our country at least. And I have a few ideas, a few strategic bullet points, which we can flesh out in more detail down the line. But let's focus on these 5 points for now. We definitely want a decentralized, self-sustainable CFD practices. I mean, CFD cannot be restricted to the top 1% universities of the country. I mean, we have a couple of universities around Bareilly, fantastic mechanical engineering departments, but they are all doing ANSYS end to end. Again, so that needs to change. Teaching OpenFOAM at all institute levels. I've already expressed my pain at that point. Students will find it very hard if they do not know a good open source software down the line. I mean, even a small startup like ours is rejecting hundreds of applications because they are not able to showcase the right CFD acumen simply because they've been clicking buttons on a very easy to use CFD software for a long time. And moving forward, we cannot just rely on application side of CFD. There has to be R&D. There has to be better CFD learning. So less reliance on commercial software, of course. Again, as part of Atmanirbhar Bharat, again, someone in the morning spoke about that. We really need to. I mean, this is a golden opportunity, to basically lead the pack. Otherwise, once again, someone else will do this for us. We'll continue importing the software. A very good initiative by Ministry of Education and IIT Bombay that they have at a very critical moment, selected open source tools as a right way of educating students across India. And as our commitment from Pandav Applications, we are committed to teaching OpenFOAM with the right support, right resources from esteemed institutions like IIT Bombay and Ministry of Education. And we are sitting in Uttar Pradesh, Bareilly. I cannot promise for the entire country, but with the right amount of support, at least we can take care of a big student population in my state, and be a part of this initiative of building next generation of CFD experts. So that's it from my end. I did not want to show a million projects, and just wanted to put my thoughts in front of you all about what I think is the real state of CFD or OpenFOAM in the country. So thank you, everyone. I cannot hear you if you're trying to talk to me.
Yeah. Now I am audible to you?
Yes.
Okay. So I was saying that it was a very effective and insightful talk by you. So thanks a lot. And now we'll move ahead with the next expert talk, which will be delivered by Dr. Abhishek Datta from Izmir Institute of Technology, Turkey. He's a professor there. I mean, he's a assistant professor there. So we call him Dr. Datta, not Professor Datta. And he is also, he has his startup, Simuligence. So over to you, Dr. Datta.
Thank you. Thank you, Mrs. Mukherjee. Let me share my screen first. Okay, so I think my screen is visible, right?
Yes, it is visible.
Okay, thank you so much. Well, first of all, it's a great honor for me to be part of this program, and probably the biggest initiative for this is thanks to Mrs. Mukherjee, Payal Mukherjee, and who actually kept on this continuous, dialogue between us. Thanks also to Professor Kanan Modgolia, and Dr. Chandan Bose for this warm offer for presenting ourselves. Basically, yeah, indeed, I'm Abhishek. I'm Abhishek Datta. I am from currently I'm an associate professor at Izmir Institute of Technology in Turkey. And I have this startup Simuligence that I made it just after COVID. So I remember dates like that these days, before COVID or after COVID. It was in 2021. And since then, I have been focusing keeping aside my conflict of interest and things like that, which are very important in this part of the world. I'm sure as well as in any other part of the world as well, trying to focus on things that are, let's say, not connected directly to my own research, but yet still complementary to my skills. It was a very nice presentation from Dr. Gupta as well as from the previous presenters as well. Dr. Gupta had clearly mentioned the problems, and I think this is it more or less covers a big aspect of this today's presentation. However, I'll talk from a little bit from a different perspective. I have a very few slides actually, to be honest, and That's basically on the priorities of European Union on the aspects of digitization, basically on the fourth industrial revolution. And here, of course, an integral part of it is CFD. Why I focus on the European Union? Because as you have probably seen, my company is registered in Lithuania. It's a fully registered company, and it's in Vilnius, the capital city of Lithuania, and we are there since 2021. So let's go to the next slide. A little bit about Simulagens. We are focusing on three principal domains: environmental, health, and energy technology. These are, of course, three of my personal strong areas as well. I'm trying to combine machine learning and artificial intelligence algos to play a pivotal role for product and process development, especially in the context of digital twin technology. Under the scope of digital twin, so the scope of Simulagens basically includes the digital twin conceptualization. We do modeling and simulation, and here, of course, lies my own personal expertise with the algorithms of finite element and finite volume. Then I'm having a team which works on communication and connectivity issues using edge and cloud computing. And of course, we are trying to develop some good machine learning algorithms, AI algorithms using PIN, physics-inspired neural networks. Out of scope for us currently is the human-computer interaction and the human-robot interaction, which we are dealing only with collaborations across Europe. So these are this is the main scope, or rather these are the main scopes of Simulagens, and we are focusing principally on the three domains, as I've mentioned. Personally, I have a background in chemical engineering, as was also mentioned by Mrs. Mukherjee, I think. I have almost 15 years of experience in numerical modeling, and I have a team with a mechanical engineer with 5+ years of experience in simulation and validation, a computer science graduate with 12 years experience in software development, and an applied mathematician with knowledge of algorithm developments. So this team basically tries to work together. This is our team, a very small team, as you can see, and it perfectly falls under the SME definition for European Union. So we are poised as a SME, and we are trying to, or rather a micro SME in that sense, to be more specific. And the whole idea is basically that we try to help companies, as well as we are now venturing into a little bit other things, not just the company work, and I'll come to that in a few slides from now. So this is standard vision, mission, and values. I skip it for now. Yes, so indeed, Dr. Gupta was mentioning a very valid point that the use of commercial license is still a big issue in India as well as across the world. I have personally faced myself this issue as well when I had approached companies, and they clearly told me that this is the deadline. The deadline is 6 months or 1 year or something like that. Depends on the projects, of course, and you have no time to improvise or work on it on an improvement scale. You just have to deliver. So there is at one side the money or the happiness of finishing the work, and the other side of your personal happiness of you using an open source. At some point, there had to be a compromise, and we had to go for commercial licensing. So this is an aspect which, unfortunately, the industry is also a little bit responsible about it, that when they have a legacy software and they have their own engineers with this license, they generally do not want to have any other, even outside even CFX or ANSYS, they don't want to go into any other softwares as well. There are a lot of new softwares coming up from the Dassault systems, and also these are also upcoming commercial softwares, but the market is really, really blocked by, or rather monopolized by, commercial licenses. Small things that I'm proud of saying on behalf of Simulagens we did was trying to improve this existing argon oxygen decarbonization process for steel company. Let me not disclose the steel company now. It's an European steel company, where we actually reduced the whole idea of this mixing time. 10.6% of the mixing time we reduced it, and this meant that the company was making around extra 130 hits per year, which is at least 500,000 of earning for each year. And especially when steel is having a cutthroat business these days, from especially from the Chinese manufacturers. This was a very, very important work that we did for them, again, with a very time-bound project, which means that we had to go for a commercial license. The other was working for another, this is a pseudo commercial company. It was with a company that works on development projects as well. The idea was to develop a new design of an impeller with degassing kinetics. The degassing was very important for the solidification for the aluminum refining case. And again, we were forced to go into commercial. We did start with open source, but they were not happy with the progress, the speed of the progress, let's put it like that. And eventually we had to go for commercial license as well. These are some of the open source stuffs that we could do, where we worked on a baffle design in a shell tube heat exchanger. It's a very small, non-time bound project. So there was not much of a time bound in this. And here we could actually optimize the baffle cuts and the distance between them without compromising the pressure drop. So it was a small scale project, but then it gave us the opportunity to use the open source license. The second one was a commercial project as well. Okay, I should have put this before. It was an industrial project where we actually developed the heat exchanger, also for an European company here. We tried to improve the heat exchangers, basically that was using for desalinated crude oil. Okay. This was an open source indeed, where we actually worked for, again, a shell and tube heat exchanger. So again, this project was not time bound. And when there is not a time bound, and of course the budget was low, we could actually play with the open source. So wherever the budget is high, the company is offering us a very limited time but a very high amount for per hour basis. You know, the revenue was higher. We were actually also, I mean, I won't blame always the company. We were also tempted to try with the industrial commercial license as well. This was not the case. It was an open source, so we could also use the open source capabilities here for the understanding the thermal profiles for the shell and tube heat exchanger. Okay, so this was a small part of what we had been doing since the last 3 years, keeping in mind that I have a full-time job and I have my own research. So coming to the thematic problem or thematic question of my presentation is all about digitalization or digitization, whichever way we say it. And as we know that this digitization was basically kind of like a fusion of the mechanical analog and biological and digital. That's what the whole idea of digitization is all about. And it was kind of tempted to be the fourth industrial, mentioned as the fourth industrial revolution. So here, there has been a lot of focus lately, especially after 2010, rather 2020, in fact, when Ursula von der Leyen had laid out that the Europe needs to be digitalized, and almost legacy companies were not so much digitalized, unlike in US. And there has been a huge impetus since then through the Horizon Europe fundings, which are actually few billion euros funding. And these fundings are basically focusing only on digital revolution, or we can say the fourth industrial revolution. Here, we tried to grab this opportunity because this is a great opportunity, especially the funding was a support for SMEs and startups, as you can see in the 7th point. The key priorities of European Union was to give a single digital market, to give a digital infrastructure and connectivity, trying to include AI and emerging technologies all in one system, digitalizing skills and education, a very important factor, digitalizing health technology, sustainability and green digital transformation, and support for SMEs and startups. So these three are tried to become the focus of Simulagence because of the catching up the market. And we really were helped by the fact that we could apply for the support programs from the European Union because of their 7th key priority, which is the support for SMEs and startups. So this was, as I mentioned, this was originally it started as a digital agenda for Europe. That was a key initiative all the way back in 2010. but in a big way, it started from 2020, so post-COVID, whereby everything was just because of the pandemic. People started to see that it was very difficult to, if there is a repetition of such events, people won't be able to meet face to face, and digitalization started to gain very rapidly. At least the impetus for digitalization. So here in this case, I would like to say that a small information that we have been working on for the European Union projects. So we successfully passed the round 1 of the Eurostars Eureka with a budget of €1 million, where we had a personal budget of 0.25. Not so bad, because of the work that we had to do, it was not too much. The idea was to develop a resource efficient and environmentally conscientious sustainable oven. This oven, basically, it's an innovative idea for optimized cooking performance, where we had to basically try to combine the CFD. That's where I'm referring to this, where we had to combine the CFD. The whole thermal management of the oven was combined with the IoT and the smart sensor applications. So we had a patent with a collaborator. They had a flexible baffle design and built-in image sensors, so whereby we could actually combine all this into one idea, one oven, let's say, and we could predict. We actually are predicting savings of at least 20%. This will be a disruptive technology for Europe as such, and this is already we've passed through the rounds. So here, the second one is we just submitted it as well. This was again for a municipality in Turkey. Actually, this was with Turkish partners, where earthquake affected a certain part of the Turkey. As we all know, a very devastating earthquake happened in eastern Turkey, and one of the municipality wanted to completely redefine the way the water is being distributed across the city. And thereby, we had to apply through this strategic budget again, strategic project again, with a total budget of 0.68 million. It's not so high. We are working here not only on CFD, and here I had to mention all this work, since it is not a very time-bound project, and we have a time, 2 years, somewhere 3 years, we are all going to use open source here. Not only that, we are also using OpenSCADA for our work here, and apart from the other applications that has been mentioned here. So this is a project where, indeed, just like the previous one, we could use open source and try to deliver all the results in open source. The third one is about poultry management system. Also a very similar idea to the first one with Eurostars. So that's why we again decided to apply for the same idea. I'm not the coordinator. Simulagence is not the coordinator here. It's another company from Turkey again this time. This has a higher budget, 1.7 million euros. And here, the whole idea of actually combining the thermal management again, trying to get the IoT sensors, do the edge computing. So everything is all together in one system, whereby all the details of the poultries, where the results are coming, everything will be all monitored, including the feeding system, the watering system, the health monitoring system, and the environmental management as well. Very interesting project. And I wish that this project could be even scaled beyond Europe. In fact, India would be, and the growing countries like China would be very ideal for this, unless India or China doesn't have already this project, this type of system. We are finishing the project submission. We will submit it well before the deadline of March 25. These are the drafts that we are working on, sensing integrated smart sensors. This is a project with the Turkish Aerospace, sustainable, innovative, and efficient two-engine V2L UAV system. Here again, we are developing CFD systems for fuel cell applications for drones. The third one is the impact accelerator for deep tech. This is basically capacity building for Simulagence. So we are trying to ask money to develop our own capacities, which is actually what European Union is giving as a 7th priority, as I've mentioned to you. And the fourth one is also a very interesting one. It is urban heat island, very, very relevant for India as well, where we are trying to reimagine urban spaces using with the consortium partners. And here we are involving the municipalities, the NGOs, as well as the research organizations and the SMEs like Simulagence. So these are the four main things that I have at hand. So pretty much busy with writing proposals and making it pass through. There will be probably few more coming by, but this is enough for the middle of 2025. So coming to the question of, no, or rather the point of what Dr. Gupta was mentioning in the previous presentation, what are the employee expectations, and most important is employability. Employee expectations. I'm not a company with Elon Musk's habit, so I will give my employees time to breathe, of course, and time to innovate themselves. So this is the four things that I thought could be very interesting for the expectations from our side: is need for continuous learning and upskilling, cross-functional collaboration and communication skills, very important communication skills, work autonomy and drive of innovation, ethical use of data and knowledge of sustainability goals. These are four important things that as a EU startup, I'm expecting from my employees as well. And for the employability, apart from the technical skills, industry-specific knowledge and soft skills, I think these are three that are quite obvious and are quite expected. The fourth one, I think, is really very important, which is an entrepreneurial mindset, which means that at some point, I would want my employees actually to build up their own and move on. So that's the whole idea, that I don't want to retain them. I want them to move on and with their own ideas, and they can develop. So this developing and co-developing, this is the expectation of Simulagence in terms of employability. I think there are just two strategies, corporate strategies, cooperation strategies that we have with industry and academics. It's a bit of my own thought process, so I don't know if this is relevant at all. We can't find this anywhere. It's my own structure. So we, for the industrial cooperation, we start with a topic. We do the market analysis, as you can see with the arrows. You can just follow the arrows, and we create a task. This task, either it is already given clearly by the company. Most of the time in Europe, I've seen that the task is not clear for them. They just know that they have to do CFD, and that's it, and which is actually a very ridiculous thing, because unless they have a clear idea, we can't move on, and then at the end we have to propose something back. So there is an adaptation, a small loop that is needed here. After that, we start with the principal case. We call it as version 1.0. We go for the iterations as it is seen here. And then, of course, with the discussions of with the companies, we finally reach the desired version. Until then, until a new topic is again delivered. So this is the closed chain process. This improves the main aspect of this is that we are working in very close cooperation with industry. I've been using this model with 3 industries already, and it is pretty much successful.
Sorry,
in this
Dr.
matter.
Datta, could we please request you to wrap up for the interest of time?
I just have the last slide here, so
Sure.
I think this would be, so this is the academic cooperation while we are working with some universities. Started my cooperation with KU Leuven directly, and this is kind of like cooperation that we're developing also for all the European projects that we are working on this aspect as well. These are the extended lists. There's no need to go for that. And here is the last slide. Thanks for listening. If you have some questions, please ask. And these are the immediate partners that we have, and we thank all of them for providing us interesting projects and funding. Thank you very much.
Thank you so much, Dr. Datta. Dr. Abhishek Datta is also one of our esteemed faculty partners of OpenFOAM. So thanks a lot for your talk.
Thank you. Thank you very much.
Okay, so we will move ahead with the next talk by Dr. Joseph Prabhu. Sir, please come on stage. So he is there with us at IIT Bombay today. Over to you, sir.
Okay. Good afternoon to all professors and delegates and all the students present here. So myself, Dr. Joseph Prabhu. I have done my PhD from IIT Kharagpur in the field of CFD in marine applications. And currently I am working in IR class Indian Register of Shipping in research division. And I am associated with hydrodynamics and multiphysics groups. So today I will share some what all works going on in our department and how CFD we are using in our group. Yeah, this is our office that is in LND Junction. It's nearby, quite nearby. So over 400 employees we are here, and in R&D around 60 plus people are working in our R&D division. So we normally provide classifications and certification for the ships and the marine related services. And a short history of our organization. So IRS was formed in 1974 as a public limited company to provide classification and certification service to the maritime and allied industrial sector globally. So this is formed by the initiation by the Indian government in order to support our Indian flag by the certifications to the maritime services. So initially it was VRB land occupied by the land of the ACA Corporation nearby. Later it was handed over to Indian Register of Shipping, and after that we are providing as an independent body. So it's a not-for-profit organization, and IRS doesn't receive financial grant from zone. It makes its own revenue by its operations. So we have few offices in India and outside India. So 26 in India and 27 26 outside India and 27 in India. Almost all ports we will be having one small office, and head office is in Powai. So can see in our major research activities what will happen in our group, hydrodynamics and ship structures, where I am linked to, then vibration and noise, then corrosion fatigue, then rule development. We make the rules that need to comply by the ships and ports and harbors. Then formal safety assessment, then development of new engineering tools and methods, softwares, then analysis of data from ships in service, then multiphysics. Other than CFD, we have like infrared signature, some kind of other activities we also deal with. So I will be talking more into the CFD. So CFD, actually that IMO, Indian Maritime Organization, has made new regulations like energy efficiency index. That's very, by 2015, there is no zero carbon emission policies towards. So every existing ships and upcoming ships to be built with this energy efficiency index value should be in the limitations. So if they are not able to meet this, that they need to comply with some, fit some energy efficiency devices and increase the efficiency of their shipping and propulsions unit. So here, every owners will come and approach our service in this case to provide this efficient. So CFD, the IMO has said you can perform CFD and validate your vessel whether it is complying or not. So seakeeping and maneuvering analysis. So seakeeping we will do the ship motions, and maneuvering we do for zigzag and maneuvering capability of the vessels. Then propeller cavitations. So in order to minimize the noise in the propeller, so you are an underwater radiated noise. So as IMO is again concerned about the underwater radiated noise that will be disturbed by the aquatic animals. So that should be also in limitations. Then ship airway. This we will do for specialized for naval vessels, where halo operations, where aircrafts are landing. So the airway from the upstream should not be follow into the halo operation areas. Then other than CFD, multiphysics and specialized analysis for naval vessels. Underwater noise, electromagnetic signatures for naval vessels. Our vessel should be not throw any signatures, and underwater blast. So these are the other tools we'll use for computing these services. So ship resistance. This is our kind of day-to-day work. Every ship's approval need to comes for plan approval to us. So we need to validate their reports using our, we need to compute the resistance, whether they are meeting with their effective propulsion is fine, and whether they are able to achieve the proper speeds. So this we will be, currently we are using CCM, and partially this is a multi-phase two-phase flow. So partially we will be doing a foam also in this. So next part of it will be open outer to compute the open outer characteristics of propellers. So how the propeller will behave behind the ship. So that at what RPM it should be operated and efficient operate, what will be the efficient operation of the propeller, that need to be computed. Then self-propulsions. So here we will be, finally we will be rotate the propeller, and the propeller forces will be transferred to the body. And finally we will need to arrive with the what will be the reference speed power curve, I will say that. So from there we can come, the ship can achieve a particular speed. So as per EXA regulations, they will be operating at 75% MCR, and the EXA value is beyond the limitations. The ship owner should go for power limitations. That will lead to, they need to reduce the speed, or they need to reduce the tonnages. So that may again produce a loss to the ship owners. So then next part we can see, there comes energy saving devices. So we can adopt some of the energy saving devices and improve the efficiency of the hull and propulsion unit, like that. So some examples are Mewis duct and propeller boss cap fins. So using that, we can do IMO has regularized, you can first do the CFD, and you can come with the improvement in efficiency, then you can proceed further with that. So next, this is the sea keeping of planing hulls. So sea keeping we'll normally do for the vessels where the passenger comfort is more concerned. So there we'll be checking about the accelerations in vertical and horizontal accelerations. So this normally that some coastal patrol vessels will be doing the analysis. And you see, then we always do for mooring part. We'll be calculating the tensions in the mooring lines, whether within whether the barge or the boat to be in hold in position. The next part, if you see that propeller cavitations, that we need to compute the underwater radiator noise. So as I said before, it is very keen, it should not disturb the aquatic animals and all those things. So cavitation we will be studying, and we will be using Rayleigh Peasant model to compute this. Then if you see some specialized analysis we do for airwake analysis, this is for Navy vessels. So where the airwake from the upstream should not fall in the hollow deck, where the hollow operations will be carried out. So that need to be analyzed. Then plume from the exhaust should not enter into the engine intake. So that we need to analyze at what different speeds we need to perform and different heading angles, and that to be, and finally the chafe hollow operating limits to be reported. So that's all from my side. So in part of these works are still, I am towards moving, shifting everything towards foam. We are currently using CCM as part of it. So few part like resistance and open outer, we are able to do it in foam. But 2 years back, I met Janani madam. So we are towards the making a GUI part of it. So that is the our future plan of it. Thank you.
Thank you so much, Dr. Joseph. Thanks a lot. Yeah, we look forward with another collaboration with IR class for the GUI part of OpenFOAM.
Yeah, sure.
Yeah. Thanks a lot.
Fine.
Thanks a lot.
Thank you.
Thank you. So we move ahead with the next talk by Mr. Arnab Chakraborty of TCS Research. So Mr. Arnab, are you there online?
They maybe need more.
Okay. Welcome, Mr. Arnab. Yes, yes. Could you please give permission to Mr. Arnab for screen sharing? Yeah. So over to you, sir.
Thanks, Payal. Actually, I was mute and I didn't have the permission. So, yeah. So, first of all, I would like to. So, my screen is visible?
Yes, it is visible. If you could.
Slides are visible?
Yes, yes. The slides are visible now.
Changing?
PNG is also visible. Yeah.
Okay. So,
Please make it.
so first, I would like to thank Professor Kannan, Dr. Chandan Bose, and Payal and the whole team for inviting me for this wonderful event. So I am Arnav from TCS Research. I am working here as a scientist. So basically, I am in a group of industrial manufacturing. Here, basically, we deal with the projects related to the process industries, some process modeling. Those are relevant to the tablet coating, 3D printing, and many other things. So here we basically use some commercial softwares like ANSYS Fluent, MATLAB, or the COMSOL, and nowadays we are shifting our interest towards the OpenFOAM because as you know that so for the commercial software, the licensing is an issue, and another thing is that they are very costly. So, and nowadays the OpenFOAM has gained lots of popularity. So continuously we are shifting our research or our projects into the towards the open source softwares. Yeah. So today I will be presenting the droplet dynamics in industrial manufacturing. This is the part of my work, so we cannot disclose all the results. So so let's discuss few of them. So yeah, so the overview of the talk will be the background, the novelty and objective, the computational setup and validation of the model, modeling of spreading parameter and image processing based approach, the parametric studies, that is the effect of impact velocities, inclination angle and static contact angle, then the effect of non-sphericity of the droplet on its spreading dynamics, and then we will discuss some machine learning techniques in modeling the droplet dynamics, and I will conclude this talk. Now, coming to the background, as you can see that the droplets are present everywhere in the nature. So let's say one droplet is carrying some viral load or bacterial load, and it impinging upon some surfaces, the leaves or some surfaces, and it spreads. So based on its spreading, basically, yeah. So from the central, let's say this is the spreading or the maximum spreading. So based on the spreading, one can evaluate that how much the viral or the bacterial spreading will can damage the leaves or the surface. And similarly, in the second image, it is the disease transmission, and in the third image, as you can see, this is the surf zone where the waves are breaking off and produce some minute droplets or the sprays, and these droplets evaporates and change the local dryness fraction of that region. Eventually that contributes to the climate change. And the fourth image, you can see the disease transmission via sneezing of droplets. So it was a very serious issue during the COVID times. We all know that. Now, coming to the industrial applications, so all of those previously this mentioned applications were found in nature, but now coming to the industrial applications, that you can see that so when a droplet is impinging on a wind turbine blade, eventually based on its dynamics and the trajectory, the erosion occurs. Okay. And how that erosion will propagate, that depends on the many things, the impact velocity of the droplet, impinging angle, the medium of the droplet, because when the droplet is impinging, it is not the fully water, it is somewhat acidic in nature, and sometimes that contains some aerosol particles also, because yeah. And let's say this is a gas turbine engine. When, let's say, these engines are going through the volcanic ash or some erosive medias, or let's say the yeah, so the droplet eventually come into it, and it uh, erode the blades, the compressor blades. So droplet turbine blade interaction is another important aspect of the droplet dynamics. So there are lacuna in the literature we have listed here, that it is imperative to mention that most of these studies were experimental, and most of them reported the post-impact dynamics of the droplet and an inclination angle of 60 degrees. Above that angle, there is no literature available. So it could be observed from the few numerical studies also that the dynamics of the droplet changes in tangential direction above 70 degrees, while there is no mention about the post-impact dynamics on the droplet in the lateral dimension. So we need to carefully observe what is happening in the axial direction as well as in the transverse direction also. All the previous studies were focused mainly on the rebound and splashing regimes, but there is a substantial gap on the literature for the deposition regime, which is having direct implementation in the spray painting, tablet coating, 3D printing, and metal additive manufacturing. Because based on that, one can ensure the required efficiency or required efficacy of the coating. Okay. So all the previous studies talked about the dynamics of spherical droplet only. However, if the droplet is larger, or in case of polymeric droplet that encounters in many chemical applications, cannot sustain its sphericity and becomes non-spherical while impacting. So there is no literature available on the discussion of the dynamics of non-spherical droplet upon impacting an inclined surface. So the droplet turbine interaction is a major issue, as I mentioned above, and there are very few numerical machine learning based studies available for predicting the droplet dynamics. So we invoke a few of them, and very few numerical studies available for the dynamics of the droplet on plane having different kind of motions, whether it is a 1D translation motion, or it is a 2D or 3D translation motion, or a rotational motion, or combined of both motion. So we have investigated that. So that motivates us to further proceed with this study. So these are the motivation and objective of the present study, that all the previous studies were mostly experimental and reported at a higher Weber number. So in the present study, we numerically investigated this post-impact dynamics of the droplet on inclined surface over different Weber numbers, and the inclination angles and the static contact angle. Static contact angle means you are changing the surface every time. Now, the effect of droplet shape on the dynamics upon impacting an oblique surface over a wide variety of these influential non-dimensional numbers. And then the tangential and the lateral spreading factor, contact time, sliding length, the leading and trailing edge lengths, the regime plot of different dynamics, time evolution of the pressure, velocity contour, and the different dynamics over a wide variety of these non-dimensional numbers were investigated. And finally, we invoke some machine learning based techniques to predict its dynamics. So there are the challenges. So we know for the numerical modeling, there are lots of challenges. So I'm not going into the detail of it. Now coming to the computational domain. So as you can see, this is our fluid droplet, and we have used water here, pure water. And this is the whole computational domain, and the surface is at an angle of alpha. So for the validation purpose, we have taken it for 80 degree. And the initially impact velocity u0 is 1.5 meter per second, and the size of the spherical droplet is 2 mm. Now, normally in ANSYS Fluent or in any CFD, commercial CFD software, people used to write UDF, their own UDF. But the thing is, sometimes this UDF doesn't work good. There are lots of patching issues. That's why we have developed our own image processing based techniques. That is, first we used to do the CFD simulations. We make its time resolve animations, and then from that we are extracting the image frames of that. Then we are converting these RGB images to the grayscale using in MATLAB, and then from the grayscale we are converting those grayscale images into the binary images using some proper intensity thresholding, and then we verify whether and then we are tracking these two extreme points of the droplet on the surface, and from that we are calculating the spreading diameter. And in a similar manner, we used to track the vertex of the droplet, how it moves downwards and downwards during the spreading and upwards during the retraction. So then we compare these results with the literature and see if it is having a good match. If not, then we repeat to this step and change the intensity thresholding and again run this loop. So yeah, so and finally after simulation and after obtaining all the CFD data, we have used the AdaBoost algorithm, and this table is as an input for this AdaBoost algorithm. So there are other algorithms also. So we have used only the AdaBoost here to show the machine learning based modeling, and this is the simulation setup. I'm not going into the detail. Yeah, there are certain simulation assumptions also, that there is no heat transfer. We did not consider any heat transfer. Eventually that leads to the isothermal assumptions, and the droplet volume is constant. The liquid density is independent of temperature. The temperature has no influence on the viscosity of the liquid, and the liquid is incompressible, whereas the outer air medium is compressible. Now coming to the results and discussions, before that, this is the grid convergence and the and the comparison of the schemes. So let's say this is a initial droplet, and this is the inclined plane, and it hits the surface. Eventually it will go in the this downward direction. We are saying it the axial direction, and from the top view we can see the perpendicular plane, the perpendicular plane on the perpendicular surface on the same plane is the lateral dimension. So we are calling the distance from the touching point to here is the trailing edge length, and from the leading edge to these touching points is the leading edge length. And yeah, so now coming to the grid convergence, as you can see, we have used the simple scheme of different mesh size, and finally we have chosen this 0.12 mm mesh as optimum, and 12 black elements were used. And further we varied the scheme, the simple and piezo. Now simple is simple, that's over a piezo. That's why we use the simple in the overall simulations. Now coming to the quantitative validation and qualitative validation also. Now, so the first one is from the Guan et al. These are the numerical results. The second one is from the Sikalo et al. These are the experimental results. And third one is our results. And one can see they are good in agreement. So the qualitatively they are matching. Now coming to the quantitative validation. So we validate for the spreading parameter. So this xi is nothing but the instantaneous diameter of the droplet divided by the initial diameter of the droplet. So this is nothing but the non-dimensional spreading diameter of the droplet with respect to the time. And we compared our result with the experiments performed by Saho et al. And the error was found to be around 3%, which is below 5%, so it is acceptable. Yeah. Now these are the few videos of the effect of impact velocity on the inclination angle. So the first one is the Weber number, the of 0.05, the second one is the 40, third one is 80, and fifth one is 150. So from first one, you can see this always shows at a very low Weber number, it shows the deposition regime, and the second one is at Weber number 40, it is showing the rebound characteristics, and for higher Weber number, which is more than 40, kind of 80 and 150, they are showing the splash. So all
Sorry
of
to
these simulations
interrupt.
are at 30 degree. Yeah.
Arnav, can you please wrap up
Yeah.
for the rest of time?
Okay. Now we have varied the inclination angle to 45-degree and 60-degree. Now one can see that now at 80-degree the droplet is not breaking. That shows the prominent effect of the inclination angle. So these are the quantitative results, and we derive some correlations in terms of Weber number and the inclination angle. Okay, so these are the we have measured the different leading and trailing edge for different Weber number as well as for different angles. Yeah. So now these are the regime plots. These are the deposition and rebound and the splashing regimes. Now we varied the static contact angle. That means the solid material, the surface material, and that shows the different characteristics. Yeah. So these are the quantitative results again. Okay. So yeah, now coming to the machine learning part. So after obtaining those results, we have developed this AdaBoost algorithm, and we are calculating these matrices that shows the effectiveness of model, and one can observe that it is the accuracy is 90% and the precision is 91% around. So we are still improving the accuracy, and the precision can be improved. We are having we don't have a large data set. We are still running the simulations to acquire more data, then we can tune it finer. So these are the conclusions. So at a lower inclination angle and Weber number, a lower SCA or the static contact angle results in a greater spreading factor due to the hydrophilic nature of the surface. As the SCA increases beyond 90 degree, the surface becomes progressively more hydrophobic, and beyond 120 degree, it stands to be a super hydrophobic, leading to a decrease in a spreading factor. At a higher Weber number, the partial splashing was observed across all SCS up to the inclination angle of 30 degree. When the inclination angle reached 45, the droplet dynamics shift from splashing to rebound again due to the increased axial momentum transfer caused by the higher inclination angle. Now, the classification-based machine learning algorithm AdaBoost was developed to predict the droplet dynamics based on the CFD results. As I said, it shows the 90% accuracy, and still we are increasing its accuracy by providing larger amount of data set. So that is the conclusion. So here I am showing some ongoing projects, that is the droplet impacting on the translation surface, and here we have not introduced the turbulence. Soon we will introduce the turbulence to make exact what happens on the droplet impinging on wind turbine blades. And these are the we did this validation with these experiments by Zhang, and our results are giving around 3.5% error. And these are different regimes of yeah. So after impacting on the translating surface, yeah. So thank you.
Thank you so much, Mr. Arnav. Please stay back, because after this two more talks, we will start the panel discussion. So next, I would call Mr. Nikhil Bhamare on stage. He's there with us today at IIT Bombay. He's the founder of the startup CFD Baba. So over to you, sir.
Thank you.
Hello. Hello everyone. I am Nikhil Bhamre, and today I will be talking on OpenFOAM beyond academia. That means what will you do after learning OpenFOAM and how to go for industrial applications. So for today's discussion, the flow will be that we will first discuss a little bit about myself and my first OpenFOAM problem. Then we'll discuss for the student skills required for industry and what students can do after learning those skills. And we'll go towards the closure of PPT, and if time permits, I'll show one small case study which is quite interesting. So I started with CFD Baba channel in 2019, and in 2023 I was suddenly ranking among the top CFD creators worldwide, and then people keep giving my reference as a influencer. So these photos were posted by Simon Fisher, who is at rank 11th himself, and I am very privileged to be among all the top CFD creators all over the globe. But my main interest is to promote OpenFOAM right now to the Indian students. So my first CFD problem, I did it when I was in Suzlon One Earth. It is a windmill company. So the project was thermal housekeeping of wind turbine nacelle using OpenFOAM. So I went to the company. They said in 2018, the company was not too good at that time in terms of financial status. So they said they don't have money for license. You need to do it in OpenFOAM. So I did my MTech project using this same problem. So here you can see this problem. It had two fans as inlet, two fans as outlet at the top, and there were heat generating components. So what is this nacelle? If you have observed wind turbine closely, you will see that behind the wind turbine blades, there is a box-like structure. That is called nacelle. Inside nacelle, this shaft is connected to the wind turbine blades. Then there is a gearbox, and then the mechanical energy is transferred through the coupling to generator and then converted to electric energy and sent down through the tall towers on which the windmills stand. So in this problem, there were many models together. So every time you go to solve industry problem, you will rarely find a single model problem. You will have to use multiple models in your problem. So in this case, I had to simulate fans with fan curve inputs. Then there were volumetric heat sources for gearbox coupling generator. Of course, there was turbulent flow heat transfer going on. And at the bottom opening, there was porous medium. So all these together in 2018 was quite rough, I must say. So I started with learning the mesh first. So I remember the first day when I meshed this CAD model, which is 3D, very complex inside. And it was quite happy moment for me, and things didn't stop after that. So the problem was that this coupling here was exceeding the acceptable limit of temperature. And they wanted a solution, quick solution, without spending much money on how we can increase the cooling of this fluid coupling. So the solution I proposed was that we can extend the length of fan 4 duct and we can increase the speed of the fan slightly. So as you can see in this velocity contour plot, the air is now moving into the duct. And here in the temperature plot, we can see cold air coming in from backside, taking the heat from generator fluid coupling, successfully going out through the duct. Earlier, it was not happening because duct was very small, fan was very slow. So this is how I solved my first OpenFOAM problem after lots and lots of struggle. But I had time at that time since I was in masters. But then I realized that there are no sources which can help Indian students to solve complex industrial problems. There were sources to solve simple 2D problems, but not 3D complex industrial problems like these. At that time, I got the inspiration and motivation to create CFD Baba channel, where I started teaching students how to deal with such complex problems. Not directly the complex problems, but the steps. So there are two parts. One is component level analysis and second is system level analysis. So I try to focus on the component level analysis, and then every CFD problem is different. So students can navigate their way and learn to do the full system problem from my component level simulation tutorials. So the student skills required are not one or two. They are a combination of many skills together. So we will talk today one by one on all these skills. So the very first skill is understanding the problem. So I mainly created this PPT to help Indian students who are trying to navigate their way into industry using OpenFOAM. But I don't see any students here. Also, I see 40, 50 participants, but we have good professors here. So please, if you find anything helpful, pass it on to your students. So the understanding the problem means how much 3D CAD model should you create in the software on which you want to simulate. Second, you need to know material properties, boundary conditions, and the physics or models or equations that you need to solve. So all these things must be clear even before you touch your computer. You also need to know what output you want from your simulation. And also I would say that CFD model is just a virtual model of the actual problem. So create your CFD model, try to create as close as possible to the real flow. And another thing, if there is any other alternative than CFD, then please use that method to solve industrial problems, because companies love it if you save some money. So it can be done using, by creating tools in Excel using empirical formulas and so on. So I wanted to show this one thing. I had created this simulation using a real life problem. So one day in bathroom, I saw that the mug was rotating inside the bucket. It was very interesting to watch. So I thought maybe I can model it in CFD. So I opened OpenFOAM. I used Interfoam solver, and I was able to replicate the real world phenomena into CFD solver. So as you can see here, the vector arrows in the second video, simulated video, are also going round and round. That means the water in my simulation is also rotating. So try to find problems around your vicinity. Try to simulate them in OpenFOAM. That will help you build your portfolio, and it will help you become better engineer. So the next skill is CAD. So how many of you can create this simple 3D CAD if any software of your choice given to you? So from audience, many less people will be able to do it, I think, because we don't focus much on CAD aspect. But in industry, it is mandatory. You need to know basic operations like Boolean, extrude, revolve, blend, pattern. It is not even hard. It is very easy, but you should invest time at the right moment and learn these things. Also, if you are going for any new problem, don't directly go with 3D problem. Try to start with a 2D plane cut out from your 3D problem. Of course, it is not possible for all problems, but whenever it is possible, do it. In this case, on the left side, I have a 2D CAD model of a Santa Claus with reindeer. I simulated it in Christmas 2021 just for fun. This is simple foam. And we see that the reindeer at the very beginning has a lot of pressure on it, air pressure. Next, next we require cleanup skills because in industry, no one will assign you a dedicated design engineer. You have to do it yourself. You have to learn to modify the CAD that you receive from the customer. You should be able to remove unwanted parts and simplify the model to avoid complexities in meshing, which is our next step. So basic things again, perform all mesh quality checks. Don't skip anything. Don't think that it is okay if some quality check is failing. And also give systematic named selections because it makes your work very easy in the solver setup part if you have systematic named selections. Also, for a new problem, start with a coarse mesh and see if solution is running. Don't directly start with fine mesh because if you run it for hours and hours, later you come to know there is a small problem in boundary condition or something. All the hours are wasted. So that's why I try to use this approach. There is one wedge model in the extrude mesh dict of OpenFOAM. So this wedge model allows you to model only a part of your cylindrical geometry. So if your geometry is symmetric in cylindrical coordinates, please try to use the wedge model. You don't need to model the whole CAD. Just model a part of it and solve it, and it gives fairly accurate results. And when going for 2D mesh in OpenFOAM, if you see here, try to create only one cell in the third direction. Don't create more than one cell because it is a waste of resources. And if you follow all these points, then one day, even you will be able to mesh this complex lion. You see its nails have been captured in the mesh. Its mane has been captured in the mesh. By the way, this is snappy hex mesh. And if snappy hex mesh can mesh such a complex line, then of course it can mesh the mechanical industrial parts easily, I think. Next is the solver setup part. So many times puzzling things can happen when you try to attempt new industry problems. So I'm currently working in Cummins, India Limited as a senior CFD engineer. So they use commercial tools only, but I am trying to bring in OpenFOAM into the company. And I have already placed the roots of OpenFOAM into Cummins. Last year, I have simulated a simple geometry in Cummins, the Cummins geometry in OpenFOAM for flow analysis using simple foam. So now I'm leveled up the complexity this year. I took on actual problem which they solve in ANSYS Fluent and tried to do it in OpenFOAM. So there is this thing in my geometry, the flow is above 100 meters per second, very high velocity. And I am trying bind simple foam because there is heat transfer involved. So the rho or density value explodes every time I try to run the simulation. And it stops with a negative initial temperature error. So if you face any such errors, always read and try to find the source of error. And the best thing I can recommend is CFD online forum. It contains lot of knowledge from years of OpenFOAM users where you can check. So I checked it. They said, check the mesh. So I reduced the complexity of the problem, made it a simple pipe with varying diameter, but still it diverged. Then they said, check the boundary conditions. I tried with various boundary conditions, but still it is diverging. They said then bind simple foam is quite unstable. Try with the transient solver for a few steps and then switch to steady state solver again. But even that did not work. So currently I'm working on this problem. If any one of you has faced any such similar issue and overcome it successfully, then please reach out to me and I will be happy to discuss further on this problem. Next step is, the next skill, the main skill, post-processing. So you need to explain your results in simple language because most of the times the people who will take the decision won't be CFD people, they will be management people. So if you go into the intricate details of CFD, they won't really understand it. So explain properly with as many images and also variable plots as possible. That will give a better picture of your problem and solution. So a tip would be you can display CAD and multiple variables, like in this simulation of Ahmed body. I am showing the CAD model, I am showing the mesh, I am showing the pressure values on the mesh grids, and I am also showing the velocity vectors, the velocity streamlines. So it is showing 4 things in a single image. Even in this video here, I am showing the walls of the Pelton. This is Pelton turbine. Walls of Pelton turbine are pressure colored. There is velocity streamline and geometry is also seen. It was dynamic meshing. So what happens after, suppose if you learn all these skills, then what happens? So if you want to go in application side, you should have command on CFD tools. If you want to go on development side, you need to know CFD tools and coding and also mathematics. So the thing I would suggest is that create a good portfolio. It can be done in form of PPT. Choose your best complex problems and do at least 20 problems hands-on to fill your portfolio, because your portfolio will speak louder than your words. And once you will come to know in which domain you want to enter for your job, then once you finalize your domain, make it domain expertise, because if you don't have domain expertise, people won't prefer you in industry. They want people who can simulate and give end-to-end solutions for their problem. So there are multiple streams, turbulence models, porous medium, heat transfer, heat sources, multi-phase combustion. And we also have LinkedIn, where you can go and approach CFD professionals after you learn these skills. But then you will ask, how do we do 20 problems and best complex problems if we don't have a job? So you can start with CFD model from research papers. Research papers are your best companions right now to enter into the CFD world. So try to find CAD model, material properties, and boundary condition from research papers and simulate them yourselves in OpenFOAM, because it doesn't cost money. So I'm thankful to all FOSSEE members for this opportunity. And I'm trying to encourage and implement usage of OpenFOAM in Indian CFD industry. And I think so today I saw that the vision of FOSSEE and what I'm doing is almost similar. So we can join forces and we can achieve this with the help of FOSSEE. So from CFD Baba side, I'm ready to offer all the help that is needed to achieve this goal and to collaborate with FOSSEE. So here is a link to some of my tutorials. So all the models that I mentioned above are there in these tutorials. You can check them out on Udemy under the name of CFD Baba. More than 4,000 students have enrolled worldwide, and most of the students are from India, Turkey, and Egypt. So the best way and the most secure way to contact me is my email ID, cfdbaba@gmail.com. I also have my website where I have uploaded some CFD courses. I have my YouTube channel with more than 500K views, just CFD content, nothing else. No shorts, only long form. And I have some followers on LinkedIn. I am active on LinkedIn, Facebook, and Instagram as well. So there was this small case study where I simulated. So I got this project from Libya. I simulated a Sabartha platform topmost level where you can see this helideck, this helideck. So the problem was that there were 4 points: north crane, south crane, racking board, and helideck. People used to work there most of the times. Now what happens? This is a oil mining rig. So this platform mines oil and harmful gases are emitted from these exhausts. So if SO2 ppm coming out from these exhaust gases is more than 5, people might faint or even die. It is very harmful for people. So we did this simulation and found out that the SO2 ppm levels were under acceptance criteria for all these points, and it was safe to work on them. So if you take CFD seriously, it can even matter for human lives. This is just one simulation, but we had to simulate wind flowing from all the directions. This is just wind flowing from helideck side. So thank you for listening patiently. In the end, I would just like to say, if you want to become an OpenFOAM hero, you need to start from zero. Thank you.
Yeah, thank you so much. The ending dialogue was really good. Okay, thank you so much, Mr. Nikhil. And our last expert talk will be by Mr. Saurabh Mukhopadhyay from John Deere Private Limited, India. Okay, so over to you, Mr. Saurabh.
Thank you, Payal, for introducing me, and thank you for the opportunity, Professor Chandan. Thank you for the opportunity for Professor Kandan. Yeah, I'm just going to share my screen. Let me know once it is visible.
Yes, it is visible now.
Thank you. Thank you very much. So yeah, about me, this is Saurabh Mukhopadhyay. I am pursuing my PhD from IIT Kharagpur, and also I am working in Deere and Company since last 8.5 years. So I completed my master's also from IIT Kharagpur. So I just work as a CFD DEM analyst, and majority my expertise is in the CFD DEM domain, particle flow, airflow in that domain, multi-phase flow. So I will share some of the cases whatever we do in industry level, as well as also some of the cases, potential cases we are also exploring through the open source software. So that part we will go ahead and share. So let's look at it first. I think whatever agricultural product line I generally work on actually, and especially I can say that John Deere dealt with actually. So that's tillage, tilling, soil tilling. Soil tilling is regular interaction with the soil and cutting the soil, cutting the residue of the soil, digging the soil, and that part. After that, seeding and planting. If you look at whenever seeding and planting is planting the seeds into into the soil. Actually, spraying operation, that is something a major business for John Deere. And I majorly work in this area, actually, sprayer. So spraying operation, if you say, we have to model the spray, and after that how the spray is getting drifted, lot of things comes into picture. I'll cover that later slides. So harvester is that, whenever, hey, crops had grown, so crops had grown, at that time we generally cut the crops and take the crops and harvest the crop ultimately. So entire this agriculture cycle, if you look at, this is actually designed to show, according to the agricultural cycle. Actually, if you look at the agricultural cycle, first tilling operation occurs, after that seeding, planting, and after that spraying operation, and at the end, of course, harvesting. So entire agricultural cycle is tried to covered, through this slide. So generally, where we apply CFD in agricultural product line, so we do vehicle thermal management, underwood thermal management, also we do soil tilling, planting, metering, spraying, cavitation, FSI, tank sloshing, FSI, and also we do some sort of solution mixing, etc., that kind of problem. So we generally deal with this kind of interesting problems. And I'll first show some sort of interesting problem. If you look at, in the world of the agri-machineries. So actually, whenever spraying occurs, actually spray got drifted in the downstream. So what we do with the spray modeling here. So primary and secondary breakup, considering the effect of the Reynolds number and the Weber number, and we model it. And after that, we have validated methodology. I cannot share further data for the purpose of the confidentiality. And yeah, so after that, whatever spray characteristics we get at the downstream, maybe 5 centimeter, 10 centimeter downstream, we use that spray data in the full model, and we get the how the spray is getting drifted, how the spray is getting recirculated in the downstream, over flow over, it is a flow over like a blob body, if you see the downstream. So how the recirculations are occurring in the downstream. So that what we want to capture, we try to capture generally. So that's something interesting problem. Tank filling, for this one we use the open source software lights. So we try to understand how the material is getting filled while filling operations. We design the tank accordingly. The corners should be filled properly, there should not be any void. So that kind of stuff we generally use, discrete element modeling lights tool, and we try to model this kind of stuff here. If you look at granular segregation, this is mostly from my PhD work. So there is a common example of the CFD-DEM coupling. If you look at generally pulsed fluidization, we generally used for segregation purpose. So segregation, if you look at the segregation purpose, actually for the particles of high density and low density, actually uh, through pulsed fluidization, we often segregate them. So we use CFD-DM coupling for this kind of complex phenomenon. And of course, means we are using commercial software for this kind of complex phenomenon modeling. But yeah, so but the thing is that there's a lots of opportunity in the using the open source software. This is a implicate example of the strong physical problem, as well as if you go into the deep fundamental analysis as well as industrial applications. So we have a lot of application of the granular segregation using threshing, or in the harvester point of view, I'm saying threshing operation. There are a lot of operations often we do in the pharmaceutical industry, mining industry, a lot of application of the granular segregation using this CFD-DM coupling. So there is a lot of opportunities are there in this area to further explore and get more value added in this area. So this is something we often do, I mean, in all the industrial applications. So yeah, this is a common example of the CFD-DM coupled analysis, and we have got very good correlation with the physical test performed by Lee et al. And we have further extended the study for parametric variation of the this particle density ratio, flow parameter, sinusoidal flow parameter, as well as triangular, as well as exponential flow parameter. So that kind of stuff we often do. So yeah, again, I'm going for one of the most interesting example for the DRN company. So this is one of the most tricky actually part for the seeding and planting. If you look at seed meter, so if you look at this seed meter modeling, actually this is one of the most complex part of the DRN company. So we generally I cannot share further data about it because of the confidentiality. This is a YouTube video, you can look at it. I can also share the link. So this is something how the seed meter works actually. So there is a vacuum seed meter, and we also virtually model this kind of complex phenomenon, and we had a very good correlation on that front and using CFD-DM coupled analysis. So this kind of stuff can be used to this kind of complex capability can be utilized in the industrial level. And yeah, of course, this is for this kind of stuff we use the star CCM plus. This is a commercial software, but on the other hand, again, for the low fidelity comparatively, the model of the lower level of model, we generally use kind of open source software, OpenFOAM or Lite. So that's a part. Of course, there is a long way to go if I talk about the opportunities in the industry is well acquainted about this open source software. And yeah, of course, there is a long potential for this open source software in the future, and industry has a strong eye in this area. And we are definitely looking at it if we can explore further opportunity in this area. Yeah, thank you for this opportunity again, to Professor Chandan Bose, Professor Kannan, and yeah, everyone, thank you for listening me through.
Yeah, thank you so much, Mr. Saurabh. Please be with us. Very shortly, we're going to start the panel discussion. So, yeah, I would request all of you to please come in the first seat so that we can have a face-to-face interaction with the people who are joining online. So I would request all the advisory board members to please switch on your camera so that we can talk to you. And Professor Chandan Bose will be handling this panel discussion.
Okay, thank you everyone for being with us actually. It's a long day, but I hope that all these expert talks actually enlightened us with the real life applications, and I learned a lot because mostly I come from academia and I have limited experience in working in the industry, and mostly I worked in the industry of fluid mechanics or civil engineering. So I think it's a great learning experience for me, and I hope that all the audiences have also learned more, and the students, if there are some students in the audience, they have got enough motivation to learn more about in-depth CFD techniques, particularly the use of open source tools. So I have all our advisory board members that we onboarded today with us to have a discussion, and I have also requested Professor Somnath Roy from IIT Kharagpur to join. Probably he will join if he can get out of the meeting he is in, so that we can get a broader perspective from the academic side, because he is one of the leading CFD developers in the country. So, and from my perspective also, again, we are interested in developing both in-house computational fluid dynamics code as well as developed under the open source software or open source libraries like OpenFOAM. So let us try to discuss some of these aspects from your perspective of an industry. So the first question probably I will ask, and you can one by one answer. So through the expert talks that you have provided, some of you actually are completely based on OpenFOAM or open source tools, and you are trying to promote it, and based on that you are using it for your company or organization. Some of you are using only commercial tools, mostly because of the legacy of the company, or you are trying to get into the open source domain. And some of you, interestingly, are using both. Like in some process you are using commercial CFD softwares, and in some processes you are using open source softwares. So what are the pros and cons of the commercial CFD software? We already know. We know one of the major impact is the cost impact. The license costs are very high. And the second point, we already know that it's almost like a black box, because due to proprietary software issues, we do not get to see how we are implementing these CFD techniques. So on the other hand, I would like to ask your experiences on what do you feel about transitioning to an open source domain, or starting with an open source computational fluid dynamics domain. What are the challenges do you see, and what are the opportunities you see? So what are the challenges versus opportunity? So if I may request one by one, if you take your views on that.
So first of all, commercial software, in terms of commercial software, makes you lazy. So the proper word will be a lazy. Because I know during my BTech, I started as a fluent, and once I see the user interface of the fluent, you'll get the addicted of it. Then it's hardly possible to you get open source software, because once you are paying the money, they are giving you good interface. That's what the drawback. And if you want to add up the OpenFOAM, I think it's best to order when you are in academic, because that's what you're starting of the career. Now I started with Fluent. It's way hard for me to get a platform like OpenFOAM, because this commercial software addicted me and made me a crazy or lazy, I would say. And I don't want to spend my lot of time on solving equations, solving bug. Instead, I would like to pay money for the licenses and get the work done quickly. So that's what my experience.
Okay.
Yeah, am I audible? Okay, so if we think about this, we can put this in three ways. Okay, one is software support. When if we are stuck, an engineer may not have time to. First of all, the proprietary software is the bonnet's not open. You cannot go in and fix the code. You have to approach support. And the commercial tools, they provide support on call. I mean, you call them and they tell you if it's going to work or not. Second is responsibility of solving the problem. Like if you are working on something urgent and you need the results very quickly and the solver is not able to solve it, the commercial tool can take a responsibility and tell you your problem is difficult, you won't be able to solve it quickly. Okay, so it's not up to the engineer who knows the in and out of the code telling the management that my code can't do it. It is the commercial tool who takes the responsibility. Our tool, what we are providing you, is not able to solve it. We will include it in the next version or something like that. We have taken it up for development. Third is, and this one is pretty odd. It's from the IT perspective, it's from security. Okay, now I have struggled to get OpenFOAM on board at Waptec for the past couple of months. And one issue is IT told me this is an open source software. Anyone can contribute it. Anyone can make a backdoor in it and hack into Waptec systems. Okay. I told that's very unlikely. The software goes through a lot of review and this may not be a valid reason for not allowing OpenFOAM inside. Last week, suddenly I got access to OpenFOAM. You won't believe it. Okay, so now I can implement OpenFOAM inside, but this was IT stance for the past 8 months.
Okay, good, very good insights. We can discuss it later.
Yeah, in IRS we use both OpenFOAM and commercial softwares, but the way commercial software is moving towards, as per my perception, they are moving towards cloud-based computations mostly. After some time, they may stop their perpetual licenses, and they will be moving to cloud-based. So whatever simulations we need to do, we need to pay for it. So as of now, if you have our own like foam or something, we can n number of simulations. Now, as of now, okay, commercial, they will professional, we can do n number of simulations and we can run it. But when it comes to cloud-based kind of thing, so every error, sometimes we can't make a simulation perfect in a one go. So for that also we need to pay for it. So in conditions we can't able to afford it. So we are slowly we need to move towards the open source things like kind of OpenFOAM for our CFD things and other softwares for other purposes. So FOSSEE is taking towards the right directions. So only currently is like what makes difficult to using OpenFOAM. We don't have a proper GUI and interface. That FOSSEE is working, and I am also working towards it. So in future we can make through it. Thank you.
Okay, thank you.
Okay, thank you. So I'm from academia, so I'll speak something related to academia. But before joining academia, I was working as a CFD engineer in a German company. So where I know what problems, so what as an engineer we used to face. So while working in company, I realized we were doing the repetitive jobs and we are using tools like commercial tools. So where we won't learn much thing, but we were doing clicking those buttons. So with the pros of OpenFOAM, we have the ability to learn. So that's what a positive point about OpenFOAM. But then comes negative thing is we have the time issue. So if we have to learn something, then you have to spend a lot of time because companies, if they face if you face any problem, since you are the purchaser of a license, so you get the help from the company. So they solve your problem. But in OpenFOAM, if you are stuck somewhere, then you are the one who are heading or you are the one who will put your head onto wall and you have to struggle a lot. So that is where I think with FOSSEE we are trying to do with the students.
I think, the same point came out again, and we will discuss these things. It's a major issue of the responsibility, right? Yeah, thanks for pointing that out.
Yeah. Hello. So I don't think there is much left to be said because all the points almost are covered. But still, it is about the blame. Who will take the blame at the end of the day? So will it be the software company who is selling the software, or will it be the company who is executing the project? So for commercial softwares, the blame can be easily transferred. But when you go for open source, you have to take the blame. So that is one thing which happens between commercial and open source. And the second thing is open source, especially OpenFOAM, is better if students start using it from their academic years because it teaches you a lot about the basics that you need to set up while doing a simulation. The first thing that you need to set up in transport properties is the kinematic viscosity of the fluid if you want to simulate anything in OpenFOAM. But most of the ANSYS users don't even have idea about kinematic viscosity because they don't need to. ANSYS automatically takes the value from its database and enters it into their GUI. So that's why people can't learn much in depth about CFD if they use only commercial tools. So they should switch between commercial and open source tools as and when required. Just try and see and gauge whatever your problem is and which tool will solve it fast. At the end, we are here to solve CFD problems, whatever tool it may be. Thank you.
Thank you. So I am from academia, but some idea with the industry. So the two things I feel the transition is difficult because one thing is the operating software. Like if you are using Windows, you already become lazy. Now you want to use OpenFOAM. Now fortunately, OpenFOAM is now available for Windows also. But the way it works is totally different from Windows. You are not habitual. So it looks difficult from shifting to something where you have to put your brain. So I think one of the thing can be do to improve the usage of OpenFOAM and all open source software is that we shift to Linux based operating system rather than Windows, which will save the money and also again promote the because the command structure and everything is similar to OpenFOAM. So that will have the transition simple because you will not feel any difference because you are already aware of it. Second thing I feel, and from the industry, as they have rightly pointed out, if your client have constrained you to use ANSYS, whether you like it or not, you are expert in OpenFOAM. They won't accept result in other than ANSYS. So we have to talk to industry. We have to discuss with them what exactly is their need. That if we fulfill that, they will accept the results based on OpenFOAM. That will help to extend the usage of OpenFOAM in the industry. Otherwise, it will become only an academic affair. We all are discussing. It will be students are learning, but industry won't accept. At the end, you have to shift to some commercial software or like this.
Yes, true.
Thank you.
Yeah, that's why I think this kind of dialogues between the academia and industry is needed, so that we can understand where are the challenges and how can the academia or people who are spending a lot of time developing new tools or developing new frameworks can then be integrated to the industry. But again, it is not easy. Of course, I think I will come to the point which I discussed in a bit of quite a few panels, is that the mindset of the senior authorities in our industry, right? And also the client, as you said. So we have to convince them in a way that the open source tools can achieve the similar things in an easier way, in a more economic way. And that's where probably we need more of these discussions which reaches to them and then starts convincing them, right? So I'll go to our online advisory board members. We can start with Advait. Advait, do you want to share your views on that?
Right, right. I mean, definitely, there's a lot of resistance in industry in adopting OpenFOAM. But one thing that I've noticed that when it comes to very cutting edge technologies, especially when we talk about defense and military, in those areas, the realization has come that commercial imported software, there has to be an alternative to that. They're not fully moving away, but they're definitely investing heavily on developing indigenous software, if not fully, but if not fully, then in that case, at least utilizing the existing open source libraries. A lot of amazing codes are written at Los Alamos, Sandia Labs, Lawrence Livermore, not just OpenFOAM, uh, and they are heavily exploring those codes. So I think 2 years ago I felt it was a very different story, but today I feel very positive working on OpenFOAM. By the way, we work 100% on OpenFOAM. We do not have a single Windows computer in our office. Everything is on Linux. Everything is on open source software. And I think at the end of the day, if you deliver good results to the clients, especially clients who really care about CFD, they don't pressurize us to use ANSYS or other software. I mean, we haven't faced that problem personally. But yeah, you have to deliver accurate and good results with the ownership as well if something goes wrong. So those are my views on that.
Right. Can I go to uh, Dr. Day if he's there?
Yeah, am I audible?
Yeah.
Yeah, so yeah, it was a very interesting discussion. So here I would like to post a new dimension to this discussion, because what is happening is, like a place like NAL, we have liberty of using commercial codes as well as our in-house codes as well as the open source codes. So generally the debate which we will be conventionally come across is like a open source versus a proprietary code. But here, when I have spoken with the different groups who are dealing with the CFD simulation, I have also come across debates happening on in-house codes versus open source codes, and surprisingly, open source code versus an open source code. For example, I just, in the second part of my presentation, I have showed Dr. KNV's work, where they have used open source code, OpenFOAM. For sometimes they were using it for even the aircraft programs. And then at one stage, when I checked with them, they said, no, they have switched over to SU2, which is the unstructured code from Stanford University. So always there will be, sort of a debate on these. It need not be that it will be only an open source versus a commercial. We can also see that the transition can also be questioned based on these kind of observations. But of course, at the end of the day, it is more like, what is your application, especially for people like us who are trying to solve scientific problems. We will see that finally which tool is being is going to help us to solve our problem, and then we adopt to that particular tool. We have that liberty at NAL to do, unlike many of the industries or even academia, to be very much strictly confining it to the tools. So this is one thing which I would feel that we should also think about, that it's not just that we have to compare the framework with a proprietary another proprietary tool, but it could be even an open source tool which which will nullify those advantages, like there is no licensing required, or it's a venue independent solution for our solving our problem. So I think that will be something which we can even discuss in detail with some of my colleagues in the later stage, maybe in the forthcoming days, and see how OpenFOAM can be made more versatile. And with the coders that are there in the academia, it will be really a good thing to look into this aspect also. Thank you.
Right. Yeah, I completely agree about that. The choice of open source code is not only about OpenFOAM. There are, as you said, SU2, even for both academic and my consultancy project, I use both SU2 and OpenFOAM depending on what is the nature of the problem, what can most accurately solve our results, right? So when we talk about compressible flows and like supersonic problems, of course, a code which is based on compressible formulation of the CFD, which will give us more accurate results for sure. And when basically, even if when we are solving for incompressible flow situations, even if like our Mach number is very low, but if we use a compressible flow solver, we can get closer results. But actually, if we use an incompressible formulation, that is more desired. So in that case, like, of course, it depends on the nature of the problem. But in both the cases, SU2 and OpenFOAM, they are open source. We can look into the code base. We can see what kind of formulation they have implemented in the code and what equations we are solving. Yeah, I completely agree. Thanks, Dr. Day. Can I go to the go to others? Can I ask Arnav that in TCS research you mentioned that you completely use commercial softwares. So in terms of using commercial softwares, what do you think? How these open source tools can complement that?
Yeah, thank you, Dr. Bose, for the question. So, yeah, I did not mention that we exclusively use commercial software. So, it is a mix of the open source as well as the commercial. The thing is, with not only TCS research, but also I'm telling you as a whole in industry, what happens? We generally have less time and we need to deliver the results, right? So in the most of the time there is no time for learning for the newcomers. Okay, so you just need to learn how you can run the software and all, and you need to deliver the results. So let's say if you are doing turbulence modeling and all, so just you click the RANs, this model, and it will automatically give you the results. Now the thing is, I have been in many industries, so I am telling you, there is no time for learning. So if there is a proper training, then people will learn the OpenFOAM and all. And another thing is the support issue, as earlier previous speakers mentioned, that if you are stuck with some problem, you just call the ANSYS guy or the COMSOL guy. They will directly support you. But here we are having these open source forums, this for the CFDs and all. So you just need to post, I'm facing this issue, and someone else will answer it. This is the thing. So, but the problem here is we are facing now. Let's say we are giving some solution to some client, which we are solving in ANSYS or Fluent, ANSYS Fluent, or let's say COMSOL and all, and they don't have the access or don't have the license. How can they open the results and check if they want to verify whether we are correct or wrong? So the thing is, now we are gradually shifting towards this OpenFOAM. So we have started few works on the gasification modeling and some this what I say, this biopharma manufacturing. We need to have some reactors. So bioreactors modeling and all, we started with this OpenFOAM. So for my project also, we have used ANSYS, but from next year onwards, we are shifting towards the OpenFOAM. So the thing is, because this is the open source and anyone can verify who do not have the license of ANSYS, right? So yeah. So gradually, it is people are this OpenFOAM is in demand in industry day by day. I think the scenario is changing, and in upcoming days, it will be more famous.
Okay, that's good to know actually. I mean, good to know this progressive mentality of the industry and accommodating more and more open source tool. So for the interest of time, I will go to our next topic that I wanted to discuss and get views. That's the high performance computing, right? So when we go for more challenging, realistic, three-dimensional problems rather than simple benchmark problems, we need significant computing power. And so I wanted to ask, maybe we can start with Dr. Datta, that because you started a startup on this CFD industry and then you are actually solving more complex three-dimensional problems. So what do you think your need for going towards more and more efficient high performance code base? For example, do you think there is a need for going towards exascale computing?
Hello, Dr. Bose. I think the sound was not so completely audible for me. It's completely my internet
question
issue, I
was
think.
short that because
if I understand,
can you hear me now?
If I understand correctly, yeah, if I understand correctly, your question.
I think there is a lag. So I think once we get reconnected to Dr. Datta, I can go to Saurav. That you showed that you are solving all these industrial problems which are highly multi-physics problems and complicated. And in most of the cases, you are using commercial softwares. So what is your perspective from a commercial software user in a big industry like John Deere? So what do you think, do you have sufficient scalability of those commercial softwares for high performance computing?
Yeah, definitely scalability perspective, and if you talk about the industry needs, first thing, industry needs is the you have to compute the things within a particular timeline. You have a particular timeline, you have to finish within that. Actually, for just adding on the Arnab's comment, actually, if you look at for industry, any program starts, we get 4 years of time. Within that 4 years, we get 1.5 years almost for R&D, and within that 1.5 years, we have to complete all the R&D processes. So that's why, of course, high performance computing is highly essential. Nowadays we are shifting towards the GPU. Of course, for multi-phase flow, multi-physics GPU is not enabled that good still now, and we are working still now for evaluating the GPU performance for of the multi-physics problems, actually. But still now we are working on the these multi-physics problems. We are working on the spray modeling or CFD-DM coupling. We are still working on the CPU side, and yeah, of course, some sort of case for I will say most towards a linear problem in the DEM side majorly. Whenever we look at the DEM side, it's mostly linear, not non-linearity. There is no nonlinearity like CFD that much. So we are scaling the physics towards the GPU side, actually. So some of the cases we are using GPU, some of the cases we are still using multiple CPU cores to get it resolved using high performance computing. So CFD, yeah, single phase flow, if we talk about, or CHT model, any kind of heat transfer model, industry level model, even we get overnight, over day, steady flow analysis. But for any kind of complex multiphysics, still we are not good enough. Even some of the cases on the scalability part of that, or runtime perspective, if you talk about. But yeah, some of the cases we have started using GPU, or some of the cases we have started high performance computing. We are using AWS solver, AWS solver for that, actually. So that part we are working on.
All right, thank you. Coming back to Dr. Datta, can you hear me now? Right, I think he has some connection issues. Can you hear me now?
Yeah, sorry for this. Yeah, I can hear you now. I got the question. I just couldn't answer that time. Yeah, it's a very good question actually, Dr. Bose, because Simulagence is a startup and it started very moderately. Well, I will be very honest here. Basically, when the client says that we have to do with we have a proprietary software at our own and which our R&D guys are using, I don't complain, to be honest, because I know the CFD, I know the story behind. So I can adapt myself. At the end, I have to earn revenue and I have to keep paying taxes. And the other question is that regarding the server, so there is two things here as well. Typically, the companies provide their own server requirements for me. So in that case, either it could be an Amazon server, as I think the speaker just now mentioned, or it could be their own high-performance computing station. So basically, these are all very confidential projects, and I don't even have the opportunity to do it in my system. However, all the European projects that we are participating in, I am putting there as one of the capacity building, as well as to have my own, high performance computers and better serving servers. So in that case, I will be doing all this project. Actually, it's included in the budget. So actually, I will be working on all those using open source, of course. And yeah, this is, I think the push has to always come from the administration or the government in this case. So the EU is trying to push, as you are maybe already aware, that EU is trying to push everything in open source these days. So at the end, probably this will eventually trickle down to the companies. I think this is how it will happen. And also the other thing, whenever I'm building a company, I didn't do many projects actually, but whatever I have done, I've already mentioned, if you do it in OpenFOAM, it will be less, at least 20,000 euros less, and then the company has a chance to choose what it will be. So I'm very open with them myself, not just OpenFOAM. I also open with them, saying that if you ask less money, I will So that was one interesting that we got from Paul Corporation. They said that, yeah, that seems very interesting. We have a high hanging fruit, so not the low hanging fruit, the high hanging fruit. That project, we will give it to in OpenFOAM because the money is less. We don't know when it will be commercialized, the idea. So even companies are now started to think, and as Dr. Gupta rightly mentioned, it's at the end, we have to change the mindset, and the changing has to be done first from us, like us, like you, me, everyone, academia, the startups. We need to tell them that, hey guys, can we do it in OpenFOAM, or can we do it in open source? Why just OpenFOAM, open source? There is Phoenix, for example, which is the version of COMSOL, which is open source. And these are things actually timed. It will take time. I know that at the end, we will reach our destination, I think, at the end. So yeah,
It's
these
a very
are
good
just
point.
very
I mean,
honest.
that is a good point that we need to take care of. I mean, for example, University of Birmingham, all the undergraduate CFD courses, they, as of now, they teach using ANSYS. And and that is because of user friendliness, and they think that one third year undergrad student who has like 10 courses, and if they have to learn CFD and within the limited stipulated period of semester, they do not have time to get over the learning curve of OpenFOAM, which I'm trying to prove them wrong. But then how do I make a case? It's exactly the same thing. I kind of am trying to make a business case to them that how much money do you save annually if we implement OpenFOAM to teach all the undergraduate CFD courses throughout the university. And it's a big school in the UK. So you can imagine how many number of students. So as Dr. Datta mentioned, that when we do a project, we have to do a cost estimation. So can we make a business case that if we use open source tools, of course, we know better, we know completely in depth what is happening, but apart from that, everything comes down to money, right? So how much money we can save in terms of the cost of licenses. So very good points, insightful points to think about. I think the next topic I want to go into is that, as some of you mentioned, that the responsibility, which is very much important factor here. So, and I was surprised to know that the commercial support system is so good. As you are telling that if you have a wish list, next day morning I want to add the complexity, and you call and whatever commercial software team, and is it a reality that you get the solution immediately within couple of hours, or what? Yeah, can you share your views on that?
No. Hello.
Yeah, it's well, see, if we are as an engineer, we are making a mistake setting up the CFD problem, then the solution may come quickly that you are doing this wrong, you need to do it this way. But if it's actually not capable, and if it's a feature that they need to implement, that's going to take about 6 months to an year, which is not even tracked. Okay, they just on a support ticket, it's just promised they are working on it. It may come out in the next version, or it is in testing. It may come down 2 versions down the line.
Right.
So yeah, it's not as quick.
Yeah. So coming to that point, if we focus on you guys, right, the startups, the companies in India. So, and if you are trying to percolate into these open source tools and try to implement or use it, for example, one is GUI option, which already FOSSEE team is working, and there is a collaboration, and we are trying to go there. Of course, it's not very easy. Okay, we need very much skilled experts in that particular domain to do that. So now, from the FOSSEE team, what can we do, or how can we kind of collaborate with you if you are trying to implement open source tools or OpenFOAM into your startups, in your companies? What do you think should be the way for us to help you, or how do you, I mean, what is the way you think is good for you to approach us? And we cannot promise anything because it's a limited resource. We work with few student interns, but I mean, it will be good to know from all of you, even including those who are there online, that what is, if you have any proposition in this regard? Yes, please.
Hello.
Oh, right. Yeah.
I have few proposition I think, but I don't know how much implementable is there. So as Manish has rightly pointed out, the MSME sector and the law, they have no idea about this, or they cannot afford to begin with, at least to create an impact. We need not to start with the biggest clients. We can start with the small clients. We can offer them, and their resistance would be less because they have no background idea. So through FOSSEE, we can start offering, we can, so the industry partners can connect to the MSME, and they can offer that, okay, solving your problem through OpenFOAM, which will be cheaper for us also, cheaper for you also, can improve your life. That way, if we can start bringing the people to this, some of them may give the small amount, some of them may not give any amount, but at least bring some problems to the from the industry to the academia. Student can learn based on those actual real life problems, and those who are able to give money, that will be able to sustain to some extent the operation of FOSSEE and this part. Another thing is some bigger client, they can for the means we can make FOSSEE as a central place. Okay, you want solution to your problem. These are the companies unlisted with us or the startups. If you have any option to preference, or we can leave it to open to all of them to respond. Those who can meet your specification criteria can do in this payment basis. So that this ecosystem needs to be brought that can work out.
Yeah, I would like to highlight a root cause of this problem. This is, overview solution, but I would like to highlight a root cause. So many of you know the ANSYS. How do you know the ANSYS? I know, I'm telling you. So what exactly the cause of this problem is, the ANSYS approach the institute and how CFD engineer is built from the institute, right? He's get to know from the CFD from the institute. And that time, if you give something OpenFOAM introduce as a start, right? Then only he can, we can introduce OpenFOAM, because ANSYS, what they do, they give, the free software. And once your student get addicted to the free software, then simply they play the game. That's how it is, how the business works. So what we can do here is we can startly implement the OpenFOAM to the institute level. So student will get, because at the end, OpenFOAM who will handle the student who is learning in the institute, right? So he should know the OpenFOAM first. So institute is the first cause where you can, break down your root cause. Second is, as I told, industry, right? The small MSMEs. Here you cannot directly approach them. You also need to, show them some biscuits in terms of, let's say, one month free software or the free service. That's how the business works on the ground levels. So that's what my
Right. Yeah. I mean, very good points. One, I completely agree with you, and I have a proposal, and we will discuss and we'll see. So we already have case study project in OpenFOAM. We can start something on industry case studies, where we, with the help of you, who are actually working in the real field using CFD, you can approach us if you know some of the SMEs, or from your end, if you have a challenge that you want to test out, and approach us with a problem statement. We can then find the best resource to solve that and make a case study and highlight it from FOSSEE website. Okay, so that is something I was thinking that, of course, it will take time to build on it, and we do not guarantee success of it, because we do not know whether we will have sufficient skilled resource to solve that problem, because that might be a very, I mean, if we ask a big player, they will come up with a problem which is a 2 years project, right, which needs to be funded. So, but immediately we can break it down, and we can actually do summer projects, semester long internships with the students to solve those problems as a balance of academic problems and industry problem, and can start with few industry case studies per year and see how it is going. And as you said, the company, if they are happy to fund the student for that, there are so many talented students who need some stopgap till they get the correct job after their graduation, and FOSSEE tries to support them through internship and train them, increase their employability. And the industries, we are very much open to the industries to come forward and fund that student to solve or try to attempt solving the challenges you are facing. Coming to the institute level, as we have already many projects, so we are doing research lab migrations. We are approaching all the particularly regional scale universities, and we have many faculty partners, including Professor Dheeraj, and we have Professor Naren and Professor Hari Krishnan. So I'll go to them in a moment. So we are trying to reach out to particularly to the regional institutes where there are lack of resources, so that the faculties can be trained, that the faculties can start doing some research using open source tools, because they do not have sufficient resource to buy ANSYS licenses, etc. So we already have these things, and we already which is not very active at this moment, but we can also reinforce our textbook companion project, where we can we can motivate students to solve their CFD textbooks problems using open source tools, and then create that resource list, which can be then given to the institutes, as you mentioned, for training. Like it can be a resource list for the faculties to train their students CFD using open source tools. So these are some ideas. So can I ask Professor Naren and Professor Hari Krishnan, if you are with us, can you please switch on your camera? And probably you can kind of tell us a bit more about this lab migrations or the activities that you have been involved with FOSSEE.
Thank you very much, boss, Chandan boss. Am I audible?
Yes.
Yes, thank you very much. So far, as I said, I'm in the academic field. So I'm working with FOSSEE for last 5 years as a student intern, like not student intern, as a student who submitted case study project in 2009 when I was doing PhD. Then as a faculty, I started mentoring also students. So mainly what we essentially do is through internships, mainly summer internships, we will give certain cases. We will give certain research papers in which the students will be within 2 months or 3 months time, they will be validating certain part of the research papers, etc. Okay. So basically, we are actually giving certain skills related to OpenFOAM to students through these activities. So along with that, I would like to share a few things. So as far as I understood from this discussion, we have people from different varieties of industries, starting from automobile, rail, ship, air, space, and biopharma processing industries, etc. What I understood here is basically the industries which are having fund, they are ready, they are happy with commercial softwares. But those small startups or those who are lacking fund, they will be planning for open source alternatives, right? So what Gupta was cited was very interesting fact. Whenever they look for people, skilled people, unfortunately we don't find skilled people. Let's say some small company want a person who is having expertise in open source software, then we rarely find good candidates. So out of 1,000, he was able to find only 1 or 2, right? So what we can do here is we can identify, along with the help of industry, as a FOSSEE team and academic institute can identify certain trust areas, as he was cited, industrial case studies. With the help of industry, we can give some certain trust areas in which we can train students, or we can make case studies, we can do research migration projects, etc. in those trust areas, and we can make skilled people in that area such a way that when companies look for resources in that direction, they can easily get good quality students. So to cite one simple example, as Dr. Joseph was citing in his presentation, they were doing IR class, various simulations related to IRS, etc. So there are certain things like ship maneuvering, all those things. So they essentially do, we can give some certain items which are related to, as he said, certain problem statement he shared. So similarly, each industry person or each industries, they can share certain standard benchmark problems. Rather than focusing on very academic or pure research problems, we can give research statements or research problems for interns in that direction, that will be much more better. So within, as Sanjandan was citing, within 1 or 2 years, we will be able to make skilled people who are having good skills in OpenFOAM. Slowly, we can say industry will be also ready to take those peoples. That's my take on this.
Thanks, Hari Krishnan. It's a lot of insightful points. I think I'll go to Advait. You wanted to share something.
Right. I just want one very specific help because I think if there is any community of OpenFOAM users as big, then it has to be FOSSEE, relatively speaking. Despite that, if you could put on your website or in some manner, all the potential OpenFOAM job seekers, students who know OpenFOAM and they are looking for jobs in the field of OpenFOAM. Now, many of them will learn OpenFOAM as a matter of fact, but they will not end up doing OpenFOAM for the rest of their lives. They will end up doing the same ANSYS work. But then there are still people who want to continue their careers in the field of OpenFOAM. So my company personally would benefit heavily if that database we can access of students who know OpenFOAM with proper marking, beginner, intermediate, advanced. And I think IIT Bombay or FOSSEE team is a perfect place to judge what is the level of expertise there.
Right. I think the one certification that FOSSEE provides when a student completes a semester-long intern with one of our faculty member or faculty support team. I personally have guided around 6 to 8 semester-long interns, and they're more on. I started. We have to take a leap from the very basic to complex problem, and I think I mean, I'm fortunate to work with these talented undergrad students who are actually in the right motivation to try these things. I mean, we do not be afraid to get failure, get errors, get whatever, but we want to try some challenge and try see if we can do it. But as you said, I mean, those kind of categorization is where it's a very management heavy job, right? So we don't
Fine. No categorization. If you can just at least
So I
provide a
think
list of
the students, if they produce a certification, let's say they have worked with us for a semester-long project or a summer internship, I think that's a kind of tag that you can understand that they have worked on an OpenFOAM heavy project with one of our colleagues. So that kind of certification, I think, is making change. As Professor Kannan said, that with those certifications, people are getting internship, people are getting academic positions outside, etc. So I think that can really help you. But personally, yeah, we can advertise your openings on our FOSSEE website. So that's not very difficult. So yes, we can do that. Thank you. Yeah, coming to Dr. Datta, did you want to share something?
Yeah, hello, thanks. Well, Dr. Advait Gupta already summarized those points and also the other distinguished members here. Just I want to give, because of the fact that, after staying 15 years in Europe, I came to a very interesting country, Turkey, and I see a very interesting environment here. Let me share something from here, which might be even helpful to some extent for our country, India. What we do here is basically they're trying in Turkey, on the record, they're trying to develop a pool of talented students, and they're grading them as per their competence levels. So there is a certification program where they are trying to grade them at intermediate, proficient, middle proficient. So these are the talented pools where database exists, and companies like TUSAID, for example, or Havelsan, Aselsan, Armelsan, these are all national companies. Turkey is very advanced in drone manufacturing and technology. You might already be aware of that from the Bayraktar group. They are all hiring people from this talent group. And this is the job of us academicians. Currently, I'm in Turkey, so it is our job to develop this talent pool and provide it to the national level. Number one. Number two, Technofest. I think you are aware of that. This is almost 10 years now. Turkey is organizing Technofest. It is world-class program, amazing. It happens across the whole country. Every year, particular cities organize this Technofest, and you cannot imagine the enthusiasm of open science in that. Open science, not just OpenFOAM, open science, and it is all reflected starting all the way from their school level. So this is the way this country is progressing, and I think it is interesting to just share this idea. I'm not saying to copy, just to get some inspiration from that. Number three, and that's my personal experience, is what are we trying to achieve in OpenFOAM? We are trying to achieve the fact that we can handle the inside codes of ANSYS or CFX or anything else, which we cannot see, right? Those are hidden from us. So while we are achieving the inside story, we are missing the outside story. Outside story means the user friendliness. We are missing the user friendliness. What we need to do, and I think FOSSEE is working on that, but it needs to work more. Sorry for this, but I have to be a little bit critical here about FOSSEE. It has to speed up the process of the mirroring of ANSYS, or in that case, the mirroring of these commercial licenses. The more they mirror, people, old people like us, you know, I consider myself old comparing to all the youngsters out there in my university. I will be also using more and more ANSYS because it mirrors my study, what I did with Dr. Ranade many years back. So this is the whole point. We are working to show that we can look inside the codes, but we don't have the reflection of the things that we have in mind. So there is this missing gap. I personally, this is my point. And from Turkey, let us learn to develop a talent pool, a database, a proper database, probably from the government, probably from FOSSEE, doesn't matter, but with their very specific competence levels mentioned there. Organized Technofest, as I think you are mentioning that you did this Olympiad, or I think Dr. Gupta mentioned Olympiad. Very interesting thing. Technofest is an idea. And as a startup, I'm ready to even pay internship fee to the students to get into working with me, but of course with an NDA signed, because I don't want to disclose this to the outer world. And that much of that much of things, and when I'm ready to pay that money, why will the students? I'm not getting students. Just like Dr. Gupta, I'm not getting students. While I have a band of Turkish students coming with me. Hojam, I can work with you. Hojam, I can work with you. Hojam means professor. Hojam, I can work with you. And they are all really super smart guys, you know. The only thing is that their English is a problem. Where in India, English is our advantage. So look how we can even go beyond the situation. So in that case, let us get this opportunity. Try to build up a pool of talented students, really talented, I mean really talented, within inverted code. Something like Technofest, and of course the national strategy to mirror ANSYS as much as possible, so that even old guys like us also start, you know, TCS, the Mr. Chakraborty from TCS, we all start, okay, forget about ANSYS, we all work because we remember the picture of ANSYS through the OpenFOAM. That's all, my 3 points. Thank you.
Right. So I think we are ending almost to the end of the event, but I'll go to Saurav. Saurav, you wanted to say something?
Yeah, so I just like to cover a little bit on the means industry collaboration when you are talking about the industry collaboration and the opportunities, how we can collaborate about the industry with the industry and how we can resolve critical problems. First, let's target the something like low hanging fruits. What I have seen actually from my past experience, actually, many people give and try in OpenFOAM, but they have started with a big problem and high hanging fruits, but ultimately the entire journey got stopped actually. So first start with the low hanging fruit, and if we definitely have the GUI, there are many other GUI like for OpenFOAM, we know I mean for I majorly use the lights. So lights aesthetics is a tool we use sometimes for GUI. So if we FOSSEE can develop some GUI which is user friendly, I think same in the same line with Dr. Abhishek Datta. So if we can bring the GUI and we can tackle the low hanging fruits first, we can win the confidence of the industry. Then only we can step up and slowly we can move ahead. So that's a part I think need to look at. Maybe initially let's tackle the low hanging fruits and get the confidence. That's my point. Yeah.
All right. Yeah, a lot of insights and lot of things to introspect from our end. Yes, please.
So yeah, one more point just to end is if we take on some industrial problem, then our duration we should increase for the students, because 2 and 3 months is a little bit less, I guess. So it should be one complete semester, 6 month
We,
project.
we do semester long and year long co-PIs for the entire thesis. We do it with many IITs. So we are open for that.
Yes, sure. And I mean, even we have some semester long projects, even
But that
FOSSEE
is,
too.
yeah, but that is for 3 months.
Yes. So I think, yeah, I mean, we can discuss it in a more in-depth level depending on the availability of the funding. We are all limited by resources. So that's the only thing, because we pay the interns in some sense, right? But yeah, so that's a good suggestion and we will surely ponder on it.
And one more point is that sometimes industry is not very open to putting our solution online. So that should be an open culture should be there from the industry to adapt.
Yeah,
Because
that's where we need more conversation. So the industry should not think us that we are looking to solve their problem for themselves as a consultant. So doing a consultancy is a one thing which I can do individually myself, right? And the industry, many industries is ready to pay me consultancy fee. Of course, with my university affiliation, the university takes its overhead. But then again, the motivation here is not to engage in those activities as a consultant from FOSSEE, but to solve those challenges in a more inclusive manner. Of course, there will be limitations, like here all in your expert talks. When we invited you, we wanted to make sure that you do not share any confidential things of your company, but you can share your broad perspective of it, where in which direction computational fluid dynamics is going. So for example, I mean, we can, with the dialogue with the industry, they might not give us the actual CAD geometry, or they might not give us the actual know-how how they're designing, but they can bring it down to a simple modified case study, which can then help them to build on, right? And which can directly show what will be the expected application of that know-how. So, and of course, outside India, as Professor Datta mentioned, that we have the culture of signing an NDA, no disclosure agreement, which is to build on trust between the academic institution and industry. We have to talk through it, how IIT system works, and I think a similar mechanism should be also there. So if some students are directly working with industry, IIT Bombay as a FOSSEE can sign NDA with them so that the trust builds on, and etc. So there are multiple mechanisms, but the way is to not to act as a consultant. So my view, particularly, of course, everybody's perspective is different. I think as far as I understand, Professor Kannan also shares the same view that FOSSEE project is not a consultant to individual industry. So we are here to promote the open source knowledge, and it is not basically exploiting open source tools to make their own in-house code. And I'm completely against that view. Very much openly. So if it is open source, it has to be open source, it has to be free, it has to be taught free, and that's why this project in place, and that's why we are here. So I think with that, we are towards the end. I just want to kind of give a hint that most of you may not know that we organized the first UK Indian OpenFOAM Symposium in last summer, which was very successful, and the first type of gathering of like-minded people. Mostly it was academic in the first place, but we are discussing with multiple faculty members in India and different IITs and FOSSEE, of course. So if it happens again this year sometime, it will be hybrid, but I would very much would like you to participate and come with your own views from industry, present to us, present to the students, and then these dialogues can go on further. So with that, I think I will close this panel discussion here, and thank you for all your insightful comments. And we need a lot of time personally to reflect on that and think about that, and we can discuss some major take home messages from here in our first advisory board meeting. Thank you very much.
Thank you so much, Professor Chandan. Hello. Thank you so much, Professor Chandan, and all the panelists. So we have come to the end of the panel discussion. So I would take another 15 minutes for all of you. So as the next thing to go ahead, I'll call my team member, Mr. Diptanshu De. So I think if, you'll be delighted to know that FOSSEE IIT Bombay is also developing the GUI for OpenFOAM software. So we have the team members, Mr. Rajdeep Adak, he's working from the US, he's doing masters there, and Mr. Diptanshu De. So Diptanshu will show you some of the demonstrations, some basic demonstrations which he has come up with. Okay, so Diptanshu, please come on the stage and you can present from here. From there you will want to present? Okay, okay. Okay, so he is there, he is presenting from there. So camera. Zoom in, okay.
Hello everyone. Is there an
Hello. I'm audible, right? Okay. So hello everyone. I'm Diptangshu, and I'm working on developing a GUI for OpenFOAM, and the current version of this GUI is based on Blender, because Blender is a screen. If anybody is not aware, Blender is a 3D software, and it has excellent meshing capabilities, and it is also open source. So with the help of Blender's Python API, we are able to make an add-on that would help us to generate block mesh files, and uh, we cannot and it eases the process of generating the OpenFOAM case files for us much easier. So the current state of the add-on is that we can generate block mesh direct files from it, and I'll be showing a quick demonstration here by making a basic Venturi tube. So in my screen you can see this is our panel for our add-on, which is called Venturial. We can select our case directory. Here I will select a directory called GUI test here, and it automatically detects the case name. So since the parent name is GUI test, the case name is set as GUI test, and the mesh directory is block mesh direct. If we want, we can change the directory of the block mesh direct file to somewhere else. Right now we'll keep it as defaults. So once we have set the case directory, we can move on to the next part, which is actually manipulating a geometry. So this add-on currently is being developed with academia in mind, and its primary use case would be to educate students on how OpenFOAM works actually, and how each of its meshing utility works. We will add more complex meshing capabilities later on, but currently we are generating geometry in such a way it makes it easier for any students who is learning OpenFOAM or learning the block mesh dig tool. It makes it easier for them to understand. So here, to generate a geometry, we will have to select, we will go to the geometry tab in the panel here, and we will select the number of blocks that we want. So in my case, in this Venturi tube, I want 3 blocks. I will enter the number as 3, and each block will be a hexahedron, and it will be entered in the grid space. So I will click generate blocks, and you can see 3 blocks have been generated. Here, using Blend, this panel is using Blender's inbuilt meshes to generate the geometry. It is suggested to make the meshes using the panel and not from the Blender's inbuilt add mesh features, because that makes it difficult for the add-on to detect the geometry. Now, once the blocks are added, we can edit each of the blocks as we want. So let's say if we are modeling a Venturi tube, it can go like this, and let's just make it a slightly bigger. Here. So here I have my shape for a basic Venturi tube that I want. Okay. Then to start my processing on it, I will just select everything and I will first compose the mesh. So what it does, it instead of it being three different meshes, it composes everything into a single mesh. So if I just remove this and I will just undo this operator. Oops. Sorry. So yeah, as the add-on is still in the development phase, so there are some instabilities that cause this bug. Just a moment. Here. So as you can see, currently each of these blocks are their own separate geometries. So in order to start working on this and generate a block mesh dict file for this geometry, we will need to compose this, compose all the geometries that are present. So first we will compose them, and then we will get the vertices that are in this file. Then we'll get all the blocks that are there in this file. So here you can see in this list, in this view, all the blocks that are present in this geometry is listed down here. And right now, for the grading, I have by default values are 1, 1, and 1. If I want to change my grading, I will just delete all the selected blocks and I can give some custom values. Let's say 10 along Z. And then if I generate the blocks, you can see the blocks are generated, and the data is shown here, which is analogous to the OpenFOAM code. So hex and the list of vertices, the grading that I'm using, and the number of cells. So moving on, after this, we can assign the boundaries to each of the faces. So for that, we will have to go to the face select mode, and I will just select each of these faces and assign a boundary. Assign a boundary type to each of these faces. So let's say this will be my inlet, which is a patch. This will be my outlet, which is also a patch. And you can see as I'm adding the boundaries, these are those boundaries are being listed over here. So if I select these three, and I can make it as top wall, which will be a type of wall. These top walls are added. I will add a bottom wall, and the rest I will list as side walls. There. So all the boundaries has been defined over here, and we can finally exit the face select mode. And now basically our mesh is ready to generate our block mesh dict. So before I generate the block mesh dict, I would like to also point out that we have a few visualization features right here been built in the add-on. So for example, we can visualize the vertex indexing that is going on here. So we can see that which vertex have been assigned which numbers according to the OpenFOAM, according to how OpenFOAM processes data. We can change it to see the coordinates of the vertices, as you can see. And if it's better, we can just change the color to see it better. Yeah. So these are the different tools. We can also check the boundaries that we have defined over here. And a few glitchiness is there because it's still under development, which will be fixed in the release version. So once my mesh is basically ready, I can just generate my block mesh dict. And yeah, it's generated. Block mesh file is generated. Now I can just show you. So in the explore, GUI test was my case file. If I open my file manager here, you can see the block mesh dict file is generated, and this is how it looks. It has generated the complete block mesh dict file, and if I want to open it in ParaFOAM by ParaView, I can do it right now by I will just copy this and paste it in a already built OpenFOAM case file. So I'm just reusing another case file over here, and I have my OpenFOAM environment open. So I will just run the block mesh utility. Sorry. Here. So before that, let me just show you. Here, this is the block mesh dict file that I just generated. And now if I run the block mesh utility, it executed all fine. And if I run parafoam now, apply, you can see this is the same geometry that we created before. Now here it appears vertical because of the axis orientation. And as you can see in Blender, the default by default the x and y plane is in the horizontal direction, whereas in ParaView the x-y plane are vertical. So if I just rotate it this way, you can see that the mesh is generated all right. And if I just change the view, you can see that even the cell distribution, the grading is also displayed all right. So this is the current state of the GUI that we have built. Moving on, we will the upcoming features that needs to be added are capability for edges and all. And yeah, that's the current state of the OpenFOAM GUI. Any suggestions that other professors might have regarding this software are always welcome.
Yes, you can always reach us at CFD, contact@cfd@fossee.in. So I would request our senior manager, Ms. Vinita Parmar, to please come on stage and share a few words about FOSSEE. Okay, so she's already there. She'll log in and she'll talk about FOSSEE and the endeavors that are going on.
Take one over. I'll come there. Firstly, good evening to everyone. Myself, Vinita Parmar, Senior Project Manager at FOSSEE. So Payal is someone who looks into CFD. I'm someone who basically looks into Scilab and overall FOSSEE activities. We also have, oh, share nahi kiya maine, sorry. Yeah, so I'll not take much of your time. I just didn't want to miss this opportunity since everyone is here. We are actually looking for, we have many softwares, Scilab, Python, eSIM. eSIM is something which we have developed from scratch at IIT Bombay. Scilab is equivalent of MATLAB, everyone knows that. And eSIM is for electronic simulation and circuit design. So we have made this software at IIT Bombay under guidance of IIT professors, which uses ngSpice, KiCad at the backend. And we have merged those softwares and made it for electronic simulation where the circuits are simulated. We also have something called OSDAC, which is used for steel structure and design. It also creates a graphical interface. It uses Blender and Python, but it is mostly for civil engineers. We have DWSIM, which is equivalent of, sorry, I forgot. But it is used for thermodynamics and, wait, I can see here and say, yeah. No, it is, uh, Yeah, it is used for chemical process simulations. I have it in mind, but I don't know. Aspen, yeah, Aspen. So yeah, we use that. OpenFOAM, you all know. So these are some softwares. We also have R, Open Modelica, and GIS is there, where geographical information is there. Focal is basically the blend of 2D, 3D animations and infographics. We use ink, GIMP, everything. Soul is also there. Basically, in FOSSEE, we have many activities where students and industry people can contribute, get a certificate, get honorarium. It's kind of, they can do a part-time work kind of thing and also gain knowledge. So we have different activities in different software. We also conduct workshops and conferences. So if you go here, something amazing we have is internships, where everyone is looking for internships. So already Dr. Bose has said that we have semester-long internship, which we'll be launching soon. Maybe in December, we'll start the registration. We take students for one whole semester. Although we say it is for 3 months, but the students get so much involved and they like doing the work so much that they continue almost for 6-7 months with us. So I officially we say 3 months, but then depending on the interest of the students and the work we have, they actually continue. So right now, winter internships is going on. And what we have seen is our students actually, uh, once they come here, they actually, particularly in OpenFOAM, I have seen that students from colleges, they do come, they don't know what OpenFOAM is, they don't know, but they are interested into computational fluid dynamics. So we have spoken tutorials. For each of these softwares, we have created our audio video tutorials where they can do learning through side-by-side method, which is a hands-on experience to them. So through this audio video tutorial, they easily learn the software and then they perform this task and submit it to us. Also, while performing these tasks, we are not judging them from their academic point of view. We are actually telling them, if you're stuck also in this task, we are there to help you. So basically, FOSSEE gives a platform to, kind of get more people in the core area. And we are actually looking for people from industries in different software, particularly eSIM, because electronics is a big market right now, and many SMEs have just started. So if you have friends or colleagues in these areas, do let us know. CFD is very close to Scilab also. Wherever Scilab can be used, like if you're using MATLAB, I would suggest explore Scilab. And you can contact me directly for Scilab. I do get in touch with my team. So basically, the point of coming here on the stage is just to tell you that we have different softwares and we are looking for people like you in other areas also. So please do be connected with us and let us grow this family. Thank you.
Thanks a lot, Vinita. So I will call our senior manager, Ms. Usha Vishwanathan, to please conclude the session with a vote of thanks.
Good evening, all. So I'm very happy to stand in front of you and propose a vote of thanks to you all. And first of all, let me thank all the panelists, our faculty partners, and the industry experts who came today, take their time off and spent both the in-person as well as online. So I thank you all. And next, I would like to thank Professor Chandan Bose and Professor Jenny, who actually has taken this mission forward. And we really are now doing wonderful job in the OpenFOAM CFD scenario. And I would like to thank Professor Kannan, who is actually the guiding light and the force behind all the work which we are doing. As Vinita has told that we have a lot of other software which we are promoting. And definitely we thank him for his guiding support. And I would like to thank the spoken tutorial team, the FOSSEE team, and the CFD-OpenFOAM team, especially under Payal, who has actually put forward this idea and come up with this wonderful event. So thank you, CFD team. And I would like to thank the studio team, who is actually doing the live telecast of this on YouTube and doing the recording and taking the photographs and making this event a memorable one. And we will be definitely sharing the photographs in the future within 2-3 days. And I would like to thank the funding agency, Ministry of Education, under the National Mission of Education through ICT. That is the mission under which FOSSEE comes. So we thank the Ministry of Education. And thank you all for making this event a wonderful one. Thank you.
So we will say a thank you and bye-bye to all the delegates who are there with us online. Thanks a lot for being with us today. And please stay connected. If you log into the FOSSEE website, FOSSEE that Vinita just showed, there you will find the contact info. Okay, so any kind of contact, any query, I mean, we welcome even the most silly queries as well, because we are open for the students, we are open for the academia, we are open for the corporate. So please stay connected and let's work together. Thank you and bye-bye. Okay, so just 1 second.